And of course, we all understand that it offers lots of opportunities, but as well challenges. So we need to understand how AI can support aviation, but how it can do it in a safe way. EASA has been working now for several years on this topic, as you know, and I will go very high level through the things that we have done, but then Guillaume will go in detail through all the things that we have done and what is coming next. I was talking to Guillaume just now to understand how we were compared to other regulators in the world, and we are very honored to have the FAA here today. We could say that EASA is leading the way in this area. We are very proud as well to work with all of you, because this is not a topic that one single partner or a stakeholder will crack. I mean, it requires the cooperation of industry, regulators, academia, researchers, basically the whole spectrum of stakeholders. So again, thank you for being here and for helping us to move this agenda forward. We started basically the journey with some concrete use cases in the area of research. In particular, as you know, or you may know, we have these innovation partnerships projects, IPCs, which basically is a contract between EASA and a company that is bringing forward some kind of innovation or new concept, where we work together and learn from each other in terms of how we bring this forward. And in particular, in 2020-2021, we investigated two CODAN IPCs, innovation partnership projects, around computer vision-based runway and traffic detection applications with a Swiss startup, Daidelian. Sorry, I can't pronounce this one, but you know who I mean. And I did ask Guillaume before, but I just forgot. So anyway, this company. And this project brought very fruitful learning and expertise to complement EASA's development assurance expertise, giving shape to the W-shape learning assurance process that was developed in the first issue of the EASA Artificial Intelligence Roadmap. Then in 2022, we explored the formal verification methods for neural networks for systems health. So basically to support maintenance and through artificial intelligence to monitor these applications with Collins Applied Research and Technology in an IPC called Formula. More recently, in 2023, this project is ongoing. We have been moving towards level 2 of artificial intelligence, which basically we are teaming up with AI. And then we are investigating the auto taxi, so basically from gate to runway with Boeing as part of the Beacon IPC. So again, you can see how interesting all these applications could be, and the use of AI can facilitate processes, but as well, you know, normal operational aspects of aviation. Then we have done as well on research with Horizon Europe, the NLEAP machine learning project, which Xavier has been leading. And this is a very, very interesting project that you will go in detail tomorrow, because there is a whole day on machine learning. So I'm not going to say much more because I want to steal your thunder. But yeah, there will be so many applications from ACAS anti-collision system to natural language processing, camera-based automatic inspection, and support aircraft maintenance activities. But as I said, Xavier will go in detail through all this tomorrow. But we haven't done just research, and actually we have done some more concrete things that now are leading us to the certification area. So we have started to go through some AI in aviation certification projects, starting with general aviation, because we want to build from a simpler base or simpler aircrafts to then build into CAT, large aircrafts, and then apply the things that we have learned with the general aviation sector. So in this, basically, we learn to publish the first AI special condition, what we call SCAI-01 in 2022. And then as well, the first EASA AI paper was based on these learnings. Now we are currently working to update this special condition to extend to other type of products, as I said, to large aircrafts. So this is work ongoing, and I'm sure that you will go through it in more detail. However, there is a common denominator to make all this happen, and this is the need for an AI trustworthiness framework. So basically, this is the link to all the things, and this is the one that we have to basically figure out and develop. The EASA AI concept papers will be consolidated in the starting rulemaking task 0742. Again, these are lots of numbers, but I guess soon enough you will know this one very much in detail, so keep this number in mind. More in concrete, talking about the event, we have 2 days, today and tomorrow. And the first day, we will be talking about the EASA AI Roadmap and framework consolidation. So basically, we will talk to you about what we have done so far, where we are today, and what is coming. And as well, some timelines, because people were asking yesterday, when is happening what, when are we going to see the rulemaking? So again, Guillaume will go in detail through all these things, because we understand there is a push, especially from industry, to get all this done and basically move into a more practical way to apply AI. At the end of this process, obviously, the rulemaking plan will be launched, and we will include as well the aspects of ethics, which of course are one of the most important ones, and our colleague Ines is leading on that through her PhD. Tomorrow, we will be talking about the machine learning MLIP research projects and the final dissemination event, and Xavier will be leading on this. And as I said before, he will explain all the findings of these research projects and how we are going to implement and disseminate with all of you. So basically, we want to share everything that we found there. I want to thank as well our colleague Peter, which is leading the scientific committee, which is a very important forum where we are engaging with academia to get their views, not only in artificial intelligence. We are doing other things like the impact of weather changes and climate in aviation, which, as you know, is another big topic. And we are seeing just recently another turbulence event that caused some injuries in an Air Europa flight going to Latin America. So basically, very important input from the scientific committee to understand as well, not only what happens for AI in aviation, but as well in other sectors. This is very much cross-sectorial, and actually in Europe, we're following the European law on AI, which is cross-sectorial as well. So we need to learn as much as we can from other sectors, from other regulators, from industry, from all of you. Okay, so I think I'm going to stop here, and I just want to encourage you all to use these 2 days to exchange information, to ask questions, basically to make it as meaningful as possible. And of course, we will follow up on all this. So with that, I will pass the floor to Guillaume. Thank you very much.
So our next speaker is joining us remotely, I believe. Yes. And so Guillaume, if you're just setting that up. So we're next going to hear from the Commission, so from Antoine Alexandre André, who will give us an update on where we are from the regulatory side. So welcome, Antoine Alexandre, and over to you.
Good morning to everybody. I hope that you can hear me and see me properly.
Yes, we can see you, Antoine Alexandre. Thank you very much for joining. Just trying to put the slides next to you. That's done. So the floor is yours. Thank you for participating with us today.
Thanks, Guillaume, and thanks, EASA, for organizing actually this event in such a crucial time. I think AI and the AI regulation in Europe is on the lips of everybody, so it's great actually to be able to present it, to make a focus actually on the aviation sector, and then for you also to discuss it in today's and tomorrow. If you can move to the next slides, I will directly start. Super, thanks a lot. So today I will, as very briefly mentioned, I will explain very high level actually the content of the legislation, but focusing really on these specific elements that are important for the aviation sector. I will also clarify some elements of the interplay between the European Commission and EASA, so that we are all clear on the next steps and the future requirements that will need to be complied with by organizations in the aviation sector. My name is Antoine Alexandre. I'm part of the AI office in the unit in charge of the legislation process, but now also in charge of the implementation of the rules. We have been actually negotiating this text for the past for almost 5 years. It was a long process, but I think the journey has only started now that we have to move towards the implementations of these specific rules. Next slide, please. Thank you. So this is probably the most well-known slides when it comes to the AI Act. These slides try to capture actually the essence, the objective of the legislation in one visualization. And this visualization is this pyramid that you can see on the left-hand side. Actually, what the AI Act wants to achieve is to protect citizens, to protect consumers on the EU internal markets against the risk to health, safety, and fundamental rights that AI system may pose. And so from the very start, the Commission, and then it was also supported by the co-legislator, the Commission decided to propose this pyramid approach with specific requirements to these systems that pose specific types of risk to health, safety, and fundamental rights. If we start by the baseline, by the green parts of the pyramid, actually the legislations for those AI systems that do not pose any risk to health, safety, and fundamental rights, the legislation do not impose any restriction on these systems. And when we actually introduce and publish the proposal for this legislation, the Commission actually determined that actually 85% of the AI systems put on the internal market would fall under this specific category. Then if we move one step higher, if we move to the yellowish category, these are actually a category of AI systems which includes those systems which interact directly with humans. What we want here is to protect actually citizens, protect consumers, making sure that when they are interacting with an AI systems, they have enough information and they know that they are not interacting with another human, but that they are directly interacting with a machine. Then, if we move again one step higher, we enter into the core of the legislation, which is the high-risk category. There, the use of AI systems that falls under this category would fully be permitted, but these systems falling under this category will be subject to compliance with specific AI requirements, which are set out in the legislation and on which I will spend a couple of seconds later in this presentation. And last but not least, for those AI systems which are considered as posing an acceptable risk to health, safety, and fundamental rights, they are simply prohibited to be used or put on the internal market in the European Union. So as a first step, as organization being involved in the aviation sector, actually the first step for all of you would be to identify the different types of AI systems or general purpose AI models that you are using. The second step would be to directly encounter whether you are falling in one of these categories. And for this, I will enter into the details of each of the categories. Next slide, please. So for the last parts of the pyramid, for these systems which pose unacceptable risk to health, safety, and fundamental rights that are purely and simply prohibited, these systems cover the following areas which are depicted on the slides. They covered systems which would be used for social scoring, for public or private purposes, for biometric categorizations in specific contexts, for real-time remote biometric identifications also in specific context, for individual predictive policing, or AI systems used, for instance, in emotion recognition. So here, if your organization is developing and deploying systems that fall under this category, that fall under these areas, they will simply be prohibited to be used on the internal market 6 months after the entry into force of the legislation. So 6 months starting in August of this year. Next slide, please. Now, if we enter into the second category, which is actually the core, as I mentioned, of the legislation, the high-risk category. So here, the question that the organizations should ask themselves to see if their AI systems fall under this category is actually twofold. First is whether the systems that they are being used by the organizations are a safety component of a product or an AI system used as a product, and cumulatively falls under consistent and existing union harmonized legislation, which are required to go on third-party conformity assessments. The systems falling under these category includes also systems from the aviation legislation, as the aviation legislation is depicted in the legislation as one of the union harmonized legislation listed in Annex 1. That means that systems that will be used by the aviation sectors will need to include the specific requirements if they fall under the high-risk category of the AI Act. That does not mean that they would need to go through two different conformity assessments, not at all. That means that those third-party conformity assessments, which are enforced to make actually conformity assessments in specific sector, will need to also check the specific requirements introduced by the AI Act. So in the case of the aviation, Article 108 actually give power to EASA to directly make the conformity assessments, but also take into account the specific requirements introduced by the European AI legislation. Next slide, please. This is not actually the only systems that would fall under the high-risk category. There is also another types of systems that can directly fall under this category. And these are systems which are based on use case, which are listed in Annex 3 of the legislation. And here we covered areas such as biometrics, such as employment, such as education, law enforcement, border management, and others. Here, what is also very important to note is that the co-legislator have decided to introduce a filter mechanism. What does this filter mechanism mean? Actually, if an organization can prove that the AI systems that falls under this category does not pose any risk to health, safety, and fundamental rights, it can simply opt out and say that the systems and documents that the systems will not and should not be considered as a high risk. Here on the right-hand side, you can see some of these specific systems which are actually depicted in the legislations. Those systems are, for instance, the systems that perform narrow procedural tasks, that improve the results of previous human activities, that do not influence human decision directly, or that do purely preparatory tasks. So once an organization has identified all of the systems that it is being used within the organization, then it has to determine whether these AI systems fall under one of the categories of the AI Act. And then, next slide, please. If it falls under the high-risk category of the AI Act, it has to determine whether it is directly a provider of these AI systems or only a deployer of these AI systems. If it's a provider of the AI systems directly, then the legislation is quite extensive on the number of requirements the provider has to achieve, has to comply with in order to be compliant with the legislation. If it's only a deployer, then the requirements are reduced. The requirements imposed by the legislations are displayed on your screen and covered things like the introduction of a risk management systems, the introduction of quality management systems, and the making sure that actually there are some specific requirements relating to data quality, documentations, transparency, human oversight, accuracy, and cybersecurity and robustness, and so on and so forth, are put in place in order to make sure the AI systems put on the internal market are fully trustworthy. For the deployers, as I mentioned, the requirements are really very much lighter than for the providers of direct AI systems. The deployers' obligations includes, for instance, a bit of human oversight, making sure actually that a human stays in the loops of the decision process, making sure that also a specific affected worker are informed that specific AI systems are used on them, and so on and so forth. So what's really important for organization is first to identify all of the AI systems that are being used. Second, to see under which category those AI system falls. Third, to determine whether the organization is a deployer or providers of these AI systems. And finally, to comply with the specific requirements, whether it is a deployer or a providers of these high-risk AI systems. Next slide, please. Now, during the negotiation process, certain new types of very high-level, very capable AI systems have been put on the markets, notably those systems who are based on what is called general-purpose AI models. Given the specific risk posed by these types of general-purpose AI models, the co-legislator have decided to add a layer of requirements for the providers of these specific models. For what concerns all of the models, the requirements are quite high level and quite easy actually to comply with. But then the legislation also introduced new requirements for those very highly capable models that are called models with systemic risk. One of these thresholds that has been put in place by the co-legislator is a computing threshold of 10 to the 25th flops, which is a computing value which has been introduced by the legislation. For those organizations that develop specific general purpose AI models with such systemic reach, which can pose actually specific risk to the society, then the legislation introduces specific requirements. But these providers of general purpose AI models are very few at the moment in the world, and are very concerning specific types of models which are very developed by very specific companies, which are not many in Europe and actually in the world. Next slide, please. So now that I explained these two parts of the legislation, so those rules which falls under the high risk categories, and those rules which would be required to be complied with by general purpose AI models providers, an important element to stress is the timeline, the graduated approach adopted by the co-legislator to fully comply with the legislation. So as I mentioned in the beginning, the legislation is supposed to enter into force on the 1st of August, so one month from now. Then 6 months after this date, the requirements on prohibited systems will kick in, meaning that 6 months, in 6 months' time, actually in 7 months' time, to these dates, prohibited systems that are falling under the prohibited category will be fully prohibited to be used on the internal market. Then all the rules that are covered or that are specifically focusing on general purpose AI models will kick in 1 year time. Then, for the most important parts of the legislation, and actually most of the provisions of the legislation will only enter into application 2 years after the entry into force of the legislation, meaning more or less 2 years from now. And then for these systems which falls under Annex 1, so which are actually the systems, for instance, that are being used in the aviation sector, the timeline, actually the time to comply with the requirements is a bit longer, as the organization that are part of these specific sector have 3 years to comply with the requirements introduced by the law. I really want to stress, to finalize this very small and high-level presentation, that our intention, the intention of the Commission, is really to streamline, really to use as much as possible existing mechanism in place in dedicated sector. And that's why actually the legislation specify that those organizations that are responsible for conformity assessment will continue to be fully in charge of these specific conformity assessment in specific sectors such as aviation. And that means that in the future, EASA will still be fully in charge of conformity assessments for what concerns aviation rules, but taking into account the specific requirements introduced by the AI legislation. And that's it for this presentation. I'm happy to take any questions if you have some.
Yes, thank you very much, Antoine Alexandre. We were not, let's say, foreseeing to take questions on the keynotes, but because we have 2 minutes, if there is a burning question from the floor, just let us know. No, I think, yeah, let's move on with the program. And you will have just after the possibility to use the Slido, which is a tool for question and answer that we will use then for the Q&A sessions. But thank you very much, Antoine Alexandre. Feel free to participate. Thank you. No, we really appreciate. Feel free to stay with us as long as you want, and you can follow the WebEx. And thank you for taking the time for us today. Thank you.
Okay, so back to me. Thank you very much, then, Antoine Alexandre. We're now going to hand over to Professor Dr. Peter Hecker, who is also the chairman of our scientific committee, which EASA set up now just 2 years ago, so in 2022. And in his real job, he is the head of the Institute of Flight Guidance since 2005. So I'll hand over directly to you. Thank you.
Yes, thank you very much. Good morning, ladies and gentlemen. It's a big pleasure to provide a little insight into the scientific committee and its work on artificial intelligence. And before entering into the topic of AI and automation, I would like to provide a little update on the scientific committee. As mentioned before, it has been established 2.5 years ago, and it's a big pleasure to support the EASA here by providing advice to the EASA executive director, and especially on issues which are somehow linked to science and emerging technologies. And there's a group of overall 11 international experts in this group supporting EASA, and it's a very lively committee, and it's focusing on several areas. And currently our work program is focusing on establishing a mechanism to connecting academia stronger to EASA, to have a lively body of research and exchange on relevant academic topics. Secondly, and this has been mentioned before in another speech, to look a little bit closer, what does the climate change mean to aviation? So in many cases, we are discussing the other way around. So what is the impact of aviation onto climate? But here we're looking the other way around. How will climate change, and what does it mean for the evolution and the safety of future aircraft? And what I'm focusing on today is the AI and automation task force. It's one of the areas we're looking into, and there are annual reports publicly available, and I really encourage you to have a closer look. They are free for download on the EASA website, and there are just shorter reports released for 22 and 23, plus annexes with a lot of exciting material if you want to dig deeper into these specific topics. So there's the link, have a closer look, and feel free to look into the documentation. So now focusing on the area of artificial intelligence and automation, the task force consists of something like 12 people working together, 7 from EASA, and looking around, I think most of them are sitting here in the room today, almost all of them. And besides that, there are 5 members from the scientific committee. The names are provided here. And we are working very closely along a stream of activities which has been defined at the beginning of this year. And the starting point for our activities is actually the continuous development of the EASA AI strategy. And there's a lot of material now available by EASA, which is, for example, the AI Roadmap in its version 2.0, which is a kind of action plan preparing the necessary AI trustworthiness guidance and anticipating necessary regulatory updates to really support this innovation wave, which is underway. And there's a concept paper, which is the first usable guidance for level 1 and 2 machine learning applications. And this is the starting point where the scientific committee had a closer look and started elaborating recommendations and supporting EASA in looking into the area of human-machine collaboration and teaming, into ethics in AI and automation, and finally into what comes next, which is the design principles for level 3 AI. And as you can read here, there are very exciting things to do. When it comes to collaboration and teaming, then we need to understand what are the roles, what are relevant use cases, how to validate the concepts we are developing here. In ethics, it's important to understand the perception as well at the stakeholders, at the aviation professionals level, and on the public level. So what does society think about AI in such a safety critical environment? And as I said before, to support the development of level 3 AI activities. And translating this into the 24 work program, there are 3 work packages we're looking at. I'm not going to read all that, just to give a little insight and impression. We are preparing together with the colleagues from EASA a survey to general public, complementing the survey which has been carried out last year, early this year, reaching out to the professionals, and we will hear more about that from Ines later today. We are actively testing level 2 AI human factors guidance with specific use cases, and we are identifying already use cases for level 3 to come. So many exciting things which are relevant in the further development of the roadmap and guidance material. And there are 3 messages and statements I would like to hand over to you to propose. So one is on the classification typology. You are well aware that the current EASA classification scheme is consisting of 3 levels, 1 to 3, which is level 1, assistance to the human. Level 2 is human AI teaming, and level 3 will be advanced automation. And there are different sub-levels. I'm not going to enter into this, but you know the levels 1A, 1B, 2A, 2B, etc. Now, looking into other means of transportation and other areas where AI is being implemented and deployed, then you might be interested in how things are matching. And we looked into other transportation means, for example, into the air traffic management domain. And there we looked into the Master Plan 2020. The new Master Plan is currently under development at CESAR Joint Undertaking. There we have the concepts of levels of automation. If you look into the unmanned aerial systems domain like YARUS, then there is a specific method. Automotive has a specific method, the SAE J3016. Levels of driving automation, there are other elements at railways, the goals of automation, IEC 62 to 91. And furthermore, I'm not going to elaborate on them very much, but the exciting question is, how does that all match? Can we map levels between the different domains? Do they correspond? Are they coherent, or are they eventually divergent? And so we looked very intensively, and you shall not read this table here at the right, it's just to indicate the mechanism we applied. We built up a very large table, which you will find in the report, and there we try to assign and to somehow allocate the levels to each other. And what we found out by doing this exercise is that the existing schemes across the domains do not easily match. So even if you compare the terms and definitions, then you find out that there are different understandings, different meanings, depending on the domain you are looking at. And that is something which may lead to misinterpretation and therefore is a kind of risk. And even in some domains, the boundaries between the different levels are not always clear and consistent, and that is a matter of concern. So what we believe as a scientific committee is that the classification typology as proposed by EASA is very transparent. It enables a coherent mapping to any other domain we have looked at. And it does, in addition, provide very clear boundaries between the levels. Therefore, we appreciate very much the effort taken here. We believe is really paving the way towards a unique structure for classifying AI in various applications, even beyond aviation. So that is the first key message. The second key message is about the human AI teaming concept. And in the guidance material for level 1 and 2 machine learning applications, we have already identified and seen the learning assurance element and the element of AI explainability. And now there is the human AI teaming element, which is very important, according to my understanding, because this will allow further steps in paving the way towards higher levels in AI deployment. So the level 2 AI applications require augmenting the AI trustworthiness framework with additional human factors guidance. We believe that the differentiation between the cooperation and collaboration between human and AI is something to be really differentiated very carefully. And the framework of human AI teaming is a very clear and very useful method to do so. And what we have started with is to do a testing along different use cases. And this is very important to really prove the concept, to understand, is it mature, is it fit for purpose, and does it really serve what we are looking for? And next steps will be define teaming concepts for level 3 AI. Now coming to the third and final message, what will be next? So advanced automation and beyond. Still, there is a field of development. What will be beyond level 3? We'll believe that extended AI safety risk mitigation concepts need a kind of human-centric approach. So this has to be introduced. In addition, it might be debatable if the complexity of operations term, this phrase, this concept needs to be integrated. So what does it mean to apply AI and automation? Does it depend somehow on the type of operation we are looking into and how to measure complexity? What is a complex mission or complex operation? We need to carefully differentiate between advanced automation and autonomy. And potentially there will be new AI levels for autonomy, something to be discussed in the coming period. And I'm very grateful for the presentation we received a minute ago. The alignment with the final EU AI Act is very important, and Article 14 is something to be really investigated in detail because it's opening somehow the door for autonomy, but on the other hand, it's putting some constraints, and we need to carefully analyze and understand what is written there. On one hand, it introduces the notion of effective oversight by natural persons, which is laid down in paragraph 1 of Article 14. On the other hand, we're looking into autonomy, which is mentioned there explicitly in this Article 14. And so we need to investigate how to open the door and what does autonomy mean in this context and what is human oversight here in this context. So looking to the paragraph 3 in more detail may be the key enabler to enable level 3A and level 3B operations by AI. So that is an area of further investigation. Now, concluding my little presentation, we believe that EASA has very well demonstrated a proactive approach on paving the way for introducing AI in aviation. I think this is really a remarkable achievement. The approach of levels of automation as presented here is a major step towards structuring the application of AI in a clear and traceable manner. That is a very important element to avoid confusion in the future. The roadmap and the guidance material which has been developed so far is an excellent basis for a unified understanding in the aviation community. I think it's really paving the way and building the foundation for further activities. And I believe that aviation, with the support and driven by EASA, is a front runner in structuring the levels of automation, which will support and may support a harmonization across different domains. So thank you very much, and I'm looking forward to interesting talks today. Thanks.
Thank you very much, Professor Hecke. The next gentleman is responsible. He's the architect for most of what we've just heard about on that last slide. And I think just about everybody in the room already knows him. So I'll hand over immediately to Guillaume Sedan from EASA.
Thank you. Thank you, Janet, and thank you all for being here so numerous. Very nice to see a crowded scene here on site at EASA, and to see also that people are joining numerously on the WebEx. I hope everyone is at ease on the WebEx and everything is working well. Sorry for the small hiccups at the start. My talk, actually, just before the coffee break, is to give you, let's say, the big picture. Let's start. First, we will accelerate, as we say here, after an initial exploration phase. And what we are bringing to you today and this week is, in fact, the consolidation phase. We enter in phase 2 of the roadmap, and that's where we are. That's a milestone we have reached, I would say, timely, with a certain background of what we developed so far. That's what you will see also in the different presentations from the team today, and also looking forward. What are the next steps? What are the challenges? I really thank Peter for his presentation, because it sets also the scene of challenges. Everything that we are dealing with the scientific committee is definitely what is the most challenging, the most complex ahead. All the rest, not saying it's done, but definitely the rulemaking will be a very important step for us to, let's say, concretize the guidance necessary. And you will see also that in the presentation from Giovanni a bit later. So with no further notice, let's enter in this very famous slide now, but we always bring it forward. It's our roadmap from the start, I would say. We updated it in May 2023. Last year was the event, the EASA AI Days first event was actually centered around this new roadmap. It is still our new roadmap in the sense that we really work per this plan, and that's our driving factor. The phases that you can see here on the slide, you also know them because we didn't change them. We wanted to keep this framework of first exploration, then consolidation, and then pushing barriers. We still keep this logic. The exploration has brought us as far as we could, but timely to enter in a rulemaking activity this year. You will see that also presented in many more details in the speeches today, in the presentations. And very importantly, we entered early 2024 in this phase 2 of consolidation. We are at the level 2. We have tackled, I would say, level 1, level 2 in a proactive manner, but also in a prospective manner. We are not at the stage where we say the concept paper is the final guidance, and definitely we will have a rulemaking exercise to crystallize what it means. Yet the concept paper, as Maria mentioned, is used already in special conditions in order to feed our applicants with early requirements. We cannot wait for, let's say, 2025, the date at which we want to do the first approvals of level 1, to say, okay, we have waited enough, now here are the requirements. Of course, a certification process doesn't go like this. We needed to anticipate as much as possible, and that was the first driver for the issue 1 of the concept paper. For level 1 applications, I would say we are served, at least for the applicants are served. For the first applications and certifications we are undergoing, it proves to be a meaningful framework. We have a couple of adaptations, as any certification process is doing, but there is nothing we identified as really missing or really too challenging to be overcome. We know there are challenges. It will be the part of the MLIP presentation and day 2. You will see some of the challenges we try to overcome with methods and tools, but also some are remaining, definitely, and it's a journey, and we are still processing on that. We enter this phase 2 with a consolidation thinking. So rulemaking is the big picture are the big driver of it, of course, but we don't abandon the notion of exploration. We still have the level 3 on the plate. Peter just mentioned some of the challenges. I will also highlight a number of anticipation we already have, but we are pursuing this effort with the scientific committee to crystallize our driving principles for level 3 AI, and that's a big step also ahead. The finalized guidance, I mean, there is kind of a cut in the roadmap. It goes a bit further, but we didn't want to show everything. The finalized guidance for level 1 and 2 is the first step of rulemaking. Of course, we'll follow at some point another rulemaking task, either an extension of the 742 task that Maria was mentioning, or maybe a new task. Let's see how challenging it is. But that will be commensurate also with the phase 3, pushing barriers. We have a number of limitations already today because we are in a safety environment. We are in aviation. We are not trying to take the maximum potential of AI. We are trying to take its maximum potential in a safe framework, meaning we are restricting some aspects, like, for instance, online learning or adaptive learning or whatever name you give to it. We are kind of saying no. We say, you freeze your model at the time of certification, and then we can certify. There is no possibility for us to adapt beyond understanding, let's say. And this is really the point where I don't say for every application, but possibly there is a bit of room of play. And the level 3, you will see, from the anticipation perspective, will bring us the tools to embed in the systems some elements that could be very advanced monitoring logics, let's say, and bring us to a level where we can say, even if there is adaptive learning in a certain frame and context framed by the application, we could possibly go to a certain level of adaptation of certain models in operations. But again, it's a very large perspective. That's why we pushed it for, let's say, 2028, the time where we will have finalized the consolidation, meaning having a really solid basis to go anywhere near, I would say, other possibilities. This is where we are. We didn't change again the roadmap from the first one. We adapted slightly the timelines towards when we think level 2B, level 3A will come. This is not a limitation in itself. Of course, we will engage with any applicant bringing level 3A today. But we anticipate that let's say the path is still a bit longer than for level 1, which is really the low-hanging fruit. Not saying it's simple. I'm always saying it's not. I'm not trying to simplify, but to say that level 1 gives us the framework in which we can safely certify applications. Again, with the limitation on the level of criticality. This is all things you will see in more details in the presentation from François and René just after. From that perspective, what is consolidation for us? Rulemaking, or RMT 0742, which starts now. We published the TOR 2 weeks ago, and this is the start. So we'll have a rulemaking group. Everything will be presented by Giovanni also just after. Continued exploration. As I said, we don't abandon that. We still, in parallel, have part of the team working on this AI assurance technical scope, expanding it. Reinforcement learning is a big stake. We see it coming. Symbolic AI, hybrid AI, we talk about it with many industry partners. Human factors for AI, a big stake, let's say, still with René and what you presented, Peter. We have a lot of things to still investigate and test from the guidance. Ethics-based assessment with Ines, and you will see also a lot more. And there will be a panel of discussion on the boundaries to give also to this exercise. Advanced automation, level 3 AI. It's a major challenge. Generative AI and tools. It's another question we regularly get. What do we do about? Okay, here with the concept paper, we address definitively the embedded part, let's say, of the AI. But and embedded, I mean not necessarily airborne, but embedded in systems under certification or approval already existing. What about tools used in operations, either to develop, why not, but also to enable certain operations under organization approvals? This is something we need also to anticipate. We have a fifth project that really started under the AI program in order to address this aspect. And this is something we will talk about just at least in a slide for today. The consolidation phase is a 4 years period, 2024-2027. And this is something you will talk about with us a lot in the coming years. From a rulemaking perspective, so now I will go on the 3 layers one by one. From the rulemaking perspective, I will not say too much because, again, Giovanni will present all the details of it. But really, from the top level, this picture gives the big picture, let's say, gives the environment in which we are evolving. At the top, the EU AI Act was just introduced by Antoine Alexandre. We have this Article 108 that gives us a mandate to do something about it. That's why, in the rulemaking, we will have a Part AI in order to clarify this link to the Chapter 3, Section 2 of the AI Act, which is the mandate that is given to us. And from that Part AI, which will be as light as possible, but aggregate authorities requirements, organization requirements, and technical requirements, we will have a framework that is most of what the concept paper will become, a set of generic AI, AMC, and GM. AMC, acceptable means of compliance, GM, guidance material. From that, we will, in a step 2, instantiate that in the different domain regulations that are impacted. So it's really like the place where the work will be very fine-tuning of connection. So interfacing can be done in various ways. That's something, again, we will investigate with Giovanni and the rulemaking group on the rulemaking task that we are starting. Very important mentioning also the industry standards. A lot is ongoing. You will have a keynote speech, also a flash talk from the chairman of the group, of the working group 114 a bit later today. And we try definitively, as usual, to rely as much as possible on the industry standards that are under development, and we will definitely make the effort to recognize them in the AMC as far as practicable. From that, the time frame will be also restated by Giovanni. From a consolidation perspective and further exploration thinking, another slide to show where we are in terms of technical trustworthiness concepts. So we developed a number of things for level 1. You know very well the learning assurance W-shaped process. That's something very, very important for machine learning. Needs to be reevaluated by the team of François for hybrid, symbolic AI, and even for reinforcement learning. AI explainability is a layer that is absolutely necessary from the perspective of everyone, but that is very use case specific. So we need to still think about what is the set of generic guidance we need to give to AI explainability. Continuous safety and security risk assessment, very, very important element. Data-driven approach, generate data. Data is really the new goal to get to, let's say, gathering signals from the operational perspective, whether something is wrong, incorrect, maybe an incorrect assumption that was done at development time. We need to monitor that, at least for, I would say, the first times, years, etc. After we will see what needs to be kind of mitigated a bit differently. But at least from that perspective, we push beyond, I would say, existing consideration on continuing airworthiness. For instance, if I take one domain, we will push a bit the data recording and monitoring capabilities on AI systems. And that's a very, very important block that François will describe also in more details. What the level 2 brought us to consider on top, ethics was already on the plate for level 1, but we really pushed it one step further for the level 2 specifically, because it's the interaction with the human, cooperation, collaboration. That's where it starts to be very important. And the human AI teaming is the framework, I would say, that was created from the human factors side to reply or to answer to a need from the notion of collaboration and, cooperation first and collaborations that will be presented also by René in many more details just after after the break. Scope of the RMT 0742 is definitely this. This is where we are, level 1, level 2. We don't claim we are done. Again, it's a lot of processing still, but this is our scope. Now, what is the further exploration we have in mind? Issue 3 of the concept paper is upcoming. We will initiate it at the end of this year with a target end of next year to come up with a proposal for the scope extension to reinforcement learning, symbolic AI, statistical AI, and hybrid AI. François will say a lot more about that also. Human AI supervision and unsupervised automation are the 2 next levels to investigate, 3A, 3B. 3A is not an easy one because we are in the sense of putting the human more as a supervision element with machines or let's say AI systems that are much more independent. I don't say autonomous, you will see why. It's a very big clarification we want to bring here to the forum also for discussion. We don't want let's say, to leave the human in a case of non-capability to recover and to take over an operation in case of, I don't know, a failure on the system. That's a very important human factors element that we need to bring, level 3A. And level 3B will bring us really in the, let's say, it's the jump in the unknown of the Article 14 from the EU AI Act, and that's something we will really need to work on the interpretation of the boundaries that we can reach. If you interpret it strictly, I don't want to talk for Antoine Alexandre, but strictly speaking, it's, let's say, you need a human in the loop of operations. Now, what does it mean? It's exactly what we need to find out in a common effort. The last element of the consolidation is this use of AI for operational tools. And I'm on purpose putting generative in brackets because generative is the hype, is bringing us this concern even wider, let's say, with ChatGPT, large language models, but it's not necessarily only generative AI that will be used as tools. Let's put it this way. Now, operational tools means we have a scope in mind of organization approval. We don't want to say to anyone, come with your tool that will help aviation and we will certify it. That's not the talk here. We are just saying within an organization approval, we could have applicants, organizations like DOAs, POAs, MOAs, going for the use of tools, but really tools, not in the sense of systems that are running in a cockpit or in an ATM environment. And this is a place where we have to start questioning how much of the concept paper would apply, how can we enable those possibilities. Would the concept paper make it, or would the generative AI like ChatGPT make it through the concept paper objectives? No, clearly not. So that's the entry point. Using public generative AI, there might be still a small open door, let's say, but let's see how far. In the middle, we need also at some point to think about prototyping, or not only prototyping, but thinking in a sandbox, meaning enabling a safe and secure environment for developing ConOps that makes sense in an environment where the data there is no problem with data privacy, etc. This is, for instance, what we do in EASA for safety reports analysis. Definitely, safety reports are elements that should not go out. We have also discussion with the European Central Question Bank. This is things that should not leak in some way. So they need to be mastered in an environment. So we have, the message is, we have the same concern internally, but we see this element also benefiting to any organization wanting to use AI tools, and we have examples and IPCs that are starting actually on this side. And the last end is developing end-to-end applications, which means more in an embedded-like way. So of course, it's the high end. It doesn't apply to everyone, but it's another possibility. What we are working on or investigating is a possibility to have a sort of a label for tools. Let's call it a non-embedded AI trustworthy tools. Of course, we will have to find a more sexy name, but actually it's what aggregates what we have in the thinking for now. And based on that, the top 3 program activities, no surprise, we will execute first priority, the rulemaking plan, and in parallel, continue the work on certification to approve the first level 1 applications. Target end of 25, target end of 27 for the RMT, but definitely, as you will see with Giovanni, NPA planned for mid-25, so there will be a lot happening in between. Initiate and develop the concept paper issue 3, second priority, but very high on the radar also, with all the extensions that I was mentioning before, and enable safe and efficient use of AI in operational tools with a target end of 2025. This is also to be, of course, carefully taken, and also with the label, it's an anticipation. It's not something we want to commit on, but we will find out the best way to deal with internal use of AI at EASA, but at the same time thinking widely on organization approval and support also to our NAA colleagues. From that, and just checking the time, no, we are perfectly on time. So one slide I really wanted to bring now as a real big perspective. One thing we are always talking about, and that's the subtitle of the roadmap, a human-centric approach to AI in aviation. We really believe in it. We are really focused on the human as much as we did so far. Level 1, level 2, it was easy. We have a human end user in the operations, like a pilot, an air traffic controller, or whoever. And this is something that was easy to sell and to not even talk about until now, because it was obvious. Now that we move towards level 3, where is the human? Supervision, possibly, or no human in the operation? How can we stay human-centric in that case? That's a big question. One thing before giving you the big picture of this human-centric approach, very important clarification also, the AI roadmap, we call it AI roadmap because we started thinking AI, definitely. But it has brought us actually beyond probably what we were anticipating initially to a roadmap that is AI and automation, or at least advanced automation. I don't want to say automation because we have a lot of automation already in cockpits today. We are not trying to reinvent the wheel for tools and standards or methods that are working. But definitely, with level 2 high-end, like level 2B or 3A or 3B, we are really going in unknown ground. And this is what we call kind of advanced automation. And the roadmap on AI is really serving as a placeholder for that. It doesn't mean we are ruling over everything that is connected. Like, I mean, every domain will have, like if you think extended minimum crew operation, there is another project running in parallel. We are not dealing with that, but we are kind of the enabler. AI is the enabler. AI is not per se a product, it's an enabler. And it enables this advanced automation that we need to look at. And therefore, we take use cases from MCO. We take from extended minimum crew operation. We take also a partnership with Cesar and all our colleagues on the ATM master plan update, especially to take on board all these use cases and go in a meaningful way on an AI and automation roadmap that is very comprehensive and very logical, at least from an EASA perspective. That means, as I said, advanced automation is obviously enabled by AI, but we always say we don't push people to use AI. That's not the point as well. So we could have non-AI automation, and we have today. We could have it going even further. Why not? Why not into level 2? Fine. And AI assurance in this case would not apply. That's one of the building blocks. But we have other building blocks in the roadmap. We have human factors, we have ethics, and all of these elements, if you push too far, I would say, the cursor on advanced automation, definitely you will hit the need for these objectives that were developed in other building blocks than the technical, I would say, AI assurance part. Last thing, level 3B comes, and supervised comes with even more challenges. We really believe that. It could be sold as a level 1 just without a human. Okay, but no, there is a lot to consider. And this is where let's say, without a net, I tried a bit of anticipation and thinking here. What are the big elements we have to consider when we think human-centric? First, human agency and oversight. That's the key element in the AI Act. Per the Article 14, we are totally aligned with this logic of protection and capability to really protect the human agency, but also its capability of oversight. And that's a big challenge for level 3A. We have the development and the operational aspects in the concept paper, but we will, of course, carry over this in the rulemaking. Development phase is extremely crucial, and so far it's maybe an implicit statement, but the development phase is under human oversight and control totally. We will not in aviation release systems that are AI developed, let's say, and then we believe that the AI has done better than the human. No, not at all. The development is under human oversight 100%. Today there is an end. It's 100% in development, and it's some percent. I don't want to give a percentage, but in operations, we have the notion of authority in the concept paper that says it's full authority until level 2A, and it's a partial release of authority at level 2B, and it's an extensive release of authority at level 3A, else the operation cannot work, and it's a total release of authority at level 3B. What does it mean, authority? We have also responsibility, accountability to think in mind, and liability in the background. Let's say we don't rule on liability, but we will think about responsibility. If we certify a system that is super advanced in terms of advanced automation, we need to think about who is responsible in case. So until level 2, we can say it's the end user. That's easy. We have a framework. We can keep the framework of aviation as it is today. When we cross the barrier of level 3, we have to think and to really scratch our heads. So that's a big part of the concept paper issue 3. So there is ethics-based assessment objectives. You will hear a lot about that later this afternoon. So with a presentation from Ines and a panel of discussion. What we see is is two terms, let's say, to consider for level 2 and 3. It's technical and societal. Technical, I mean, we are a technical agency. We know where we can put the boundary. Societal, we have attention also here brought actually by the advanced automation, by whichever level we can reach with AI. And that's something we need to put to create really the right framework that is practicable for applicants, but that doesn't leave aside really important societal issues. That's something we will discuss along the day a lot. To finish, and that was my last speech, the arrow between those terms, actually, it's not a tension necessarily, it's not an opposition. It's a bit like Jacques Derrida, the philosopher, putting in opposition means getting meaning actually from both sides. So very importantly, the arrow will need to be clarified with whether it is an and or it can be a or. Let's say today we will put an and everywhere. Whatever we do in level 2, no question. Up to level 2B and 3, we need to think how much can we release to have possibly a or, like development only for the other side, maybe not in operation. Else, what do we do with use space, with drones, etc. Accountability, we have to put possibly a or also, but a or the end user and or someone else. And the ethics-based assessment, we have to create this technical, social framework that really meets the need. So probably it will be not a or, but a union at the end. So that's where I will leave you for now. Last word before entering the coffee break. We have this Slido. We will leave it through the coffee break, so you can use your mobile phone, scan the QR code, use the slide.do website, putting AI Days as a code and passcode HM quota. With that, you enter the Slido. The Slido is a question and answer platform. We will gather all your questions there. There will be blocks of presentation from now on where you will be able to gather your questions, and we will take Q&A. There will be Q&A sessions you can see on the agenda where we will take the questions with the full team that was intervening. With that, I would say leave the floor to Janet. Yes, thank you.
One thing from me, I know you all know how to drink coffee, but you need to know how to find the coffee. It's actually going to be in our Boeing room, so you need to go through the bistro, which is the other side of the atrium here. Keep going, and then on the other side, towards the left, there is a door into Boeing, and that's where you'll find the free coffee, so to speak. Please be back at 10:50 so we can start on time. Thank you.
Thank you.
Welcome back, everybody. So we're going to get started. We now have another tight and fun-packed 75 minutes. We're going to start off with two of my EASA colleagues talking more about the latest concept paper. So I'd like to welcome now René Medved, I knew I'd get it wrong, and François Triboulet. Thank you.
Tu peux remettre le slide si les gens l'ont pas encore pris.
Okay. Good morning, everyone. My name is François Triboulet. I am seconded from Eurocontrol to EASA, and my role in the AI program is the project manager for AI assurance. And during this presentation, I will be accompanied by René, but I think she will present herself later. So I hope everyone got the Slido, and do not hesitate to ask your questions via the Slido.
Maybe you can go one slide.
Yes, I can show it again so that you can take a picture of it. So, just some reminders about the process that we applied for the issue 2 of the concept paper. Similarly to rulemaking activities, we went through a consultation process in order to produce this second issue of the concept paper. So we published a draft version in early 2023. And it took us almost 9 months to really process all the comments that we received. We received roughly, exactly 900 comments from many different stakeholders, many comments coming from the industry, but also a lot of comments from authorities, from academia and research, as well as the ATM community, without forgetting about airlines, airports, and so on. So a huge variety of stakeholders. If we look at the dispositioning of all these comments, a lot were accepted or partially accepted, and a lot were replied with clarifications about our intentions with the text of the draft issue 2. A low level of comments were not accepted. Going into the details, we tried to position them into big themes. Obviously, some comments could have been consolidated into several themes, but okay, from the comments, we decided to put them into one or the other. The safety assessment was really significantly commented. And if for those who know the second issue of the concept paper, you would have identified that a significant rework was done between the draft and the final issue, especially with regards to the sequence of anticipated mocks. A lot of comments were on the learning assurance, and here again, there have been significant changes in the final issue. I would just mention the new dotted line on the W shape between that introduces really this notion of requirements at the level of the AI/ML constituent. After that, we have human factors, and this is obviously linked to the area of the human AI teaming. And after that, you have explainability. I would just also mention the ODD, which is really a very important notion and concept with data-driven approaches, and a lot of comments were going into that direction. I would like to just introduce you the journey for the rest of this presentation by first reminding everyone the 4 building blocks of the EASA trustworthiness framework, with on the left the assessment part, or the trustworthiness analysis part of the framework, and on the right all the technical blocks to answer or to satisfy the assessment done by the applicant. We will first dig into the classification of the AI applications, and from this we will look at how the technical blocks will enable the transparency and also enable the human AI teaming. And during the second part of the presentation, we will come back to the assessment, looking at how we look at the risks and how we assess these risks, and how on the right part the scope of the concept paper and its extension will be taken into account, how some of the technical blocks will enable the continuous safety assessment, and also looking at the next steps and how to enable advanced automation.
Thank you very much, Francois, for introducing the building blocks. If you have seen the the concept paper, if you had the opportunity to go into it, you might know this table very well. Let me see, where do I, is this the, I just use it here. Okay, thank you. So I might use this table very well. We have our 3 AI levels, and each of them has a sub-level again, which leads us to 6 AI levels. It was already mentioned by Peter from the scientific committee that a mapping was done between different domains. So the AI levels of EASA are very important to ensure a mapping across different domains. As Peter mentioned, the car industry, the rail industry, drones, but also the ATM master plan that's currently under revision was aligned with the AI levels, how we have it in the concept paper. And of course, this is important. If you have an AI-based system triggering an automation level from the ATM master plan, it might be very helpful if you're talking the same language and you know which requirements are needed in line with your AI levels. I will now split the different AI levels into the sub-levels, into the 6 levels, to make it hopefully a bit better visible. So we have the level 1, right? That we split into level 1A and level 1B. So in level 1A, we talk about human augmentation, automation support to information acquisition. So we are talking about the first processing stages. Then we have also still in level 1A, automation support to information analysis. So here we are facilitating, enabling, or touching the first cognitive functions. In order to go into level 1B, we have the boundary, and that comes when we introduce decision-making. So the machine supporting the human in its decision-making, automated support to decision-making. For the level 2, we are not talking only about decision-making any longer, we're talking about action implementation. So that's the next step, where the machine supports the human also in the action implementation. So we have level 2A, level 2B. So level 2A, we call human AI cooperation. It's a directed decision and automatic action implementation. So the human is still monitoring. The human can intervene, interact, override whenever deemed necessary in 2A. In 2B, some of the action implementations might be independent. So it's a supervised, automated decision and action implementation. Again, it can be overridden by the human. So we have for the first 3 levels, level 1A, level 1B, level 2A, full end user authority. It's the end user who overrides, decides, supported by the machine. On level 2B, we partially release this authority, partially, to the machine. And in all those 2 levels, as Guillaume mentioned earlier, the responsibility stays fully with the human. If we go to the next level, level 3, this is where it will then look a little bit different, and it's still under development. Also, as mentioned, that will be our focus for the next concept paper, issue 3. So that is what we envisage, a level 3A with a safeguarded advanced automation. We have the safeguarded automation decision and action implementation. So that means the human can still intervene upon alerting. So the machine might alert the human if an action is needed. And then we have the level 3B, where it's non-supervised advanced automation, where we do not have the end user any longer. So in level 3A, we have limited end user authority. And in level 3B, we do not have the end user there any longer. Again, we are working on it. We will be working on it. It's a big focus of us for the next issue. So it's not, of course, fully developed yet. Another building block that Francois mentioned in the beginning was the operational explainability. So of course, if we talk about these AI levels, in level 1A, for example, it's the system that we have today. There might be no additional need for operational explainability on top of the human factors requirements that we have already in place today. However, the more we go in the AI level upwards, there might be, and I come to that better, something called shared situation awareness. So the human might not have their own situation awareness alone any longer. In order to be able still to be aware of everything, he has to be provided with explanations. And we are talking here about the operational explainability, operationally focused. Of course, we have the development of explainability as well, and you can see this also in the concept paper that lays out the full battery of possibilities. And then we have to see in operational explainability what is actually, and here you have the elements, what has to be presented how. So what is understandable for the end user? How does it have to be presented to understandable for the end user? When does it have to be presented? The level of abstraction, the level of detail. What is the situation at the moment? How can we best present it? And of course, is the explanation valid? So this is needed in order to give the end user the possibility to understand the decision that the AI-based system is proposing, and to predict the AI behavior as well. And only with this trust, build this collaboration, as we call it in level 2B, is able to work. The end user has to have trust, but it's not only the trust of the end user, the operational explainability also, of course, feeds into the system, because you have to design your HMI in a way that is understandable for the human. It will very much influence the design in the end, but also, again, in line with human factors principle already that we know today. And then if we come again to level 2, so in order to facilitate this human AI teaming concept, this level 2 was split into cooperation and collaboration. So in level 2A, we have the cooperation. The AI-based system supports the end user to accomplish its goal. So it's still the end user goal, right? It is all based on a predefined task allocation, so that there is no communication needed. And it is the end user situation awareness that we are talking about. It's a very directive approach. The end user is under full authority and monitoring. In level 2B, we call this collaboration. The two parts work together. So we have the human and the AI-based system working together on a shared goal. And for that, the communication is paramount, because it is based on a dynamic task allocation. So there might be a change depending on the situation. Let's talk about high workload, whatever. There might be a task suddenly moved from one actor to the other. So there is a need for communication. And we are talking here about the shared situation awareness. In our concept paper, we have rephrased the situation awareness for the machine to situation representation, and the human stays with the situation awareness. Here we still call the two together, we call it still shared situation awareness. So this is a co-constructive approach where the both parties work on a shared goal, and the partial authority is given to the machine. However, the human is still actively monitoring, and as we said, the full responsibility lies also in 2B in collaboration with the human. This was a snapshot of some of the elements, not all of them, of the human factors for AI chapter in our concept paper. And I hand over to you, Francois.
So, yes, indeed, this presentation does not aim at presenting the full concept paper. We want to focus on things that probably have changed significantly between the issue 1 and the issue 2. So just to remind you the journey. So Renée presented the classification. She has put some focus on the elements enabling transparency and the human factors aspects with the human AI teaming. I will now continue with the other aspects. and starting with the scope of the technologies that will be covered progressively by the concept paper. So far, we have put the focus on data-driven approaches. And more precisely, we have dealt with machine learning and even more precisely on supervised learning. The issue 2 of the concept paper starts to address some elements related to unsupervised learning, but probably we are not, we will need to exercise all these objectives with concrete use cases, and for sure reinforcement learning is not yet addressed. However, so all these aspects will come with the issue 3 of the concept paper. However, the issue 3 will have to also address some other techniques like knowledge-based, representation-based, logic-based approaches. We will have also to think of statistical approaches like Bayesian estimations and so on. But also very important will be this notion of hybrid AI, where you could have some items or constituent dealing with machine learning and being complemented by some reasoning aspects. Very important, and this was already mentioned by Guillaume earlier during his presentation. The scope is today limited, and we want to stay on a safe subset. From a criticality perspective, so the concept paper today addresses applications with a failure condition that is below major, below including major. We will not allow online learning, so every application will have to be considered with a machine learning model being frozen before being introduced into the operations. And as already mentioned, there will be an extension towards reinforcement learning and other techniques. I would like to draw your attention on the monitoring aspects and the data recording aspects that have been significantly reassessed with the final issue 2. So if we start from the left, you have here depicted the AI ML constituent with the machine learning model and some output level explanations. And you will have under this AI/ML constituent some pre and post processing. The pre-processing will have to deal with some monitoring of the ODD, monitoring of the out of distribution possible inputs, and the post processing will also be in charge of monitoring the performance of the system and, for example, the level of confidence of the predictions being made by the system, by the model. All of these monitoring aspects will address either the end user or the user. For that, some data recording will be necessary, and as mentioned by Guillaume this morning, this data recording will go beyond the traditional recording already in place according to the existing regulations. And the different usages of this recording will be first the accident-incident investigation, also the monitoring of the system usage during the operations, and also the continuous safety assessment. So with the concept paper, we identify the need for this continuous safety assessment in order to reassess during the operations all the assumptions made during the development. Just to conclude on some aspects of the assessments and how these different assessments are an entry to modulate the objectives of the concept paper. With the classification of the AI application, it will be about modulating the human factors aspects and possibly the ethical-based objectives. With the safety assessment, or during the safety assessment, there will be an allocation of an assurance level, and this allocation of the assurance level will drive the applicability of the objectives, especially in for the AI assurance objectives or learning assurance objectives in the first issues of the concept paper. Just a note about the quantitative safety objectives that, when necessary, will drive the quantitative safety assessment for machine learning. And also in this area, there will be an interaction, an interplay between the safety assessment and some objectives of the learning assurance. The information security assessment obviously will modulate the objectives regarding information security. And I would like to conclude also by some other aspects that we need to address. The first is the ethics-based assessment. Currently, in the concept paper, we don't have really this notion of modulation of our objectives, including the ethical objectives based on such an assessment. And this is probably an area that will have to be worked. We also consider that for some applications, there could be safety benefits with the introduction of artificial intelligence, and probably this is something that we will have to work on in order to take benefit of these benefits into the applicability of the objectives. And last but not least, the level 3 guidance and this building block, the safety risk mitigation, will have to be worked when we continue progressing in the in terms of augmentation of the level of automation. So when we move towards advanced automation, we will have to think of that. Thank you.
Thank you very much. A few weeks ago, we had a conference in Washington together with the FAA. And as an outcome of that, you might have seen that one of the things was we put out a statement jointly with the FAA saying how we wanted to work together on various topics right across the board in aviation safety. In this context, I'm very pleased to welcome today from the FAA, the Chief Scientist Technology Advisor, Trung Pham. Thank you.
Thank you. Good morning. My name is Trung Pham. I'm a chief scientist in AI and machine learning from the US FAA. And I'm very happy to be here to share with you the FAA roadmap on AI, and a special thank to EASA for providing the opportunity. So since I have only 15 minutes, I'm going to be very quick and concise. In 2022, we worked with the Research Engineering Development Advisory Committee, and they recommended the FAA to begin working on AI in aviation. And that was the main reason I'm here. I was hired after that recommendation. I'm transferred over from the US Air Force. So I have some experience working on the development side. And moving to the FAA, I began to work on the regulation side, and we proposed the work plan for the AI roadmap early in 2023. We got approved to move forward, and we began to work on the roadmap in May 2023. We had different meetings internally within the FAA and externally with the industry. And we had 2 external meetings with the industry, one in October 2023. And the most recent one was in March 2024. And we finalized the roadmap document, and we expected to release it in July. We are in July now. I prepared this in June. When we look at the roadmap, the only reference we had was the roadmap from EASA, and the only contact that I had was Guillaume. So I like to recognize his conversation with me during the preparation of the roadmap. We look at what we could do and where we are heading. So in the roadmap, we have 3 main components. One is to clarify the focus on aviation software on board an aircraft. It's not going to be the only thing we are focusing. It just is starting point where we want to focus on. And I will reflect why we do that later on with the guiding principle. The second component is the listing of guiding principle, the things that will help us to move forward, to get what we want, to where we want to go. And those are the things that should be independent of who we are or what kind of technology evolution that we will see in the future. And the final thing is that similar to EASA, we do have some research to support the aviation activity, and I like to connect those 3 together during this conversation. So the first thing we did was to make sure that we just want to do focus on safety. And this is a very important point to deliver, because at the FAA, we are authorized to regulate safety and nothing else. And later on, I will tie this roadmap to the existing US policy and show how it fit into the overall picture of the US policy, namely the executive order on AI. And when we started out, I personally saw AI in a different context, and I saw my colleague talking about AI like it's a human being. So coming from an engineering perspective, I wanted to make sure that we want to see AI as a piece of engineering component, especially when we mention that we want to focus on aviation software on board the aircraft. So we want to see that as a piece of software in the aircraft. So we don't want to misinterpret AI as some intelligent being that might confuse the responsibility of the pilot. And we want to make sure that if it's considered as an engineering component, then the developer has to have clarity on their responsibility of the software that they develop. Similar to EASA discussion this morning, we want to differentiate what type of AI we are working with now and what type of AI we are dealing with in the future. So we define learned AI, the AI that we train it to do a function or a job, but after training, we lock it down to be a static piece of software, which is 100% deterministic. And that will allow us to define clearly the intended behavior as well as to understand the unintended behavior that we can channel up to the system level, that we can assess system safety. And the learning AI, just together with the industry and together with EASA and other authority, we decided that is for the future, but not for now. So we will mention some of the research in dealing with that for the future, but for policy for now, we decided just to deal with the learned AI. And from the engineering perspective, we like to use as much existing regulation as possible. There's no point of reinventing the same thing that we had before, that we have good safety record on it. So we like to use as much as possible. And that is consistent with G34 from SAE 4 years ago, when they sat down and tried to identify the gap so that they will focus on what is missing from the existing regulation and guidance. And that is exactly what we are repeating here. One of the things that we like to be humble is that we like to admit we don't know everything. So with the new technology, we don't fully understand the evolving technology. So we are going to take an incremental approach, working with specific projects so that we can gain better understanding of the technology before we can generalize that into understanding and policy later. So at this point, we are dealing with specific projects, many of them. So that is the topic of one of the meetings that we are organizing, and we are organizing the next meeting in July 24th and 25th at in the McLean, Virginia, at MITRE facility, and we would like to extend the invitation to everybody to participate. We are going to go with the Learn AI for now, and once we have better understanding, then we will move into the area of learning AI. Right now, we are working with regulation on adaptive control to see how an evolving algorithm can be accepted and certified. And from that experience, we like to see if we can gain something that can be applied to learning AI. Right now, similar to EASA, we begin with something that at a very low criticality level on the safety continuum, something that make it easier for us to study without impacting the life of people. So that's where we begin another incremental approach, but on the safety continuum, we will fully investigate things, even though it might not be relevant on the low criticality, but we hope that what we understand from that experience will allow us to move to the next level of criticality. And we work with the industry. We saw many familiar faces from different companies who work with the US FAA, who extended their resources to help us understand AI, ML, and analytic capability. So similar to the EU AI Act, we have the US executive order in AI, and that is treating AI across the use of AI across different US government agencies. Fortunately, the US government assigned the National Institute of Standards and Technology to manage this effort. And from there, they begin focusing on safety in aviation with the responsibility to the FAA. So we are given a much simpler task, less difficult but not easy. And at this point, you can see that we are focusing on safety in aviation, and our philosophy in safety is that if we can provide a safety record, we will earn the public trust. And that's our philosophy. In the background, we are working on research, and the research is the important instrument helping us to move forward. So when we work with research, we started with the current projects that we work with the industry. And what we found out is that working with those projects, people often ask us, how are we going to do this? The thing that we ask them to comply. And the more we explain to the industry partner, the more it came to me that we have to use computer to analyze the AI software because it's so complex that human cannot visualize. We are trained with visualized things in the 3-dimension world that we live in. Anything beyond 3 dimensions is very difficult to visualize. And the more I explain in terms of computer algorithm, the more confusion I created. But it gave me an idea. I try to summarize it into saying that we need to think in like AI to regulate AI. And that gives us an idea, can we use AI to improve safety? And that is the current hot topic that we are pursuing in research. We don't have unlimited resources. So every year, you know that we have to go through congressional budget to get money to operate, and some money will be allocated to research. So in order to maximize the utility of the money, we partner with all the US government agency so that we don't have to repeat the thing all the agency might have already been doing. So that's our strategy, and we expect it to have some result in a year or two in low level of Dow C, and before we move forward with higher level of criticality. So in 2024, we expect it to have the first version of the roadmap, but we are not alone. We like to recognize that EASA has been pioneering the roadmap for about 4 years ahead of us. And we learned a lot from conversation with EASA, with the roadmap that they had 4 years ago, and the new version 2 that just came out. So we recognize that the roadmap is not a fixed document. It will be an evolving document. As soon as we have better understanding, we will be updating the document. And in the background, we work with G34 from SAE, hoping that there will be a standard for us to use to move forward. So in conclusion, the roadmap is something that we will be using at the FAA to guide our action on research, policy development, and standard priority and workforce preparation. And we recognize that feedback is important. And this is where we like to work with everybody to hear from everybody so that we can move forward together, and we will be evolving our strategy in the roadmap and the work plan. And we are learning from the initial projects, but we will also be learning from the research. Some of that we are funding, some of that we do joint research with the industry, and we are working with all the regulation authority to have a clear understanding so that we can work together and have a mutually acceptance of design approval at this point. And thank you very much for listening to our FAA roadmap.
Thank you very much. And just a reminder that you have an opportunity to ask questions to all of the speakers in this session when we get to the end of this particular run. So our next speaker comes from Airbus. We've had quite a lot of discussion about standards, and he is chairing the EUROCAE and SA working groups on AI standards. Thank you.
Thank you very much, and thank you, EASA, to welcome us. So thank you, Guillaume. So speaking about the working group 114 and G44 is talking about 5 years in 5 years of activities. In 10 minutes, it will be a challenge. Thank you, Guillaume. So it's about joint EUROCAE working group 114, SAE G44. So both groups were born in 2019, and they were a joint group as in 2020. The co-chairs are listed here. We have in the room with us Fatih Kakai from Thales, Mark Robos from Skyfred, and of course Gary Brown. Everybody knows Gary. Our objective will be, of course, to define the first AI ML standards to support the development and the certification and approval of aeronautical products based on AI technology. The scope will be twofold: airborne and ATM ANS domain for manned and unmanned aircraft. The scope of our first issue will be only and will be reduced to the offline supervised mode, supervised machine learning. Machine learning in supervised mode, and our first release will be next year. So this is a very huge and worldwide group. You've got here, I don't know, pretty comprehensive list of all the members. What we have been doing since 5 years. So first we structure the working group, of course, and then we spend 2 years to identify the concerns, to align all the industry about the concerns, to know more about the use case presented by the industry. And so we produce our first document, which was called Statement of Concern. In 2021, we start capturing the regulatory requirements from EASA Conseil paper, of course, and we define the scope of our standard. Then we define a strategy, how integrated this new standard in the aeronautical ecosystem, and there is a specific slide on that just after. And we work on the specifics of AI, the core document, what are the high-level trustworthiness properties for a machine learning model. And like any other standards, we define engineering processes with objectives and activities. And at the end, we modulate this objective according to the safety criticality. Front of us today, there are reviews, ballots, and open consultation, which will lead us to the first issue of the standard next year. What could be a future certification framework from an airborne standpoint? So I think you know the two first level of regulation consideration. So I will talk about the industry response as means of compliance. So there will be three levels of engineering. First level is the system level. Of course, you are in a system developing a classical system. At some point in your architecture, you are identifying one ML-based function. And this ML-based function will be developed using the new standard, ED 324 ARP 6983, which define a specific concept called ML constituent, which will support the development of the ML-based function. And at the end of the day, this ML constituent is actually item container. So at the end of the day, it will be the development of already known items, software or hardware items, so using DO178 or DO254 for the item. So We are in the middle, in between system and item. We have introduced a new concept of ML constituent, which is a bit a container of item. If we dive a little bit in the standard processes as it is described today in the ERP 6983. So it's a diagram of processes and artifacts. In gray, you've got the existing guidance, and in white, the new guidance. You can recognize the three levels of engineering: system, ML constituent, and item. It's a W shape. The first V is for the design. The second V is for the implementation. On the first V, you have first a MLC, machine learning constituent requirement capture. It starts with a level of requirements, and then you are going to the data management. You are going to produce your data, your data sets, in order to, and then, design your model and train your model using your data sets. At the end of the first V, you've got also validation and verification activities. And then you have something which we call ML model data description, plus, yes, very important, data pre and post processing. It's not only ML model, but also data processing, pre and post processing, in order to have a complete function. And at this stage, no training anymore. Okay, we are going to go into the implementation phase. It starts with a MLC design, MLC physical architecture design, meaning how many items do we need in order to implement this ML models. So it can be only one item, very simple, or several combination of hardware and software items. We have the flexibility to do what we want. But when all these items are defined, specified, then we can go to the development of these items using the classical DO178 or DO254, should it be software or hardware item. When these items are developed, we integrate all these items. So going back to the ML constituent process, MLC integration and verification, to have an integrated machine learning constituent and then deliver to the system. My last slide. So main takeaway we can have today. So first, our committee drove its expertise from international experts of the aeronautical industry. A lot of disciplines, of course, machine learning, but also safety, system engineering, software and hardware engineering, and of course, certification. So we create the condition of cross-fertilization into all these domains. It is, since the beginning, a very fruitful cooperation and cross-fertilization with EASA, which is involved since the beginning. We are pretty aligned today regarding the Conseil paper for level 1, of course. So some remaining consistency issues, but they are in the process to be resolved. And the committee is also working with FAA. And really, we want to. We really want to FAA to be involved with the development of the standards, and we want to closely work with the FAA and trying to align the future standard with the FAA roadmap. This new standard will be really the cornerstone of the integration of AI. It has been built by the industry, for the industry, with a permanent, constructive and fruitful dialogue with a representative of the authorities. Of course, we are very interested by sharing our experience with other fields such as automotive, defense, railway, and space. Thank you.
Thank you very much. And so for the last intervention now for this session, I'd like to welcome back to the stage our colleague Giovanni Cima.
Thank you very much. Good morning, everyone. My name is Giovanni Cima, and on top of my primary job at EASA, which is senior expert for air operations, I'm part of the AI program team, where I do the overall coordination of the use cases. And now, just started, I will manage the rulemaking task, which I am presenting now. So, this is the rulemaking concept that was explained earlier this morning by Guillaume. So I will not repeat it, but you can see the main elements here. We have the mandate from the EU AI Act to regulate AI in aviation through the basic regulation and then cascading down to the various aviation domains and taking into account the technical standards. The plan we have in mind to do that is what you see on the right part of the slide. It is a 3-year plan, which is made of several steps according to the rulemaking process that we have in place at EASA. The first of which is the publication of the TOR, which we just did a couple of weeks ago. So far we are on track. And then we are planning to have a first deliverable next year with an MPA for the anticipated Part AI and the generic AMCs. And later on during the year, we will have a second MPA making the necessary links to the aviation domains. This will be followed further on in 2026 by an opinion, which is the last step of the EASA rulemaking process. But it's not the end of the story, because it will be followed by the adoption of the rules by the legislator, which is the Commission, together with the member states, because we are only a technical agency, we are not a legislator. So we may propose amendment to the rules or new rules, but then it's up to the political level to adopt them. And then once this is done, we'll complement it with the necessary AMCs, means of compliance and guidance material. So going a bit more into the details, this is the link that you can find on our website to the terms of reference of the rulemaking task 742, a number that will become familiar to most of you for the next 3 years. And the terms of reference, like I said, is the first step of the rulemaking process, and it is a very short and concise document, a one-pager in this case, which defines the objectives of the rulemaking task, the affected regulations, and the working method that we will use to achieve these objectives, that in this case are 3. The first is to ensure artificial intelligence trustworthiness for its safe use in aviation, and this is directly in response to the EU AI Act. And then the other 2 objectives is to enable the deployment of AI in the various domains of aviation, starting with the first aviations identified by the Article 108 of the AI Act, and then cascading down to the other aviation domains that will most likely will be affected as well. The activities that we will do to do this will be centered around the concept paper, which will be the basis for what we will propose and the way we will achieve the objectives. More specifically, we foresee several subtasks. For objective 1, we will have one subtask to propose the so-called hard law, the implementing rules, and another one for the AMCs and guidance material. And then we will have a subsequent subtask for the objective 2 of the first batch of aviation domains affected by AI, and then another one for the remaining aviation domains. You can see in the left part of the slide the regulations that we anticipate to be affected by AI. You see that the impact is massive. It's basically the entire ecosystem of aviation. We have airworthiness, we have ATM, we have ops, we have the entire ecosystem. The way we want to do that is the working method, the rulemaking task, is with the help of experts. We will have a rulemaking group, and like in every rulemaking task, we intend to conduct an impact assessment that it is indicated light year, not in the sense that we underestimate it, but in the sense that the concept to develop a parte AI is already set at the legislative level by the AI Act. So we don't need to question that. What we have to question is further down the impact on the various domains, and this will be the main part of the impact assessment. The MPAs that we will publish will be of course subject to public consultation, and then we will of course assess the comments received and take them into account for the following steps of the process. So I would like now to explain a bit more in details what will be the content of the rulemaking task. What you see here is what we have today. We have the existing regulatory framework for aviation in Europe, which is made by the basic regulation and then cascading down to the various implementing rules for each aviation domain. And then we have the concept paper that was recently amended this year. We have published in March the edition 2, which is now going at level 2. And the question is, where do we go from here? So we have therefore the rulemaking task 742, which will create the parte AI. And in doing this, we will take all the important elements of the concept paper to build this part where we anticipate to have 3 subparts. The technical requirements, the authority requirements for the competent authorities that will have to oversee the use of AI in aviation, and the organization requirements for all the organizations that will be intending to deploy artificial intelligence in their respective domain. And this will be supported by a set of generic AI means of compliance and guidance material, which will be descending directly from the concept paper. And of course, it will be further adapted during the rulemaking process. So after that, again, we will transfer the elements that are relevant to each aviation domain to create the necessary hooks that will allow the deployment of AI in aviation. And this is a process that somehow has already started, because most of you will be aware that we have a special condition for certification of a level 1 AI application, which we are starting to use. And it was shown earlier this morning that there are already applications in progress, and we target to have the first level 1 certification next year. And this work will continue. And this, of course, is embedded in the general context of the AI Act, and which will also affect other domains. What I would like to make clear now is that we don't want to over-regulate. We would like to avoid double certification, and we would like to keep parte AI as light as possible, so that it can be a real enabler for the deployment of AI in aviation. And one last slide is to conclude on the work we are doing right now after the publication of the terms of reference, because attached to it, we proposed an initial list of experts for the rulemaking group. And the way we have identified those experts is along 2 axes. We intended to cover all the aviation domain impacted, and you have a selection here. And we also wanted to cover the impacted disciplines in AI. So we submitted this initial list of key experts that we knew to the EASA advisory bodies, the MAB and the SAB, which is the member states advisory body, and the stakeholders advisory bodies, which represents mainly industry. And we are now collecting feedback to get proposals and comments and possibly improve and integrate the composition of the final rulemaking group that will allow us to kick off the activity in September. And this concludes the presentation. We will take questions later.
Okay.
So thank you very much, Giovanni. Thank you also to all the speakers for this second part of the morning. We take now indeed the Q&A, or we enter the Q&A session. Let me see, we have until 12:30 actually, so yeah, plenty of time. We are a bit ahead of time. That's good. We will have the capacity to treat more questions, and that's great because I saw a number piling up. The Slido has the capability also, some of you have seen, to upvote some questions. If you have the same question, instead of writing it a second time, you can upvote. I see that it's mostly used, but just to highlight it to people that would not have seen it. And taking the questions actually in the popularity order, the first one probably will be for me. I may have missed it in the introduction, but are we confusing automation with AI? Or was Peter, or it could be also for Peter, but probably I was also talking on the same topic. Was Peter talking about two different levels from EASA, automation and AI? As I mentioned in the part of presentation I had before entering this block here, we really treat AI and automation in the AI roadmap. That's one element. Now we do separate. AI is an enabler. Automation is really the type of operation that you can get out of it. It doesn't mean AI necessarily, but it is driven, if we think advanced automation, by AI. So this is what I had on the last slide, a bit on the side to really clarify. And one thing I didn't say also on the slide, autonomy is a big word. Autonomy is used also in many schemes, is used also in the AI Act. This is another term we need to clarify in some way. Autonomy for us means something, we use the ISO definition, in fact. It's some systems that may set themselves their own rules, let's say goals or usage domain. And that's something that is extremely advanced compared to what we would accept or we could certify today. Therefore, autonomy for us is kind of a level 4. Let's think about it much later, whenever possible or practicable or necessary. But at least from now up to 3B, we are in advanced automation. So yes, we have a roadmap of automation within the AI roadmap. That's again by the nature of things. And the very important clarification will happen in what Giovanni was showing in the rulemaking. In the rulemaking, we will need to architecture all of that so that it fits in the different regulations or regulatory framework in a way that is. So at the end of the day, we will kind of separate. We will have the central generic AI building block in the middle with AMC GM that will be referentiable from the different framework, and each framework, of course, will live its life with all the automation roadmaps that are undergoing in the different regulatory framework. So not to mix things, but yes, the AI roadmap really addresses actually both. The concept paper does go over the fence of AI, but again on a consistent manner. So it's not a clarification we want to bring in the concept paper, but more in the rulemaking. Very important, I think, question. Thanks for that. Just trying to see the next one. The next one is for you, Trang. Thank you for the flash talk. By the way, I'm sorry about it. I was about to release the thing so you can see the question. That's even better. Yeah, so the question is for you, Trang. Thank you for the flash talk. With the FAA roadmap, share the EASA's roadmap AI levels. I'll let you take the mic.
One thing that I did not mention when I shared the roadmap is that we do have another roadmap for automation that is in the background, developed by Dr. Kathy Albert, our chief scientist in human factor. So we separated AI from automation because we recognize that automation can be done without AI. So when we look at EASA AI level, we realize more about automation. So I will refer that to Dr. Kathy Albert, who will be talking more about automation roadmap later on when it's more mature. But for now, we work on AI mainly seeing AI as an engineering component, especially with the lockdown learned AI is allowing us to manage it the way we manage existing engineering component, maybe with additional consideration that existing guidance and regulation cannot handle. But as far as EASA AI level, I think it's more corresponding with the automation that we will be talking later on.
Thank you very much, Trang, for the clarification. So I would go to the next question. How is human oversight ensured in a level 2B application? The authority of the end user is partially limited. Some systems operate autonomously. So I think it's a question for you, René.
Yeah, thank you. I wouldn't say the end user is partially limited. Some authority is given to the machine, actually, where we have the partially limited authority on the end user. That's 3A. But how do we ensure it? Yes, indeed. As we said, it is still the human who in the end takes the decisions and the human who has the full responsibility. Oh, in both, in 2A and 2B level. I don't know, maybe Guillaume, if you want to complement.
No, I think you said it. The point maybe behind the question, which I get, is it's a matter of operational capabilities to ensure that. So we are kind of setting limitations in saying that the full responsibility is on the end user. Possibly we kind of limit the capability to defer to the system of systems more operational capabilities. It's true, but it's the way we could at least put a limitation to enable the capability to certify 2A and 2B in good conditions today. After, when we progress on 3A together, we will probably find out other things that might revert back, to the level 2B. So probably it's not bounding forever, but the authority released to the system is really to enable different type of operation. The responsibility is overseen and overrideable. From the start, we always said that the human keeps this capability. Again, it's limitative, but it's fine to at least process the first applications. We are more at the level of seeing the first 2A applications coming in, but not yet 2B. So probably the timeline and the complexity of the type of systems will also give us a bit of time to think a bit further. But that's the way we have said. We release partial authority, but we don't release the responsibility at this stage. Okay, thanks for that. The next one would be, how do RMT 0742 link with WG114? Looks like WG114 decreased their ambition to provide AMCs. So I don't know, Giovanni, if you want to take it or if you want me to answer.
Yeah. Maybe I can start and then you complement. Okay. Yes. So I think there is not a direct link between the working group and the rulemaking task 742. There is more a link between the working group and the concept paper, because this is where the technical standards are defined. The scope of the rulemaking task is a bit wider because it also takes into account certain rules for competent authorities and for organizations. Plus, it will establish the hooks with the various aviation domains where AI is intended to be deployed.
Yes, thanks, Giovanni. So in the big picture, I agree. There is RMT 0742 is much wider than the standard we are dealing with, WG114 for now. But the hook or the link will be created by an AMC, let's call it learning assurance, which will recognize the standard. Hopefully, if the standard is released on time, and that's what we are all striving for. So there is a strong connection between the concept paper and the working group today to align as much as we can to prepare this step of having an AMC recognizing the standard and hopefully the lightest AMC possible. So this is the, I mean, the strong link we can anticipate within 742. And maybe for the second question, I don't think there is any decreased ambition from the working group side, but I will let Christophe, maybe if you want to complement.
No, I think first mission is to release something next year. Again, the scope is reduced to machine learning, offline machine learning in supervised mode, and then we will deal with the other AI techniques, ML techniques in the coming version of the standard.
Yes, and maybe to mention, you started SG8, subgroup 8 on human factors. So you perform more the statement of concern on that side, which will fuel other building blocks.
Exactly.
Right?
So to deal with AI level 2, yes. So we created a specific group, subgroup in the working group in order to address what human factor, what do we need in terms of human factor in order to address AI level 2.
Thank you. Thank you, Christophe. Maybe just reading it again, this notion of ambition to provide AMCs, the AMCs are provided by EASA by the nature of things. So the working group was never working on an AMC, but on an industry standard that can be recognized in an AMC. So I think we are fully aligned, and there is, I mean, the ambition for me is as high as it can be. Thank you. Next question is for you, Trang. You have mentioned the way to build trust is to focus on the safety record. Your thoughts on other ways of trust building, for instance, transparency, explainability?
I think this is a very good question that gives up a lot of time for discussion. When I mentioned trust, I meant to say that we don't regulate trust. We like to earn trust with what we can regulate, which is the safety of the aircraft. So that's the clarification. But as far as the question that went on with transparency and explainability, this is an issue of AI about explainability. When the developer presented us with their application, the first thing we ask is that what does it do? What is the functional requirement? Something that we can go on and verify and validate within the scheme work of the guidance that we already have. And that is where the lack of explainability became very apparent. And what we are working with for explainability is how to build the understanding of AI, what can it do? So that's why I mentioned we are focusing on learned AI, which is consistent with the industry's consensus and which is consistent with EASA, where if we lock down the system, then it becomes a piece of static software that does the same thing every time that you provide the same input. So that is something that we like to understand, something that can help us establish the functionality of that system, something that helps us to understand the intended behavior that is so defined in LRP 4754 and GO 178. And we can also establish what they call unintended behavior, something that helps us to channel up to the system level so that we can analyze the risk. And that is something that will be the topic of our conversation in the next meeting. But as far as trust is concerned, it's something we have to earn, not something we regulate.
Thank you very much, Trang. Next one I voted would be the AI Act does not apply if products are covered by union harmonization legislation, sectorial. Which use cases are not subject to AI Act in aviation? So this is let's say, a question we could, it's a very relevant question, but it could go very wide in the sense that we need to clarify that in the Part AI. That's really the simple answer to this question, saying, yes, the AI Act gives us a mandate per Article 108. Yes, it concerns IRIS systems, Of course, the level after is what is high-risk system? What do we do with minimal or transparency risk system, etc., etc. So it could go on for a long time in the sense that it is part of the rulemaking task. We will have to manage that. We will propose a text mid of next year with the first NPA. And from that, you will see all the clarification of how to use AI, I would say, at different level of risk from an AI Act perspective, translated into aviation wording and understanding. So I would say bear with us with this one, but it's a very, very relevant question. The next one is how can the full responsibility remain with the end user within 2B applications? Some information and parts of the decision process are not influenceable. So René, I don't know if you want to say a word about it.
I think, well, it's a bit similar to the previous one, isn't it? So again, it is defined in the entire level 2, so 2B as well, that the end user has the full responsibility. Information is provided, but this is a provision of information, and parts of the decision process are not influenceable. I'm not sure to understand. Again, it is designed in a way that the human still is able to override and take the or has the responsibility of the final decision. It's not like in 3A that the human is notified by the system to do something. Here it's still all under human responsibility. I do not know what to.
It's also a bit unknown ground. As we said, we don't have compelling use case level 2B today on the table. We have a Proxima use case developed as a virtual use case in the concept paper as a kind of anticipation from our human factors colleagues, what could come, but the contour needs to be defined. So definitely we are conservative also on this side, saying that the full responsibility is with the end user means that we need to ensure that the operation is compatible and commensurate with that. And that's, again, a limitation in itself. Investigating 3A will give us more tools to go back and see how to shape this partial authority release in terms of responsibility if necessary. But maybe we can stay where we are with responsibility full on the end user, and then the operation needs to be tailored for that. This is really, let's say, unknown ground, which we investigate. That's another part of the exploration, to be clear. Thanks, René. Perfect. So what is the difference? Oh, no, it was voted in between. Let me stick to this one. Wouldn't it make sense to separate automation from AI on the one hand and consider automation from the functional level on the other? Yes, I would say it's another way of approaching it. As Troy just mentioned, and they have an AI roadmap and they have an automation roadmap. I think if you take the picture of the two, we have an AI roadmap which contains the AI block in some way, the AI assurance block. And then we are thinking automation enabled by AI at large in order to go for human factors, ethics, etc. So I think it's a way of presenting things. The difficulty we have is, and that's the beauty of the level 1, 2, 3, is we cannot disconnect easily one from the other. If we start treating only the technical bit on the side and the automation on the other, we will probably have a hard time in the RMT 742 to reconcile the two views. If we have a generic thinking that we provide again with a level 1, 2, 3, and all the guidance that is consistent, because there are connection between the human factors, the AI assurance, the ethics, everything is cross-connected in the concept paper. That's the reason why we are let's say, managing it in one step. If we try to separate in the concept paper, it will be, let's say, a massive work for probably nothing. Let's do it again in the rulemaking, but we will have, with the levels of AI, a thinking that someone is not mistakenly taking a level 3 for a level 1, let's say. And that's very, very different in terms of operation, very different. We can safely, with no problem, go for a certification level 1 with all the technical difficulties, of course, on the machine learning side, on the explainability side, etc. Today we can go because we have the end user, because we have the assistance element in the operation. If we go directly 3B, someone can mistakenly take a level 3B for a level 1. Let's say detect and avoid type of assistance. It can be an assistant to a pilot. The pilot has the responsibility to avoid or not. And it can be 3B, automatic avoidance. But we are not there yet technologically. So let's manage, let's say, expectation, again, on the side of AI and automation at once. That's what we try to do consistently in the concept paper. And then the rulemaking will, again, create the puzzle in the right way so that everyone finds his final view in the regulation, in the lightest way possible. That's what Giovanni insisted on. Oh, yes. Yes, please, Frank, it's a discussion, yes.
In the US, we recognize that there's no right way or wrong way to do it, but we recognize that, at least from my perspective, as an engineer, I normally try what we call divide and conquer. When we have a complex task, we like to divide that into simpler components, and we'll begin at one component. It's not a clean division between AI and automation, but we want to focus on AI at this point so that we can provide more understanding to build up automation. So that's our philosophy, but I like to emphasize that there's no right way or wrong way to do it. It's just that our preference is to do something simple first and do a good job before we extend it. And that is consistent with our incremental approach, not trying to solve everything at the same time. So no right way, no wrong way. It's just a preference.
Yeah, thank you, Frank, for the precision. The next one would be, could you precise why learned AI could create deterministic algorithms? I'm not sure of that. I think it's also a question for you, Frank, if I remember well. The learned AI is your terminology.
If you consider a simple neural net, once you train it, then it means that all the weight constants that you capture through the training data will remain static. So everything is just 100% computational. It means that when you have an input going to the neural net, after you train and lock it down, you always have the unique output correspond to the input you provide. So that's what we mean by deterministic. We know exactly what is the output given the input. So that will allow us to establish what we call intended behavior as defined by DO 178 and ARP 4754. The thing that we have to do in the framework of V&V of software. And when we implement the neural net, that becomes the software with input and output. And DO 178 mentioned explicitly that the algorithm can be 100% computational, which is exactly the case for implementing the model that we lock down, that we know exactly what are the constant multiplication with constant, and then pass through a function. So that is 100% deterministic, and we intend to have example in our next meeting to clarify this point. And that is the key point that we like to focus on, is 100% deterministic. So we shouldn't be worried. We should only focus on what we can do at this point. And that, instead of talking about the philosophy, whether it's deterministic or not deterministic, we intend it to have specific example that everybody can visualize. And that will be our next, in the discussion of our next meeting in July 24th and 25th.
Thank you, Trang. I think this topic is a thing we are discussing for a long time. We on the other side, we try to avoid the notion of determinism because it depends at which level you look at it. Indeed, freezing a model from a mathematical perspective brings certain determinism, but if we think the machine learning and the learning assurance at large, it's not the only uncertainty element, let's say, that we have to consider. So this is where I think it's kind of yes, it's a first reassurance, let's say, to have this, and we share the condition to freeze models for now, learned AI, I think, as you call it. But after, there is a lot of consideration behind. Great, thank you for that. And I saw several questions piling up on the same topic, so maybe let's see. We have several to go. I'm trying to cope here. Up. The next upvoted one would be, again, for you, Trang, what is FAA opinion on the NIST AI risk framework and playbook? Can it be used for AI in aviation?
This is a difficult question for me because, as I mentioned, we focus mainly on regulation of safety in aviation. We do participate in the NIST conversation, but the participation is focusing on us bringing our understanding of what is AI that we learn through the regulation in aviation to the table so that they can generalize that to the bigger framework. And we are not trying to bring the bigger framework that address different domain into aviation. So that's the clear distinction of our role within the discussion with NIST. We don't want to force down everything that might not be relevant to aviation into aviation. We want to bring our understanding of AI into the discussion to see if it can be generalized into the broader framework.
Thank you. Thanks for the clarification. Next one would be, suppose I have an application deploying AI, which guidance should I follow to make it certified? Should it be the guidance from EASA or the standard from EUROCAE? So let's say, it's a stepwise approach. So we start rulemaking in order to clarify exactly this question. In the future, we will have an AMC, let's call it learning assurance, recognizing hopefully the standard in development in WG114 as G34. That's where we go. For now, the standard is not in publication or not published yet. It is in process to go to ballot. So meaning we cannot use the standard from an EASA perspective. So what do? We raise and leverage special conditions in order to clarify the usage of the certain subset of the concept paper objectives tailored to specific applications. We started on the general aviation side because the first level 1 topics came from that side. We are moving probably in September for a consultation on an update of this special condition, as Maria mentioned in her introductory speech, just to recognize the need for other products, let's say, in particular large aircraft, but not only. We have, of course, rotorcraft, we have VTOLs also eVTOLs to take into account. So we will try to do one single update of the special condition for all products, if that works. If that doesn't work, then we will kind of start large aircraft and go further. So the special condition, to answer the question concretely, is the only way to do today to leverage requirements in certification that are complementing the current certification specifications. Okay, so that's the SC, the special condition path that anyone has to go. We don't have the standard yet, and you don't certify. First, you don't certify a system, you certify a product, so an aircraft, an engine, etc. And you never certify per standard. The standard needs to be first acceptable means of compliance through an AMC, and that's what we will do with the rulemaking. So, long story cut short, special condition today. That's the reference point for certification. A question about U-Space. So U-Space is about managing a wide variety of drone operations. At what AI level can U-Space operations be classified? That's a tough question. I would say it's a case-by-case, exactly like François would say, case-by-case classification. As usual, very important to say, you have to consider the system and the operation, again, as two different things. So the AI enabler and the big picture of the operation. So possibly we may classify, or we may have in use space, I don't know, a level 1 for assistance in some element, but because we don't have a human in the loop, probably it will jump very rapidly to level 3B. And that's probably let's say the final call we will get to any application. That's why precaution also oblige. We cannot today put the requirements on the table. So we are working with our use space colleagues on use cases to pave the way also to level 3B. So it's part of all the perspective that we open today. And we cannot certify today a level 3B. That would be presumptuous. Thank you for the talks and thank you for the comment. How do EASA and EuroCAE align their respective works? So I think that was mentioned by you, Christophe. I don't know if you want to expand. I mean, we participate in the working group as much as we can. We have a very good level of alignment. As you mentioned, we have still remaining issues to solve, but I let you
yes, from the EASA standpoint, I think, yes, we have some remaining issues regarding the concept paper, regarding FAA roadmap. So we have the willing to collaborate each other in order to align our standard that is a mature draft today to the EASA the FAA roadmap, but it's something ongoing.
Thank you, Christophe. The next one is very interesting. The difference between authority and responsibility. So, as usual, definition matters. So the concept paper, in the concept paper, we have crystallized two definitions that are different from each other for authority and responsibility. This is a set of definitions. It doesn't mean we are ruling forever what is the understanding of responsibility. The train of thought we had to create those two definitions is authority is the capability to make a decision. The system may or may not have this. A human has this, and this is where we are on the authority, and all what René presented related to the partial or full authority on the one hand and partial authority release at level 2B. Responsibility is another step, let's say, or layer that is more connected to accountability in the background, again, liability. We want to disconnect the two. We don't want to say, because let's put it with the absurd reasoning. If we say we cannot release authority at level 2, then we say full authority, and then we kind of limit even more the possible applications because we stop at level 2A, let's put it this way. If we want to enable what extended minimal crew operation, what ATM roadmaps are bringing, we need to think a bit further. Can we release the responsibility? Actually, no, because else we cannot certify today. Can we release the authority? Yes, because if we don't do, we cannot sustain or provide the tools and the meanings to get to this type of operation. So it's again a perspective here. It's not, we are not enforcing a way of thinking. We are saying, if EASA, we want to accompany this type of novel operations, we need to think a bit larger and we need to release a bit of the authority to the system, yet again under the very strong assumption and limitation that the authority remains with the pilot if it's about airworthiness, with the air traffic controller if it's about traffic management, etc. So this is again, it's a strong assumption. I don't claim it is forever and I don't claim it is the only way, but this is the way we could release the level 2, issue 2 of the concept paper without leaving a big portion open, let's say. But it's open from perspective, from the perspective. We have to work on it. It's another investigation ongoing. That's what we have today in the definition. Look at the concept paper, and if you have comments, we can, of course, rediscuss that when preparing the issue 3. Is there already a definition for end user? Is it required to be a human, or can it be as well a legal entity? Yes, that's a very, very crucial question. First, a disclaimer, end user, we use it from a framework, which is the ALTAI, which the assessment list for trustworthy AI, which we initially looked at for most of all for the ethics-based assessment. This triggered a thinking between user and end user first. In this document, end user is the one interacting with the system in operation. It is a human. Just to answer one part of the question, cannot be a legal entity, it's a human, full stop. So the end user is a human. The user is the set of people interacting with the system at any time. Development teams, designers, etc., authorities for certification, investigation bodies for when there is an incident or accident investigation, etc. This is the large spectrum of people that can need something. And how did we tailor it in the concept paper? We split it between development explainability and operational explainability. Development explainability is for anyone wanting to understand how the system comes to a certain outcome. Operational explainability is focused on the end user. That's exactly what René presented in her slide, the necessary information to provide. So to give you, let's say, an understanding of how we split the guidance, we have really this end user concept that is extremely present and for ethics-based assessment as well. Doing that, we had a hard time when the EU AI Act final text came, because it talks about user, not about end user at all. So we are probably misaligned with the AI Act from a top-level perspective. They consider user and end user packaging. We have two terms. We, for now, keep the two terms. We will see in rulemaking if it makes the case. That's, of course, a discussion. But we keep the two terms because they clarify so much the split of guidance. Some objectives apply really to one and not to the other, etc. So this is really where we are. So it's a human for sure. And it cannot be a legal entity. And what is the definition? Please, again, look at the concept paper. Is there a mapping between software assurance level, ALDAL-SWAL, and AI level? Maybe François, if you want to take this one.
Yes, so no, there is no mapping between the software assurance as we know them and the AI levels. This is the proportionality table that you can find in chapter D of the concept paper, elaborate on the proportionality that will come first with the criticality of the application, so the assurance level, and in the second part of the table, how the classification, the AI level, will drive the applicability of the objectives, mainly from an explainability perspective and human factors perspective. So there is no mapping between the assurance level and the AI level. You could imagine that you have a level 1A application that is safety critical. And on the contrary, you could imagine level 2 applications that has only minor effects on from looking at it from a safety perspective. So,
thank you. Perfect, François. Thanks for the clarification. I see that we are getting over time and we have still a long list. So if we had 2 or 3, I would rush. But let's answer just one last one, and then we can all discuss at the break. Very interesting and perspective-oriented one. With the speed of development of AI, do you think that the proposed timelines for setting up the rules and guidance can keep pace with the advancement of AI? That's a crucial question. I would say we don't claim that we keep pace. That's why we have a pushing barriers phase 3 after 2028. In the meantime, we claim that we keep pace with the needs from our aviation stakeholders. This is what we try to do. Each time we raise a new slide and topic like the generative AI usage in operational tooling, etc., this is because we get, let's say, feedback that there is a need. So we try to onboard everything we can. Clearly, we are not, let's say, an AI agency. We are a safety agency. Therefore, we are not trying to keep pace with technology, but we keep an eye on it. But we take it, let's say, we take the pace from what industry at large is bringing us back, all our stakeholders, our applicants. And this is the, let's say, the ambition of the roadmap and the AI program today. And let's push barriers all together in after 2028. Thank you very much. We will stop here. I let you the floor, Janet. Thank you very much.
Thank you very much. I think that was a very stimulating and interesting discussion. I'm sure you could have gone on right the way through lunch, really.
Absolutely.
But lunch is waiting for us, I hope, anyway. Also back in the Boeing room, so through the bistro and the back corner there. Thank you very much.
Shall we? Yeah. Okay, so we are ready to start again with the next session of our agenda. We have a panel now on use cases, and we will present you 5 use cases with the help of the presenters that you see here at the table, who have kindly accepted to join us and to present their own projects. We have Thales, Honeywell, Deep Blue, CIE, and Boeing with us today. But I will come back to the speakers in a moment. For the moment, I just want to spend a few introductory words on why we have a panel on use cases, because use cases are particularly important for the AI roadmap because they are the way we engage with stakeholders in a collaborative manner. Use cases are the way we have to test and possibly challenge our guidance. They are the way we have to learn and to improve and progress. And this slide that you see here, that you have probably seen in other presentations before, I like it particularly because every time that we show it, it's a little bit more populated than the time before. Just to highlight the interest, the growing interest that there is from all sectors and all stakeholders to engage with us to develop their use cases. And we do this in different ways. We do directly through innovation partnership contracts or memorandum of understandings, or even through actual applications. We do it through research projects under CESAR, for example, or under Horizon Europe. And in doing this, we close the feedback loop with the standardization bodies, because the use cases give us the feedback we need to improve the technical standards. So with this, I would like to invite on stage the first presenter of the day, who is Frédéric Barbaresco from Thales. He's an AI senior expert at Thales. He's in charge of advanced studies, coordination, and AI algorithms for the Thales Global Business Unit, Land and Air Systems, including Thales AMS. And today is going to present us Thales Land and Air use cases. Frédéric, the floor is yours.
Thank you. So I will present you 3 use cases of Thales. The 2 first are the more mature one, and a more exploratory one at the end. So the first one is reinforcement learning-based CDR for conflict detection and resolution. So what is CDR? CDR is to try to detect resolution of medium-term conflict detection. So classically, we use a 4-day flight plan-based estimated trajectory, and we have to detect minimum separation, so horizontal 5 nautic and vertical 1,000 feet. So classical resolution is based on classical AI, so mainly research, like Monte Carlo research, for instance. So it's more explainable and configurable, but slow depending on the situation. And it's why we are exploring reinforcement learning, because we have fast inference, several resolution per second, potential to achieve more also optimal solution with enough development. But the main goal is to hybrid approach to develop a safe AI based on this RL approach. So I will show you a short video that we have presented at Eurocontrol AI Forum that illustrates the concept of hybrid AI based on reinforcement learning and classical algorithm. So here is the interface that we have for the conflict detection and resolution. So the principle is to detect conflict and to propose to the controller some solution. And the idea is to also mix classical and deep reinforcement learning to have in backup also the classical solution. For that, we have to reinvent also the simulation because we need intensive simulation to train on historical data the reinforcement learning algorithm. But we have also to integrate safe AI system constraint and so to develop the methodology for that. And so the idea is to also hybrid the classical and the hybrid. So the concept of reinforcement learning is to train a network to find clearance from system state, to simulate the clearance on an ATC simulator, and to model the impact of the clearance on as a cost function, and to learn to maximize the function using reinforcement learning. So here you have some illustration of the different criteria we have used for the reward. We have also to work on the data. So we have worked to build 1,000 seconds of realistic training scenario using historical data. But the main problem is that we have no conflict in recorded data because the controller has solved the conflicts. So we have to create this conflict and to have data augmentation to ensure the presence of separation loss. The simulation also is very intensive, and we have to use parallel computing fast simulation environments to have enough simulation to train the reinforcement learning algorithm. So training is, we have two main challenges. So for the training, we have developed a reproducible training pipeline from historical data to train model. We use a parallel simulation environment that continuously run scenario. We have monitor also with KPI the result during the training. We keep also the complete log of all the clearance for metrics. And also we have different tools for monitoring the scenario. So if you have the evolution of two KPI related to percentage of loss of separation on reward. And we work also how to integrate this kind of module of AI in a system with system integration constraint. So we have to deploy the trained model and connect it to existing CDR components, but also use the trained model as an additional solver. So it's why we keep the classical solver as a fallback system, and also validate the clearance by using the system probe function, and only display a validated solution. So we have a continuous check solution validity in time. So what is different in terms of validation? We can reuse some recommendation for machine learning because we have the same kind of development step for reinforcement learning. We have also a machine learning inside, so we are still using machine learning model. We can use historical data. We still need to objectively measure the model performances. We still need to test the trained model. But some requirements may be outside of reinforcement learning. So historical data is not always used. Validation datasets are not always available, and requirement should be expressed as a measure of the dataset outcomes rather than a measure of precision. For specific points, so there is specific point of for validation and qualification of RL, but I will not give all the detail. But we need a new type of validation, which is required to qualify the simulation environment first. We have also to validate the data. So we have three kinds of data: initial data, transition data, and live simulation data. And also we have for the Thales CDR AI use case specific advantage. So we have the system allow clearance probing to validate human or algo generating clearance using certified components. We could use human in the loop. So all clearance are displayed for human validation. On human validation is performed only on clearance that are also validated using the probe function. For the second use case, we work on deep learning based digital sequencer. So for arrival manager, AMAN. So in this case, so you are familiar with arrival manager. So this operational goal is to allocate flight delays across the different collaborative control centers. And so try to integrate in our product, which is called Top Sky Sequencer, this new technology of deep learning. So what is the main function on our capacity? So is to develop a prediction of ETA on flexibility window. So we have a first time to fly to the ACC flight point, and also we have to estimate the time to fly from ACC to APP boundary. And then a third model from APP entry point position on the flight allocated runway. And we have a flex window associated to this time to flight estimation. So we have developed a specific structure which is based on different tools for development of the model. So TensorFlow, which is classical, SkyData, which is an internal library developed by Thales to use to prepare aircon data, MLflow, which is an interface to monitor the evaluation metric during the training and test, Airflow, it is a task scheduler to execute the preparation. The monitoring, so we have developed our own monitoring tools and solution with Python script. And Certified AI is also a Thales test library that has been developed to easily test the implementation. Obviously, we are also taking into account so guidelines from EASA and standard draft. And also we follow the MLOps best practice to handle this kind of model life cycle. So we have developed an application of EASA guidance on EuroCAE working group. So we have defined operational domain design for our application, what to do in case of an event like a storm, what is the impact on the model output. We have also specified the machine learning constituent requirements. So we have defined more than 70 requirements. We have also to test the data quality attributes and also all high-level properties the model must satisfy, like stability, robustness. So we also beneficiate of the program Confiance.ai, so it is a French program with French industry, which has developed engineering tool for machine learning validation and qualification. And so we have selected some part of the methodology and some part of the tool of the Confiance.ai program for this project validation. So Thales is also a contributor in validation qualification of AI through the working group 114. We have also participated to a definition standard ED 324. And also we are in discussion also to improve this standard. And also this discussion on the standard are also source of inspiration for our French activities through the DEAL program in Toulouse on Confiance.ai program. And the last one is the last use case of Thales is what we call GEAN, PIN control and green operation. So GEAN for geometric informed neural network and PIN for physics informed neural network. It's what we call also analytical model informed neural network. So it's mainly to address green operation problem, and especially for the analysis of contrails. So we are working on the different technologies. So geometric informed neural network for the detection of contrails. So we are using, for instance, fisheye camera from Reuniwatt in electro-optic and infrared sources. We are working also on physics-informed neural networks to improve the model of contrails for their prediction, and in the future also on thermodynamic-informed neural network. So we are involved in different projects, a French-German project, which is called Contrails in the Climate System from Observation to Impact Modeling and Prediction, with DLR and DWLD on LATMOS and CNRS in France, and Réuniwatt. So mainly on the observation, on modelization of the phenomena. We are also involved in the BECOM project from Horizon Europe. BECOM means better contrails mitigation, where we work also on sensors for contrail detection and contrails modelization. And the last one is Concerto. So Thales is leading Concerto. Concerto is a program of CESAR, and it means dynamic collaboration to generalize eco-friendly trajectories. So it's more on the tactical part, how to optimize for green operation, the flow on the trajectory. Thank you for your attention.
Thank you very much, Frederic. And I didn't probably mention it before, but we will run now all the presentation in sequence. And then after that, we will have a short panel discussion and then a Q&A session. So the next speaker we have today is Pavel Kolcherek from Honeywell. Pavel is the principal scientist and cockpit architect for EU-based cockpit systems technologies at Honeywell Aerospace. He started working for the company in 2016 as human factor scientist in the advanced technology department. His research interests include human factor analysis, design on human-machine interfaces, human-computer interaction, and artificial intelligence. He has been in charge of the research and development of speech recognition, voice control, and natural languages processing technologies at Honeywell since 2016. Pavel, the floor is yours.
Hello, good afternoon. Okay, so I'll present a project that Honeywell leads. It's a CESAR project called Darwin. It's a project on a digital assistant for a pilot. And in this presentation, I decided that I will show the programmatics at the end, and that I will start with what we are actually trying to achieve in the project. So with a broader picture, what are the trends that we are going to address? I think that these are the obvious, but it gives us the floor from which we are designing this system. So first one is obviously the autonomy. So there was a lot of information on the autonomy already, and it's a big driver for any cockpit operation with increasing amount of information, with the complexity of the information, more of the traffic, changing generation of the pilots. This all calls for advanced automation in the cockpit. This goes hand in hand with the digitalization. So we need to transform all of the current aircraft system in a form that the machine is able to process it and is able to provide the human pilot the right assistance at the right time. And the last but not least, again, many thoughts was shared already on building the trust in AI. So this is one of the cornerstone of the project. And with these three drivers, we are expecting these four major safety benefits from the project. These safety benefits are related to the technologies that we are addressing in the project. So first one is to detect and mitigate pilot incapacitation. So when we have a pilot in the cockpit and automation on board, we need to have a system that is able to detect pilot incapacitation and other states. We need to manage pilot high workload in critical situations when the workload can go up. And also provide the support with the cross-check. So when you have your human copilot and when you have your automation, there must be a way how we can synchronize this this information together. And with these three benefits, we are trying to create and build a trust in this technology. So how we are envisioning the system from the human perspective, from the human pilot. So currently, we have a pilot in the cockpit, and we have a set of the automation assistants or set of the automation functions. So in the current cockpit, when we are referring it to the lower levels of the AI, so referring to the EASA roadmap, the pilots can trigger these parts, review the outputs, execute it. So what we are building in the project is the expandable skill set. So some kind of the, what we are referring to as a digital copilot, which is basically a system that is able to interconnect all of these assistants, provide the unified interface, and then via the human-machine teaming interface, the pilot can execute and work with the individual assistants. So in order to make this pilot's perspective real, we are designing in the project three technology enablers that are based on the artificial intelligence. So the first one is the pilot state and task load monitor. This is the component that allows to monitor of the physical pilot state, whether if pilot is awake, if it's drowsy, becoming or can fall asleep soon, or if the pilot is incapacitated. And another part of this component is able to predict increased task load along the flight planned route. So you can imagine that you are entering a busy sector. You have a complex part of the flight plan in front of you. So based on this and the information coming from the cockpit, we can estimate that at some certain point in time, there will be a busy period, and the automation can get ready for that. This enabler is based on machine learning, and it corresponds, when we are referring to the EASA roadmap, to level 1 assistance to human. The second technology enabler, the main one, is the human-machine teaming or human AI teaming. This is the component that basically refers to the level 2 of the EASA level. So we are designing a system that is capable of dynamically distribute the tasks between the pilot and the automation based on the environment conditions. So it means based on the pilot state, based on the task load, based on the state of the mission, weather, surrounding environment, etc. And the pilot can collaboratively work with the system, but still remain in the loop and is in charge of this system. So we still are thinking about it as how the pilot would really interact with the system for these given tasks. And in order to make these two enablers working together, we have another component which we call Trustworthy Machine Reasoning Platform. This is basically a software engine that glues all of these assistants and informations together and provides the means how the pilot can interact with the system. So it's a rule-based, transparent decision support via which we are also able, or are designing the system that we are able to provide the operational explainability. It means that when the pilot gets some suggestion from some function, from some automation, or from some assistant, the pilot should be also able to see why the automation has decided as it is decided and what is the rationale for that. So that there should be a short explanation for this. And this is a representative of the symbolic AI or knowledge-based AI. So this is something that, we hope that we'll explore a little bit more within the project with EASA. But for all of this concept, it's a crucial component. When we now paint these three enablers in a way how we envisioned it to be designed for the cockpit environment, so we have this three enablers. I see that we have some fonts issues. So currently, we have a cockpit, we have a pilot in the cockpit. The cockpit is connected to the environment, to the ATC surrounding traffic. And we split these three enablers in three phases, how the human usually process the information. So at the beginning, you gather information, you see some information. So this is represented by the enabler for a pilot state monitor. So in the project, we are developing this light gray boxes, pilot state monitor and task load monitor, and it's accompanied by another usual aircraft monitors about the vehicle state, etc. With this understanding of the situation, then we have the main component. This is the decision making or thinking part or decision support, whatever we would like to call it. So that's a core that is gathering the inputs and providing some suggestions to the human pilot in terms of what functions can be executed autonomously. It can offer some solution. If the pilot decides that because of the high workload, this task will be delegated to the automation, it can trigger it. So at the end, we have this third component. This is the acting or execution part. So with some human AI teaming interface and interface to the assistants. So when you look at this system as a whole, then we close the loop back from the interface to the pilot and add these small black parts, which is the machine reasoning or the rule-based system. So you can see here that as for all of the boxes, they are interconnected together and can provide the pilot with some right information at the right time. So that's a technical solution. So now for this programmatics, so Darwin is a 3-year project, started last year. So we are after 1 year of the execution, having 4 main partners, Honeywell leading the consortium, Pipistrel, DLR, and Eurocontrol. And we have the associated partners, Slovenia, Control, and EASA. And we are designing a system that we should validate it in the real environment with the flying aircraft on the Pipistrel's precursor in 2 years. So we are all looking forward to that, and hopefully that it will happen in time. So this is all from my side for the project. Thank you.
Thank you very much, Pavel. For the next presentation, I'm happy to welcome Simone Pozzi and Vanessa Rigoni from Deep Blue. Deep Blue is a research-intensive consulting firm based in Rome, in Italy, whose core expertise in human factor and safety in aviation and other safety-critical domains. Simone and Vanessa are the 2 coordinators of the HaiQ project that will be presented today. Simone, in particular, the CEO of Deep Blue, he has a long-standing experience in leading human-centered innovation projects and highly complexity sectors like aviation, space, and maritime. But consultant since 2015, her expertise covers the application of human factors in safety-critical systems, including aviation and healthcare. Simone, Vanessa, the floor is yours.
Thank you very much, and good afternoon, everybody. So we will present the HaiQ project. The HaiQ project is a research and innovation project funded by the Horizon Europe. It's a 3-year project started in September 2022, and so it will finish in August 2025. Basically, we are a human factors project. The goal is to develop AI-based intelligent assistant prototypes for aviation system. And of course, as human factors, our key challenge is to develop human-centric intelligent assistant. And when we say human-centered, for us means integrating human values, needs, abilities and limitation since early stages of design of our intelligent assistants. Indeed, we use a human-centered approach while designing our intelligent assistant. We consider the operational goals and humans' need, but also their desirability and societal acceptance, trying to find the place where AI can fit. And while doing that, we also try to analyze the impact of the technology that we are developing and AI more in general on the human work, meaning that doing the same job with an intelligent assistant does not exactly mean doing the same job. So it's something different. So we are trying to explore also this part. To do that, we have gathered a total of 15 partners from 10 different countries, and basically we are 3 different communities together. We have the human factors community represented by us, but also we have in the project Barry Kirwan from Eurocontrol, human factors expert from ENAC, and other human factors expert. We have the end user community. For instance, you can see here Skyway, Thales, Embraer, London Luton Airport, and our technological community. We have 3 technological providers that are coming from other domains, so are not from the aviation domain, and they are trying to, let's say, bring best practice from other industries in our project. And these partners are Sweet5 from Cyprus, Engineering from Italy, and DFKI from Germany. So this is the consortium. We have one external partner, which is one external end user, which is London Luton Airport, and EASA is one of our advisors, meaning that we keep them updated on the project. We ask them for feedback. For instance, at the moment, we are trying to apply their guidance to our use cases, and then we will provide them with a feedback, and we'll ask them for a feedback, trying to keep this loop of feedback between us. So our 6 use cases. We work on 6 use cases. Each use case aims to deliver one intelligent assistant prototype, AI-based. The first use case is for pilots and aims to deliver an intelligent assistant for pilots to support them in managing startle effect. And this is a use case led by our partner ENAC. The second use case is also for pilots. It is led by Thales together with Embraer, and it aims to develop an intelligent assistant to assist pilots in route planning and replanning. The third use case we are working on is the more futuristic one, let's say. It aims to develop an intelligent assistant to support the management of urban air mobility traffic, and this is led by Linköping University and LFV. Fourth use case is for tower controllers and aims to support controllers in decision making related to the sequence of inbound and outbound aircraft while optimizing runway utilization. And this is led by Skyway. The last use cases are for airports. Use case 5 focuses on safety data, basically. And it has, let's say, this ambitious goal to try to enable the shift towards predictive safety intelligence. And this is led by Eurocontrol with the support of engineering and London Luton Airport. Last but not least, we have our use case number 6 is for airport, but actually is for passengers at the airport, trying to support them in finding the best way in the airport and try to reduce the risk of spreading virus inside crowded areas such as airports. So this is the overview on our 6 use cases. Here you have at the bottom the QR code in case you want to know more about use cases and the project in general. And I leave the floor to Simone that will give more information about one of our use cases for time sake, which is use case number 1.
So we selected this one for this presentation, and it's about how can artificial intelligence support pilots during startling and surprising events, so startle effect. The name of the intelligent assistant is Focus, so we created this one with the colleagues from MENAC. Let's go through to a story. So we have a flight landing, there is a lightning strike, the pilot is startled, you can scan the QR code, you will see the actual video, and then we have the support kicking in. And the support takes three different functionalities. The first one is the detection of startle and surprise, and we want to differentiate the two. If you are surprised, you can still perform. If you are startled, you may freeze. So we want the assistant to be able, based on physiological parameters, to differentiate where we are. In case the pilot is startled, then we have the second functionality, that is the support to pilots to manage emotions and stress. This is based on biofeedback. It is exploratory. We are trying to see if by calming the body before calming the mind, it is an effective approach or not, given that we have maybe enough time, maybe not. The third functionality is once the system detects that the pilot now can perform, there is guidance to regain situational awareness and to get out of the problematic situation for pilots. So you see that even in one concept, we have three different functionalities. AI plays a different role in all of these. For the moment, we are developing the AI part for the first functionality, the detection of startle against surprise. For the others, we have mock-ups for the moment. We are trying it out in real-time simulations, and then we'll see whether we will manage to develop the AI support also for those ones. This is about the first strand of work in ICO, which is our use cases. But ICO, like Vanessa said, is human-centered, human-centric project. So we wanted to explore other two strands. So the second strand is to test the current methods and techniques that we currently use for human factors, human performance, and see if they're still applicable to AI systems. In particular, we are, of course, trying to understand what is explainability from the end user point of view, from the pilots and controllers perspective. And then we have the societal aspect that was mentioned a couple of times during this morning. So we want to see whether the introduction of digital assistants may impact the safety culture of aviation. We have a very good safety culture in aviation. We're proud of that. Does it change if I am all of a sudden interacting with a digital assistant? Maybe for better, maybe for worse, but this is something a question we are asking ourselves, and we want to put in place safeguards against that. And then, like Vanessa anticipated, I will spend a couple of words. We want to assess the impact on the human role and try and anticipate how the human roles are going to change. So a couple of words on these two strands. We are looking for each of the use cases. We are analyzing the use cases from the human factors perspective, security, safety, liability, shifts of responsibility and liability, and also compliance with regulation and also with ethics, for instance. The key point there is to test all of the golden standards and see if they still work or if we have problems, and to see how all of these things may interact together to give good feedback to the use cases. So, for instance, we start from one critical event. In the use case you have just seen, the assistant may trigger the startle effect support, but it's not necessary. And we are asking ourselves, okay, what is the impact on safety? Overload. What is the impact on the human aspect? Trust. The pilots are going to lose trust because they have too many cry wolf alarms. What is the impact on liability? There is an increased liability for AI providers because the system is not perfect. It will never be perfect, and that we know. But there is also an increased liability for the end users because we need to train the pilots for that. So we're trying to see whether there are common cases that have an impact on all the different key performance areas, sending feedback to the use case developers so that they can tackle those issues at this stage. Here it's worthwhile mentioning that especially our colleague Barry Kirwan for Eurocontrol is developing is tackling the human factors aspect and trying to integrate the EASA guidelines, the objectives for human factors, with the CESAR, human performance assessment process, in the form of an app where basically you go through different questions and it gives you the requirements that you need to address as part of your development. It can be fairly open-ended. If you still have a few ideas, where are your critical areas, you can select the areas, the ones that you see there on the right, and just go through the list of questions to see if you need additional requirements to comply with in your ConOps to include in your design and development. This one is being done as we speak. So it's still, we have the concept, we have the contents, we are developing the app. We will be developing the app in the first couple of months, in the next couple of months. Then finishing on this one, the impact on the human role. Most of the project is technology driven. We have technological opportunities, but we don't want to catch up on the human aspect. We want to be able to design the human role while we design the technology. So for instance, we analyze for pilots how the future interactions with our digital assistants are going to be. And we want to see if pilots need different skill sets to interact with the digital assistants. And the answer is, of course, yes. It's not the same job. It's a different job because now you have a digital companion. So what we want to get out of this part of our work is a new set of training requirements for pilots. For instance, for CRM, we want to see whether that digital assistant is going to impact, where the digital assistant is going to impact on the current requirements for CRM training, and to see if and how we need to modify the current requirements. It is exploratory work. We are trying to project ourselves into the future, lots of uncertainties, but we thought it was good to try and not just assess the impact after the technology is there, but to try and design the human side of the job while we design the technology. So that's the spirit of this activity. So, thank you.
Thank you very much to Deep Blue. And we continue now with the next presentation, which is delivered by Emmanuel Levitt from CAE. Emmanuel is the Vice President of Product Management. He started his career in aerospace over 20 years ago at Dassault, moved through Bombardier, and then arrived at CAE. In more recent years, he expanded his experience also at Amazon. And Emmanuel, the floor is yours.
Thank you. Thank you, everyone. Thank you for giving me the opportunity to brief today. And thank you for the two presentations just before me. It's introducing exactly what I'm going to talk about. So CAE, for those who doesn't know CAE, we build simulator and we train pilots. We train about 140,000 pilots every year on commercial aviation, business aviation, and military. So today I'm going to focus on one use case where we're leveraging AI to improve training and also ultimately safety. So a simulator session, there's three people: the co-pilot, the pilot, and the instructor on the back. So we have a system, a product called CAE Rise Training Ecosystem. That system has been in place for about 10 years, where we're collecting data with the consent of the pilot and co-pilot to aggregate that data to telemetry, all the parameters that the aircraft are generating, the external parameter. As you can imagine in a simulator, we can control every outside parameter as well, being weather, being the temperature, the traffic, and also any kind of malfunction to simulate emergency or abnormal procedure. What we've been doing with CAE Rise is also assessing how the pilot behave with the co-pilot in terms of communication and screening pattern. So we went one step further, having some biometry instrumented into the simulator. It's been mentioned this morning a few times, there is no AI, no automation if there is not a big data lake. It's been 10 years that we're collecting data across the planet, across the different aircraft type that you can see on the top of the slide. We probably have a simulator for every aircraft flying today. And we have about 2,000 customers that sign on to that system. Will it be airlines directly, some business operator aircraft, and some military customer as well, where we provide training. So you're going to tell me, okay, it's nice, you have data. What do you do with it? Before diving into what we're doing with it, we're focusing mostly in the simulator session, according to EASA and FAA, in 3 main phases of flight. The most dangerous one, the takeoff, the approach, and the landing. And all combination of malfunction, external effect that can impact the safety of the flight. So the instructor is there to assess how the crew performing into those sessions. So after 10 years of data gathering, as you can imagine, we have a lot of data. The first thing first, we have some algorithm that automatically detect when a crew performing a procedure. Like if they perform a takeoff, the system gonna recognize that it's takeoff, then gonna collect the proper parameters to be assessed later on. So we conduct those maneuvers every day, every hour, every minute on different aircraft type, and we're clocking data into the data lake, which is a cloud computing somewhere on the planet. The next step in the middle is when the magic happens. When we say, okay, now we have Boeing 737 or Airbus A320 rejected takeoff. We have 10,000 hours of recording. What do we do with that? Is where we start doing some data clustering to understand what are the population in regions or even sometimes airlines. We can't go at the pilot level to understand, is pilot performing well a rejected takeoff? And what you can see, so it's a very small graph, some pilots, the blue dot and the yellow dot, we see that some pilots perform a rejected takeoff while they pass V1 by many knots, increasing the risk of safety for a flight, and reversely. So what we do as a training provider, then we unpack those outliers to understand what happened and to try to provide some remedial training, 1, 2, also some closed loop training. What we see in the middle is not just the simulator data. We operate on behalf of airlines. We operate on behalf of government for training. We also operate on behalf of business aviation partners, where some of the top 3, top 4, top 5 risks in flight, we see them in the simulator. Because pilot, as often I say, flight as they train, sometimes train as they flight. So a way to remedial flight operation risk through that methodology is to improve the training and reassess every month to see, okay, do my pilot perform well now in rejected takeoff? Do I still see pilot rejecting V1 plus 10? Or do I see my pilot that should not have rejected at that time and reject for the wrong reason? The last element is so we're doing many analyses. One of them is comparing to the prescription of the aircraft manufacturer. Go back to the rejected takeoff because it's the easiest one to talk about. So we compare within 3 seconds, as an example, the pilot must retract the throttle. Within 3.5 seconds, the pilot must brake. I let you imagine, if you have an instructor on the back, the simulator is on motion, but it's vibrating, the instructor on the back cannot assess if the pilot is pushing the brake at the right timing. So to give feedback as well for a crew, it's critical to have that access of the data and provide recommendation. You did X because of Y. Let's work on Y to improve the occurrence of X. The next 2 slides is gonna perfectly dovetail what you just briefed. It's about biometry. So that's, I often call that data. It's hard data, mathematical data, aerodynamic data, avionic data, environmental data. But as we know, pilot and co-pilot are human, are still human, and will be still human. The interaction, the communication, where they're looking at is very important. That's why we have done an experiment, with Singapore Airlines, where we put 300 pilots on 150 session on the 777, where we were asking the crew to perform a landing with a loss of an engine at different altitude, different speed, to assess, 1, how do they behave together? How do they communicate together when the actual co-pilot detects the engine loss? 2, the pilot in those phases of flight must look PFD, outside PFD, primary flight display, and outside all the time. Does he do really that? Again, it's impossible for an instructor sitting on the back to see where the pilot, the co-pilot are looking. The other element also that we assessed in that one was, is the pilot and co-pilot do the right visual check? As you know, there is procedure where they you need to do ABC, then check. Is really doing the check at that time in an emergency situation. The next slide will be an actual video of what happened in the simulator. So you're gonna see on the top, a bit slow, on the top left, PF stands for pilot flying. On the right side, that's a pilot monitoring. The two screens on the bottom, it's a primary flight display. So we're in approach, 800 meters above ground, and the navigation display. And you see the yellow dot on the two top screen. The size of the dot means how long a pilot or the co-pilot are looking in that area. And you're gonna see throughout that emergency procedure, the crew doesn't know when, it doesn't know actually if an engine is gonna fail. And it obviously doesn't know when and what will happen in that situation. And you're gonna see the screening pattern of the pilot and also look at the screening pattern of the pilot monitoring on the right side. Oh, we have no sound. No.
No, it should be working. Let me see.
Okay, got it. Yeah.
I'm not getting FD guidance. FD off.
Sorry for that. It's going to work.
Cancel the caution. Caution. Cancel. Recycle my FD, please. Firefighter, helico. Roger. I'm not getting FD guidance. FD off. Wind from the right, huh? 500. Check, check. Sure, continue. Check. 50, 40, 30, 20, 10. Speed brakes up.
So what you see here, it's a landing without an engine. We went one step further, and unfortunately, I didn't have enough time. We work with university in North America to assess the cognitive workload through the gaze tracking and also through the galvanic skin detector. Because we've seen, and many reports show it, and specifically in military pilot, higher the cognitive overload is, lower the brain is reacting with a much slower speed, and specifically in those critical situations. So it's a simulator, but that can happen in real life. And the goal of the simulator is to train pilots of the unlikely event of an emergency situation. Thank you very much. Merci beaucoup. Merci.
Thank you very much, Emmanuel. And now, last but not least, we have Boeing presenting. We have Matjan and Dragos Mongiteanu. Matt is the Autonomous System Certification Subject Matter Expert at Boeing, and he focuses on certification strategy and developing certification techniques and processes for novel technologies and new concept operations, such as AI, machine learning, and technology encompassing advanced air mobility. And Dragos is the Boeing Senior Technical Fellow and Actual Engineer, Chief Technologist at Boeing. He is the technical lead of AI research and engineering at Boeing, and he was one of the pioneers of AI at Boeing and in aviation in general. So
The floor is yours. Thank you. So, good afternoon. Talk about today, we're calling the Beacon Project. This is our IPC between Boeing and EASA. Start by a few acknowledgements, and then we'll talk about the IPC and what we're doing, and then I'll hand it off to Dragos, who's the AI Chief Technologist, to talk more about the system itself that we're exploring. So, acknowledgements-wise, first and foremost, I'd like to thank the Boeing and EASA team that have been working on this. It's a long list of names, too long to try to name everybody off, but everybody who's been working on it knows what they are. Just like to stop and thank them for their contributions on this. I'd also like to talk a little bit about what Boeing's doing as we're trying to engage with global regulators, exploring innovative and emerging technologies. We're looking for, this is one of a host of projects that we're doing, looking to, as you can see here, kind of our strategic objective, strengthen regulatory relationships and where we can help foster global regulatory alignment between the regulators. And to do that, as I mentioned, this is just one of a series of projects we're working on. We have another IPC with EASA looking at the AAM ConOps for our partners at WISC and a few other operations. So just wanted to highlight those first before we get into the details of this particular project. So the IPC, what we're doing here is in collaboration with EASA, looking at the regulatory requirements, means of compliance, and V&V strategies for a machine learning-based system. We are using the concept paper issue 2 as the basis of the work that we're doing here. We're using our experimental automated taxi system, which I will talk more about here in a minute, as a surrogate for exploration in this. We are considering both a level 2A and a level 3A version of the system. We started with 2A, and we'll talk a little bit about the split there in a second. And we're hoping to wrap that up here in the next few months. We began this IPC back in June of 2023, and we're looking to finish up kind of early to mid next year. And we are expecting to publish a report at the end of it publicly that'll be out there for reference, similar to the other IPCs that other companies have done. So the IPC, a little more about that. Why did we propose this? We thought it would be a very interesting and helpful exercise for both us and EASA to explore these systems kind of off the critical path of certification. So we really had time to sit down and talk about the points of interest that we both had and that we wanted to explore. We also thought it would be a good opportunity to take the concept paper and apply it to a system and see what we learn and what EASA can learn from the concept, that application, and where there might be potential areas of refinement in the future in both sides. We also wanted to help lay the groundwork for future certified AI systems. And like I mentioned, some of the other IPCs, Formula and Codan and MLEAP and some of the other, that if we wanted to continue to add to that growing body of work that the rest of the industry has contributed to, we wanted to add our contributions to that as well. And like we also said, we want to help facilitate harmonization on this. And so we're, when the results are advanced enough that we can share what we've done with the FAA, we're planning on doing that as well. So we could help add to the continuing engagement between the two regulators. So areas of focus for our IPC. So the application of the objectives and the mocks from the concept paper, like I mentioned, take those, apply it to the system, and see what we learn about how the objectives work, how the mocks work, and what we would need to do with the system to satisfy those. Validation and verification approach. There's been a lot of discussion about the W-shaped model. And so what you can see here is the kind of our Boeing take on that and how it overlays with the traditional systems V and how they interact. And so that's one of the areas of exploration for us. And then, as it's been highlighted multiple times today, human factors is a big thing, obviously, especially for the level 2A system. And so we're focusing on that and the use of STPA, or system theoretic process analysis, as a way to explore the human factors issues, especially around the HMI. And you can see here on the bottom right-hand screen is the STPA control structure diagram that we've created for our system as part of this. And we'll go into that more in the report and what we've learned from that. So last slide for me, kind of our key takeaways so far. Again, I'd like to thank EASA. They've been an excellent partner in this IPC. We've had a lot of very good productive conversations both ways. And so we'd like to continue that, obviously. As we've worked on it, applying the concept paper to the system, we have identified, and I think EASA would agree, that there's some potential areas of refinement. Not to say, especially in light of the last bullet there, The concept paper does, in the approach to taking, definitely seems like a viable way to approach certification in these systems. And obviously, it's a concept paper. It's still working through, and that's where we're hoping to help add to the areas that can be refined as we move forward and as EASA moves forward. So upcoming schedule. So later this year, EASA and hopefully the FAA will both be visiting us at our test facility in Montana for a demonstration of the automated taxi system. At the same time, there'll also hopefully be our wrap-up for phase 1, which is exploring the level 2A version of the system. And then shortly thereafter, we'll do the kickoff for phase 2, which is the level 3A version of the system. We're looking to finish up phase 2 in the first half of next year, and then hopefully get the published report done and out by roughly mid-year next year. So with that, I will hand it off to Dragos, and he'll talk more about the system.
So this is an automated taxi system that runs. It's at a TRL level somewhere between 4 and 6. It runs on an experimental airplane, and I'm going to describe it in a few minutes. Please ask questions, and I'm happy to address them, and also in one-on-one discussions after that. So it runs on our experimental airplanes. You can see some videos that we have released on our experimental airplane on our LinkedIn site and on the Boeing LinkedIn site. So basically, the philosophy and the development of the system was to change as little as possible in the environmental operation. So we don't clean environments, we don't stop other vehicles from moving around. In fact, in some demonstrations, in places where we test, we had incursions, we had noise, we had different weather, and so on. So the system is able to receive a taxi clearance via radio, very much like a pilot. That's from ATC, human, to parse the clearance and to plan the taxi route and provides readbacks. If obviously the clearance is uncertain, so uncertainty is everywhere, and we try to handle it with utmost care and also to reason on it at every step. We provide feedback, we read back if, for example, the clearance doesn't contain all the taxiways. For example, a path would be Alpha Bravo Juliet, and Bravo is missing, we read back. It executes it, and it can execute it on all the airports on which we have maps, which is pretty much all the airports in the world. The important thing is the perception. So perception is used for obstacles, but also for localization, which we use on our own maps. Now, as it was mentioned, we're at level 2 here, 2A in particular, in which the flight crew monitors the automated taxi. It can disengage it. It's a route to override it. And in earlier demonstration, we had a ground station just for monitoring the safety. So that's for experimental reasons. So this is the flight crew oversight that we have right now. The crew is responsible for the activation of the system. It monitors the execution. We expose the execution in the planning and also in the perception as much as possible. If needing, we can override, for example, the destination and details like this in the plan. And it can obviously override if it's an abnormal operation. So for that, there's an interesting component because we humans always project what may happen, right? And we anticipate, and that's why we're scared if somebody does a special movement or so. We try to do that and to provide some sort of input like that to the pilot so that they are able to override. We have our experimental displays. Again, this is experimental. This is not certified. It's a mid-level TRL. This is a high-level architecture, and it probably matches a lot of what you've seen earlier. We have a planning and decision-making backbone, which is symbolic, but it handles uncertainty. It's connected to our two big learning-based components. One is the perception, the other one is the dialogue management. We have the dialogue management, and I talked to some of you during the break. We haven't exposed that in detail in our IPC here, and it's obviously work in progress. Obviously, I mentioned we use maps, and we have what we call our navigation database, which we patented. Basically, that's a representation, a symbolic representation of the airports for the planners to run on them. The planning and decision-making backbone symbolic, but it's important, state action-based. And again, it handles uncertainty, and it handles the uncertainty of the input. It also plans and expands the plan as it's executed. So it's basically a state-of-the-art, modern, hierarchical planning component. Again, the focus in our IPC is on the two major classes of risks coming from perception. One is on the object detection. And again, probably all of you who have implemented object detectors on any robot, you know that it's not only a detector. Typically, we converge to some sort of a pipeline where we do some scene process, pre-processing, then there is the detection, then there is a reasoning component, which has at least tracking or something else, and the decision-making. It's important here, and we discussed this both with the EASA and the FAA, the goals. So the decision-making is tied to some goals, and there is also the risk. So it's very hard to talk about AI, quote unquote, in the absence of goals or in the absence of an objective. We do optimization here, and that's the goal here. Localization, obviously. So one example is that currently maps are not certified because they are handled by the human pilots. And we use those maps. Those are the Jeppesen maps. It's interesting because we believe that if there will be automation for localization, there will be a risk analysis, and we run that risk analysis as part of the IPC. All the measurements are fused in the evidence grid, and we run standard localization. Given that we have the maps, we don't need to do SLAM. So that ends my presentation. Happy to address questions and answer.
So thank you to Boeing, and thank you again to all the presenters for their use cases that we have seen today. I would like now to have a short discussion with the panelists and have a round of opinion around a couple of points we have put together. The first question I would like to ask to all of you is, based on the actual content of the concept paper, edition 2, and based on your experience so far with your use cases, and probably with others that you have done before, what do you consider to be the most challenging points of the anticipated AI trustworthiness framework? I mean, what can be anticipated today by EASA? Maybe we just follow the order.
Okay. I think that for the deployment of AI, as I illustrated on the conflict detection and resolution, we could envisage to have to deploy this kind of system in a first step in a shadow mode with a human in the loop. Also to make the operator more confident on the module, and also to use it on not operationally in a first phase, but as in a shadow mode, and then also use the feedback of the operator. For example, for the conflict detection and resolution, we could have also a clearance by the operator and it could improve the performances of the conflict detection and resolution by reinforcement learning. So try to define different steps where in the first step, the operator is in the loop, but in shadow mode, and improve the system. We collect his feedback to improve the system. And in the second step, the operator will control the system. But for the time being, we are addressing mainly advisory system like conflict detection and resolution, and also arrival manager, which are it is up to the controller to make the final decision.
One of the biggest challenges we're facing is with level of security. For commercial airline, it's about making sure data is anonymized, so we can't trace back the pilot or the co-pilot. That's one thing. On military, when you deal with military asset and cross-domain security with different clearances, where you could eventually, if someone would look at the data, reverse some doctrine, military doctrine. That's one of the biggest challenges we're facing, and specifically with cloud computing. So the solution I talk about is designed to run on cloud, whoever the provider. However, we see in military that it's not always possible to have a security cloud specifically outside the US. So we have also a solution leveraging edge computing to try to circumvent those risks and those limitations that we can see mostly for military customers. So security and classified data would be the biggest challenge.
Thank you.
For our project, we have multiple challenges depending on the component. I would mention probably specifically two of them. So when we are detecting the pilot incapacitation, so this is a machine learning component. So here the main challenge is the data representativeness. So how to make sure that we have trained the system of the sufficient and diverse set of the samples so that we can detect it correctly. And for the teaming component, it's probably design a system that we keep pilot in the loop. So make sure that the pilot is aware about the automation and automation is aware about what the pilot is doing. So to keep these two actors in harmony.
For us, it's really something related to the way we design the project. We have 6 different use cases, and we are trying to harmonize the approach among 6 different projects, really. And so the guidance material, for instance, is great because it gives us a common language, but it is still a struggle because we have different levels of maturity, different ways of interacting with the AI system. Sometimes it's a dialogue, sometimes it's just giving input and receiving an output, so it's not really a dialogue. So we have different teaming concepts behind that. So to us, the biggest challenge is trying to keep it under the same umbrella, having the same harmonized approach, even though we have 6 different use cases in covering different aviation domains.
And for us, I don't think this would be a surprise given the amount of coverage it gets in the concept paper, but around the HMI, providing the flight crew with the correct information they need in order to monitor the system and intervene if they need to. Giving them what information, what they need, when they need it in order to make a decision when they need to do something. It's not that much different than today. There's automation, and there's been a lot of HF discussion over the last few years. And so learning what we need to do differently, if anything, around AI and making sure the flight crew gets the right information.
Technically on the system, I think we have 3 major issues. First of all, on perception, the community learned about perception a lot just in the last 10 years. And we realized how much it is about reasoning and handling that uncertainty. So that's one huge thing. Then there is, let's not forget that these systems run in real time on some sort of an airplane where you always will be limited on power and computational capacity, no matter what, and that has to be addressed continuously even as we advance with technology. And then I think one thing that we should all acknowledge is that if we go with the more we go with end-to-end learning, the more we fall into fallacies. Why? These are high-risk systems for which high risk, those rare data points, we will never have enough data. So a challenge will be not so much on having the data, but inferring the knowledge so that you have knowledge inferred based on data, and then you have knowledge coming from physical rules and so on. So that's what we try to do in that, in that navigation database, for example. And that's a challenge in general. So for the high risk systems, we will never have enough data, and we'll have to cover it otherwise. And then comes the reasoning in it.
Thank you very much to you all. I think we can switch now to the questions from the floor, and we will go on Slido for that. Okay, so I read the questions in the order they appear. So we have a first one. Currently, several methods exist to classify performance, such as pilot performance. Can an AI tool be used to complement that, or is it unacceptable under the AI Act?
We can ask the panelists.
So
I think it was raised on Frederick, that is a question.
Yes, if probably this was raised on Thales' presentation. I don't know if you want to react on that.
I have not addressed pilot performance, so it's not my rated tool.
Yeah, I can maybe give it a try. So today, instructor, depending on where they are, which jurisdiction, assess pilot performance. The scale 1 to 100%, 1 to 5, etc. The product I showed you, CRISE, is a complement to provide also a grading to the actual performance of the pilot, where the instructor has a right and can overwrite the system, that give him some information, like I described earlier, the rejected takeoff. It's impossible for an instructor to see if the pilot has pressed the brake within 3 seconds. So the system is an assistant, is an aid to the instructor evaluation system.
Thank you. Somebody else who wants to react?
Yeah, on pilot performance, yes. On the same one. I think here we have two questions. The second one is whether this is acceptable under the AI regulation, and it depends what you use the assessment for. I mean, if you're talking about monitoring people and workplace, no. If it is for training purposes, that's what we currently do. The first part of the question is, can we do it? It is an open research question today. I mean, it's not like a magic box, you put everything in and you get the answer. We are, I think they are doing the same. We are correlating with other metrics, other indicators that we currently use, normal standard practice. And we see whether the AI analysis can add anything to it. A problem is the scarcity of data. So for instance, you had quite a lot of data, so maybe you also can complement on that one. The problem that, for instance, we have in ICU is the scarcity of data. So the recordings we did, we don't have enough data to answer to that question, to be honest.
Yeah, perhaps I would add maybe a complement of information. Would AI be the proper mechanism to assess CBTA, competency-based training? I think that's one vein that needs to be explored, and we are exploring, our industry is exploring that, because it's one thing to know how to fly, it's one thing to have the right competencies to operate a flight from E to B. And I think that what we just talked about and what you just mentioned can be a leverage with the proper regulation around.
Thank you. So we have another question. Yes. So let's go for the next one, which is about the HaiQ use case number 1. If accepted by pilots to be monitored with biodata on how they perform. Maybe because it's acceptable rather than accepted. I don't read it. Yeah.
Yes.
Yeah.
For us, we monitor physiological data, not performance data, to detect if there is a startle or surprise effect. We spoke with different pilots. We didn't mark any issue on it, especially when you talk about startle effect. Especially when you speak with pilots who experience startle effect, actually they tend to like the idea to have this kind of support, as when it happens, it's not a nice experience. So we didn't mark any acceptance issue related to this use case and this aspect.
Thank you. So the next question is for, was just overtaken by another. So the next question is for Honeywell. The pilot state and task load monitor is not social scoring, unacceptable risk according to AI Act.
Yeah, that's a similar response as HaiQ. So we are not monitoring a performance data. It's a physiological data, and it has nothing to do with the social scoring. So we are really measuring the human physiological data and the markers that can lead to drowsiness, sleep, etc. So with this information, we are explaining to pilot that this is just another safety net, even for them to be aware that their vigilance is degrading and the system can react on that. So it's not on how they perform or how they score, but it's about really safety.
Okay, thank you. Then we have a question for Boeing. What will be the difference between the level 2A and 3A application? The automatic taxing seems already mostly level 3A, safeguarding by human.
Yeah, so like I mentioned, we're going to be rolling into level 3 later this year. So I'm sure this will be refined a little bit as we have our discussions with EASA. However, our going in preliminary discussions have been around the level 2A version of the system as if we would put this system in a traditional 2-person flight deck today. So you have one flight crew monitoring one system on one aircraft. Like I said, our preliminary discussions with the EASA is if we had that system installed in a remotely piloted or remotely supervised aircraft that had a remote supervisor that was overseeing multiple aircraft at the same time, that's what we were talking about. It would be a level 3A system due to the reduced amount of oversight that the human supervisor could provide to any one system at any one time.
Yeah, in general, this is a challenging technical discussion, and happy to have it during coffee or tonight during a soccer game. Simply because if you in doing it practically, and I know there were declaration, there were official declaration of, Boeing, Airbus, authorities, and so on. There is a state. We have in machines, we have the concept of state and actions. And here we talk about the state of machine, state of the environment, and the environment is whatever is in the environment plus those humans. You have to monitor that. Now, once you monitor that, you can claim to be somewhere in 3 and so on. You have to monitor it and to act, yes, safely and so on. So we had discussions. This borderline will be blurry once all of us will work on actual systems, because just simple advisory systems, not state-based, will not live long. So state and action are central to, call them whatever you want, automated, intelligent, AI, IA, whatever. But it's central. It's central. And that's why probably Guillaume cares about reinforcement learning and planning. It doesn't matter how you do it. you'll have a plan, and that plan has to monitor everything, no matter what, 2A, 2B. I think it's going to be a question of robustness at some point.
Yes, Dragos, just to jump on this, this is one of the discussions we exactly have now. We focus on the 2A example for now, so we didn't really engage in that. But we see really this reasoning element as a key element, and we need to see what is around of it. So it's kind of it's a system of systems, in fact. It's a separate piece of the system, and that's something we need to investigate, theorize, and see how good it feels with different use cases. Maybe to create a bit of interaction and not letting you fall asleep on this side of the room, because we have a lot on the Slido, and each time we reply a question, there is another one coming. So just to see if there are some questions from the floor, I can pass at the back if necessary, but you have also mics on the tables. I don't know if someone wants to jump in before we continue with the Slido. No, you're okay. Anytime, raise the hand. We take questions from the floor as well, and we want interaction also on site. Thank you. So let's go.
Okay. Then we continue with the Slido. So the next question we have, it was said that AI is not permitted to be used for scoring people. However, data is used to score pilots in FOQA without AI. Is there a difference? So it was, anyone who wants to start on this?
I think so. From tying back to the previous question, it's about the state and the uncertainty. It's not. I mean, it's got to be a very thin line there, right? Because we all know it's illegal to score. However, you are allowed to monitor the uncertainty of action, and we should be allowed to monitor, for example, if the belief state of the pilot is uncertain, and I think that's the goal. So it's basically from a systems perspective, it's all about understanding where the environment is, and the pilots and the humans are part of that environment, and what their belief state is. And then the system should be able to take the optimal actions. It's about optimal actions and optimization. It's not about scoring.
Thank you. So the next one is a question for Thales. How do you keep the pilots in the loop when increasing level of automation during higher workload periods?
Okay, so first I will change the word pilot by controller, because I have presented only air traffic control use cases. As explained, to be very concrete, for instance, with conflict detection and resolution, the CDR will be an advisor, so it will propose some solution to the controller. And the idea is that the controller will have the proposal by the classical algorithm and the proposal by the AI-based algorithm. And so it could make its own appreciation of the solution proposed by a classical approach or AI-based approach, and select the best one based on his consideration. So we don't know that it will increase the workload of the controller. It will propose different alternatives, and he has a higher degree of freedom to select the best one according to this understanding of the context and the situation. And then by this way, we will increase confidence of the controller with the tool. If we take the analogy, if you use a Google Map on your car at the beginning, you are not so confident that the time of arrival of Google Map is correct. And when you have used 10 times and you have a good estimation of your time of arrival with Google Map, you are confident in the tool, and you use it. So is to how it's more to increase the confidence of the controller. And obviously, we take into account, try to avoid to increase the workload of the controller, but it's necessary to put the controller in the loop to increase its confidence.
Thank you. So next question is
Giovanni, sorry, can I also reply to this one, to the one about how you keep the controller pilot?
Yes.
To me, I mean, again, from a human factors perspective, you need to reply to two different questions. One is like design with the uppercase D. So it's the concept on human AI interaction partnership that you want to have in your system. It can be a dialogue. It can be reactive system that only reacts to users' input. It can be proactive. So it alerts you when there is something that you need to pay attention to. But this is the concept of human AI interaction that you want to put in place. Then there is the lower case D design, and that's about the user interface. So it's about what Matthew was talking before. So what do you put on the interface at that moment in that specific situation? And it's a matter of the explainability levels. It's a matter of that specific context, that's the specific situation. And the two are linked. So it's always a dialogue between those two levels. So what you have in mind as the metaphor, analogy for the human AI interaction and the way you implement that. But it's a constant back and forth between those two levels. If you just get one of the two, then you lose the big picture. Or if you just get the high level, then you don't have the solution to the detailed design of the interface.
Thank you, Simone. So the next question, none of the use cases elaborated on the fear of systems safety risk effect, such as a minor from a false positive or major false negative. Why? Does anyone want to?
To the contrary, I mean, we had very limited time, but basically all the risks that we mentioned, for example, for the perception are evaluated clearly. Obviously, on the detection, it's about false negatives and so on. But for example, for localization, it's about continuous risk and it's about basically the uncertainty. So the risk is the probability times the loss, right? And all the risk analysis is that's central to our work, and I guess pretty much of everybody's work. So,
yeah. Thank you, Dragos. Anyone else want to react on this, or shall we go to the next, which is for Thales? Using open source like TensorFlow, where is the liability?
So the TensorFlow is just a tool, so we could use other kind of same tools for developing a neural network. What is important is to validate and to qualify the result on the neural network itself. So TensorFlow just like another tool to learn the neural network and to train the neural network. Sorry. So we have other tools in Thales that we use for developing this technology of neural network. But the challenge is more on the qualification, on the validation of the result, not the tool needed for the development.
Thank you. We have now a question for Honeywell. What is the limit between pilot monitoring and emotion reading? This was prohibited in the EASA AI Act.
So I assume that the limit was meant like a threshold or a division line. For the pilot monitoring, it's about the data that we have selected for training. So when we started building the classifiers, we did analysis. So for multiple sensors, you can have a camera-based sensors, you can have a variable-based sensors, you can have a chest sensors, some different kind of the radars, motion sensors, etc. And then you have a tremendous amount of the markers that can give you some kind of the value. So heart rate, eye movements, galvanic skin response, etc. And After this analysis and under consultations with the subject matter experts, meaning the medical doctors, we have down selecting the ones that are contributing to the classification of the states. So if we are to detect sleep, so we have a set of the markers that are contributing the most to the sleep detection. If we were to detect the emotions, we would select the different markers for that. So that's about the selection, and it's about also the challenge about the data representativeness. So we need to acquire sufficient amount of the markers and the data to be able to classify the requested state.
Thank you very much, Pavel. Yes?
Maybe just a comment on this question, because it has not been mentioned, but there is an exception in the UAI Act allowing emotion recognition specifically for safety and medical reasons. So it would be compatible, and I assume for many of these use cases, specifically in this domain.
Okay, thank you.
Probably just to complement on that, I think the point is exactly that, is to trace properly the way you select the criteria and the way you trace it to the prohibited or non-prohibited use cases. I think this is something we'll have to think about as well. Yeah, great, thank you.
Okay, we have now another question, which is rather general, and it's for all of you, if you want to react. Why do all use cases start with intelligence rather than virtual, or other term with assistant? AI is not intelligent, is it?
They don't. So we want our friend to pay attention. I don't think ours starts with intelligence, and we tried not to use the term. So in for FAA discussions, I think, they don't. And we don't claim intelligence. So do your cases start with intelligence?
Well, yes. There was a long discussion inside the ICU consortium. We started calling them digital assistant, and then we decided to move to intelligent assistant. That was because, first of all, the assistant are not all AI, but there are some parts that are AI, but others are technology. And the second is because when we design them, as we said, we start from user needs, human values. So we start to respond. We try to respond to real needs with our intelligent assistant, and so try to take out from technology the best we can do to make something intelligent that can really help our pilots, controllers while they are working. So this is why we call them intelligent assistants.
Thank you.
When we launched our product 10 years ago, the biggest pushback we got is from the instructor, not from the pilot. And we used virtual assistant, and people, instructor, which are pilots, quickly jump to, okay, they will replace me. And so, but if you read the presentation and if you have followed me, for sure there is automatic thing that can happen, and it's a complement today. That's why I purposely not use intelligent or virtual for that matter, because it's trigger emotion and bad perception.
Yeah, I can see you, but I hope you can hear me. Yes, I have a question about you were talking about before about, for instance, monitoring or performance monitoring of pilots and so on. And I would ask you if, because in the AI Act there is a specific list in Annex 3, in which there is also employees management. That list, as the purpose of the list is to protect against another kind of risk. It's not a safety risk, it's a risk to harm fundamental rights of citizens. So in this case, we have many examples like, for instance, having access to private services like financial services or public benefits and so forth. And one of these domains is listening these annexes in the management, employees management. So could it be followed under this list? And in this case, it has to be considered high risk because of the use of that, not because of the where is the, in which domain it falls and so on. Thank you.
I don't know if one of the panelists want to take it, but I would say in a global manner, Matteo, thinking about what we presented also this morning, this is precisely what we need to let's say characterize in the part AI. It's really where there are so many, let's say, cases where the use of it could make a difference. So the operational use is an important thing, and that's why we always start with the ConOps. The concept of operation is our starting point. With that, or having said that, that's something we didn't mention this morning. It brings us also a bit higher up than the system itself. To be clear, when we say ConOps, we are at the product or even, let's say, interaction with a human, but also product level, which is on purpose because we have to take this big picture. And I would say part AI and ConOps are kind of the answer, the generic answer to what you're looking for, but precisely I would not answer because it's a use case basis, let's say, assessment, I would say. Thank you.
So, overall, I think we're only touching the surface. So when we talk to our pilots, and this touches also one of the leaders of Airbus mentioned this a few years ago, the pilots do so much more than flying an airplane. The pilots, before you start even taxiing, the pilots decide on unloading luggage, anxious passengers, personnel. We don't even talk about that now. So the way I see this automation, and I'd like as much as possible the community to embrace it. So far, we, Boeing, Airbus, all the makers of airplanes have optimized this interface between two intelligent humans and a lot of automation. And we have there two very interesting systems. The autopilot, which acts but is low dimensional and deterministic, and the FMS, which is actually high dimensional but doesn't act, it's advisory. We try now to move that boundary and we try to start making decisions which are not made by any of the systems. And that's what's painful. We try to call it AI, non-AI, whatever. We'll move and there will be humans involved. We'll call them whatever. We'll see where they will be in 10 years, in 20 years, and so on. But we're just moving that decision boundary here slowly. And I think that's what you thought. And, we'll see how we monitor these humans and, what the role is. But the goal will be to have something robust there where you have these automation and some human, and maybe the human is remote, whatever you will decide. And we look for the robustness of this team. I think we should embrace this vision. And this vision was always embraced by airplane makers. And we, from 50 years ago, we added automation. Now it's the big thing. We want to make decisions in a high dimensional space. And we have these pains. So I think if you disagree with this, I'm happy to have discussions.
Okay, thank you. We are approaching the end of the slot, so we take one last question and then we pass to the next agenda item. So the question would be, hybrid AI for contrails is surely not a safety function that benefits society. The need is fit for purpose. So would it need to pass the concept paper 02 scrutiny?
So about contrails topic, so the result of this AI will have an impact on altitude, no-fly altitude, and so it could compress the traffic at the other altitude and could increase the conflict. So the main impact, there is no direct safety impact, but due to the level of altitude that will be not authorized to limit the contrail generation, you will compress the traffic at lower altitude, and it could generate some safety issue. So we have to address the contrails topic in a global context, also impacting the control traffic control. So we have to develop tools to help the controller to manage the change of trajectory of the aircraft, and also for the pilot because it has to manage also this issue.
Thank you. And with this, we are at the end of this panel. It was a very interesting and rich discussion. I would like to thank you again, all the speakers, for having joined us today and presented their use cases. So please give us a minute to rearrange the table for the next agenda item, and then we start again.
Yes, and I will call Ines on the floor for the last presentation before our next coffee break. And we've put it on purpose before the coffee break to reinitiate thinking and start discussion, because the next slot is the panel of discussion on ethics. So it will be very interesting to have also interaction from the room, same processing with the Q&A session. So Ines, I would say let's let people take a seat, and then the floor is yours. Thank you.
The slide is just there, right?
It's there. It's here.
Just
here. Press there.
No,
it's okay.
Just here.
Press
That's it.
Yeah.
Okay. So are you ready? Yeah. Okay. So good afternoon, everybody. Again, I have this tough task to keep you a bit awake, hopefully. So, and take you with me on a flight of half an hour on a different topic, which is ethics for AI in aviation. Yeah. So, okay. So this little flight, so this little story will have several points. So I'm going to, tell you why did we start to looking into these topics, what was the approach that EASA took considering ethics, what was the starting point, what research did we do, why we put together a survey that I'm pretty sure that some of you filled in. Thank you for that already. How did we put this together? What was the results? And I think everybody's very curious about the results at this stage, and what are actually the next steps, right? So that's the thing. So why ethics? Because from the first moment that we were dealing with these topics, this really impacted on us, yeah? So it's not just about the part that is related to technical domains, yeah? It's much more than that, because this will have implications and impacts and consequences on the humans. So it was very important from the starting point for us to understand what is actually the perception of the humans that will actually interact with the AI-based systems, yes? So for this, we started to see, okay, is this ethical acceptable or not? Until when? In what conditions? So all of these doubts were really the starting point for these works. So this was basically the reason why. So, and how did we do this approach? Yeah? How did we tackle it? So for us at this moment, as you can see, so we don't evaluate ethics. We don't evaluate it having this idea of that, okay, an AI-based system, it's like a moral agent, okay? So we are not there, all right? So we are just understanding now at this moment, at this stage of the technology, that AI-based system serves us as a tool, okay? So as an artifact that will help us to perform and to perform better, okay? So that's a bit the approach. So there's no moral agent here. It's not that we have an AI-based system being an individual entity, okay? So yes, so for that, this is just the approach that we took to be clear for everybody. And what we did actually was trying to see, all right, so what is this ethics? How can we tackle this? How can we measure it? So for that, we based on key ethical concepts, of course, hooking these concepts with different guidelines. And for sure, you heard about it in the morning, a lot about the EU AI Act, right? So this is a big important guidance for us.
So what we did, we of course hooked ourselves on the European regulation. Of course, we took care to listen a bit to the people, because it's very important to see what is the opinion of the professionals that are dealing directly with these things. And of course, we hope to draft guidance to help you to do better, to be safe, and to not infringe any human rights. Of course, human rights, I just take a kind of a parenthesis here. It will be very important to see that we have nowadays a third generation of human rights. And this third generation has really directly to do with the technologies. Yeah, it has to do with data protection. It has to do with bioethics. It has to do with transparency. So all of this has to match together. All right, I'm not going to read the slides from A to Z because it's boring, but just I highlighted here some parts of some articles from the EU AI Act that are touching a bit these key ethical concepts that we put together and that served as a basis for our studies. Of course, the starting point was actually what? The Alt-I, right? So this is nothing new for you, of course. It's back to 2019 or something like this. We encountered this good basis in order to think about ethics applied to this new scene. So, of course, the Alt-I give us these 7 years. I'm not going to read everything here, but we have some new kind of an animal here. When you, for example, see this societal and environmental well-being or non-discrimination, diversity and fairness. So this, for the systems that we are dealing with, may be something new for us, yeah? But still it's important. And in fact, some important gears on the Alt-I mentioned. You know, the Alt-I has also a huge bunch of questions at the end, and the team did the exercise to go through all of the questions, because here the goal is not to invent regulation. We have a good sound regulation. We are proud of this. And we want, of course, to maintain it and to, of course, to check from where we can actually not reinventing the wheel, but take what we have in order to promote efficiency when dealing with ethics. So we took these questions and we tried to see on the regulation where this could be treated. Okay, for this question, we actually have this type of the regulation that replies to it. From this other question, we have also this regulation that can reply to it. So we were just trying to match a bit. Of course, at the end, we can say, oh, maybe for some questions, we don't have a regulation that really replies totally to it. So, and that's why you see on the lower part of the PowerPoint, these objectives in lila or so, this was the piece of the puzzle that we put on as new in order to consider some of the questions of the Alt-I that were not totally replied by the regulation. So that's why we created this, some new objectives. Of course, we didn't do this together. We did lots of exercises and a lot of research. And I want really to highlight the research part, because we are all on a learning process. And this is just the first part of it. We take baby steps, but sure, baby steps we want to do. So I want just to bring it here, a bit of the partnership that we put together with some important, beautiful people that I want to highlight here. And in particular, of course, you just have here the team leaders, but behind these faces are other members of the teams, and they're very keen to work with EASA. We are very motivated to work with them. This, of course, it will continue, and I thank very dearly, of course, the EASA Scientific Committee, DLR, of course, Lockie and Elsa team. I see some faces here already. Thank you for all of the work. It's a pleasure to work with you. Also, Lisbon University, in particular, Faculty of Psychology, Professor Maria José Chambel, a big thanks also to her. The Politecnico di Torino, and of course, internally, some collaboration with some project management, particular teams in our case, the team of human factors was especially, dear to us. So thank you, René, for that. Okay, so as I was saying before, we took note of all of this contextual and kind of a regulated frame. And considering the ethics, we took some key ethical concepts that was the basis for us. So not forgetting, of course, the Altai, we came up with this set of ethical concepts. So equal opportunities, non-discrimination and fairness, data protection, right to privacy, transparency, accountability, and labor protection and professional development. Okay, so what did we do with this? Because you can say, Inês, but how can we measure ethics then? You have beautiful ethical key concepts, but how can you do actually an evaluation? So we really wanted to see the opinion of the professionals. And of course, we didn't ask them, hey, what do you think about ethics in aviation? What is for you data protection in aviation? What are the ethical issues? Because this is all very subjective, right? So if I ask each of one of you, what is ethics for you? I will get as many replies as persons, right? So what we really designed some cases, practical situations applied to aviation, of course, where we could represent these key ethical concepts. So, and when you're asking, considering these situations that you're going to discover in a minute, we are asking the professionals to position themselves towards these particular situations in 3 variables. So we want to know if they are comfortable to liaise with an AI-based system, if they trust in it, and if they will accept to work with it. So basically, these were the 3 main questions that we sent to the professionals. The situations, so I bet that you're very curious about it. So the situations were created on a very descriptive narrative story. So like, imagine that you are in this situation, and then we describe the situation, and at the end we ask, how will you position yourself? Are you comfortable with it? Do you trust on it? Do you accept it? So you have here the first case, which is pilot's physiological data monitoring. Very interesting, because you heard 5 minutes ago 2 or 3 cases that were directly connected to this. And I have some news for you. But okay, we will get into this. So very interesting that everybody's more or less interested on the same type of cases, because it represents that are really the important ones. So second one, pilots supporting go-around situations. Third one, AI-based systems supporting maintenance. Fourth case, airport allocation of airlines to terminals. Fifth case, airline crew members attribution to flights. 6, speech recognition in voice communication. I heard already some cases related to it too. 7, the risk of de-skilling. 8, new competencies when teaming up with an AI-based system. And this 8th case had 2 parts. In fact, the last part, it has to do with accountability and responsibility. We touched a bit in the morning about this too. So we sent out a survey based on these 8 cases. Of course, we have qualitative and quantitative questions that we treated. And there were just 2 conditions to reply to this survey. First one being an aviation professional. Second one, connected somehow with an AI-based system. So interacting or being impacted by an AI-based system. So these were the conditions. And it was very interesting to receive 231 replies. When we just opened the questionnaire, like 2 or 3 weeks only. Yeah, it was available only for 2 or 3 weeks between like Christmas time and the new year of 2024, and which is a very peculiar timing, I know. But it was very interesting that we could receive 231 professionals saying, yeah, we have a say. We want to have sharing my opinion with EASA. And I also would like to say that, in fact, this was not just a survey, like click, 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 inbox, 10 minutes and it's done. It was a very important and extensive questionnaire. It was more a working session. So at least 1 hour it would take for one professional to go through the questionnaire. So I thank dearly all of the professionals that went through the questionnaire and took at least 1 hour of the time to have a say to the agency. Okay, let me see my time. Half of the time gone. When the things are interesting, they fly. Okay, so I just put together some results that I want to share with you. Of course, it's just little tables and boring tables, but I just want to highlight something. So for comfort, you just see there the 8 cases, right? And I want you just to look into the mean, just to highlight the fact that all of this was rated on a scale of 7 points. So we had a rating scale from 1 to 7. 1, it's almost nothing, and 7, it was the maximum point. So here in this case, it's 7, it's a maximum comfort. What we can see here is we are all in the middle of a path, right? So we are here on the 4, a tendency to be comfortable, but not, comfortable. Totally. One thing that I would like to highlight very quickly, it's the case 7. So the risk of de-skilling, it's actually the one that brings less comfort to the professionals. Very quickly also, trust, same exercise. Here also we encountered the same. So the people are not very, trustful in situations where they find out that there is a high risk for themselves to be de-skilled, to not cope anymore with this new job that somebody was talking about on the speech before. Also for acceptance, it reinforces a bit the same, okay? So on a very global and quick basis, if we say, okay, what is the generic results that you have? The focus will be on trust. So the people, the less results, it's really trusting the system. We will have to work a lot on trust, building up trust. Another thing that we asked the professionals were, hey, but what is the need for regulation? Do you think that this should be regulated? And clearly everybody, or almost everybody, said yes, should be regulated. And we asked also, do you think EASA could be the authority to do the oversight? Yes or no? What do you say? And at least 50% of the professionals said yes, EASA should have an important role here. But of course, if we are happy to see, well, there is a tendency for acceptance, a tendency for comfort, a tendency to trust. We are not yet there, but there is a tendency. We are of course curious about taking the acceptance. Actually, what is the rate of non-acceptance? So we are usually taking about more care about the people that are not keen to accept an AI-based system teaming up with themselves on a work environment. So yes, here you can see also through the cases on a very quick basis, the percentage of the people that were not accepting the cases. So for example, for the pilot physiological data monitoring, just to link to the cases that we were listening before, we have 35% of the professionals that tend to not accept this monitoring. All right. So this is for the colleagues that were speaking before. Just of course, it's a questionnaire. We are talking about 231 cases, replies, but we have 35% saying that they have a tendency to not accept the situations. All right. Anyway, what I want also to highlight is this risk of de-skilling. Again, almost 50% of the professionals will not accept teaming up with an AI that put at risk their skills. Yeah. Okay. So of course we asked also, and this very quickly, we asked the professionals, what would be actually the factors for you to change your opinion to acceptable? Or what other issues would you see here? So lots of contents we got. This is just an example. I just want to say to you that we got 2,326 contents. People really engaged in saying to us what ethical concerns do they have. So for example, I'm just going to read out the risk of de-skilling, case number 7. Somebody said, as an example, yeah, that it is really difficult to feel safe and capable of doing fluently a task that you don't regularly, that you don't do regularly. So if you're not doing it on a systematic basis, it's really difficult. So occasional training cannot replace at all a more regular practice, which I think should be required. So this really, yeah, it's just a statement, but it really shows that the risk of de-skilling is there and it's important to be considered. All right. Another thing that I wanted to share on a very quick basis, I'm trying to do this this quick run. It's as we are talking about de-skilling, what we connect immediately with de-skilling, it's skills, right? Competencies. So somebody said before that, well, my job will be a different job. It's not my job anymore. It's something that will be transformed, that will be totally disruptive. So I'm not doing anything that I'm going to do now. I'm going to have a completely different job. How can I behave? Am I prepared to do it? What new competencies shall I develop? So we asked this to the professionals. So we sent a list and we asked them to rate them from the most important to the less important. And of course, not surprisingly, we see here that general AI knowledge and data literacy and cognitive skills and IT competencies were the most important competencies that the people elected in order to be ready to team up with an AI-based system. Then we have communication skills, sensory competencies, the social skills, and the last was the physical skills. Well, it seems logic, yeah, but we don't know about the future. Is this really not interesting or not important? Physical skills? I don't know. Okay, so we just, we asked also, this is just a list that we asked the people to rate, but we opened the question and we said, hey, what other competencies do you see important that you have to develop? And then we came across with 25 new suggestions, yeah? And of course, the technical competencies are the most important for the professionals. It comes right on top. But then we see lots of new interesting competencies. For example, emotional intelligence, dealing with error, interacting with the machine, being resilient, keeping human autonomy, so solving problems, knowing about cybersecurity, and having ethical awareness. What is really interesting here, and I want to highlight to you, is that we have a considerable new competencies linked to this emotional intelligence part, namely the need for assertiveness, the need for emotion regulation, and here regulation has nothing to do with the legislation, right? Okay, so how to deal, for example, with boredom, because we feel that if we have a machine interacting with me, maybe the richness of my job will not be anymore like it was. So they expect to be bored. And how to gain trust in the system. So these were actually the new competencies that were highlighted. Okay, almost at the end, we asked also, what are the type of initiatives do you think that EASA should develop in terms of ethics in AI for aviation? And the people replied to me like saying, okay, of course, regulation and guidance materials should be there. Of course, it's our mandate, we recognize it, we are doing it already, but we have to continue to do it. Then ethical awareness by dynamic activities and written materials. So, and this is, I think, interacting immediately with the following topic, which is interacting with the stakeholders. So more systematically and more directly. Of course, this survey showed as being one of these initiatives, and we had some people saying, oh, so nice that EASA wants to have my opinion. It's really interesting, but we can do much more. At least the people say that we should do much more. Then promoting training and competency development, initiatives for sharing information and sharing knowledge. And of course, the other suggestion was linked to certification in order to have, of course, reliability and safety in terms of the certification process. Yeah. So almost at the end, you can ask me, Nesh, but who are these people? Right? So who are these 231 professionals? So a bit of a mirror of the aviation world, unfortunately for the ladies yet. So 80 men, 20 women. So basically 62% between 40 and 59 years old. What I want to say to you is that we have here really a set of mature professionals with more than 10 years of professional experience, saying that they have a good understanding of AI for aviation. They are within teams that know, at least at the medium level, what is this AI-based system about. They basically 80% of them work directly in technical aviation domains. 20% are from the NAAs, and more than 75% they work directly with AI-based systems. So just to close the profile of the people, they are also feeling quite happy with their work, motivated and satisfied with their work, which is good, right? Okay, so closing almost my presentation. What are the next steps? So what is actually going to happen in the future? So this was the first exercise, trying to listen to the people. So we try to listen to the professionals. But this year, we're going to launch a similar survey, not of 1 hour for sure, to the generic public, because we want to continue to listen to the people. So this will be one of the big milestones for this year. Considering the results that I was just sharing with you, so we expect to share the full report with all of the results at the end of August. So maybe you can just bring it to the beach sometime. Yeah, nice literature. So we expect to share at the end of the summer, August. And of course, we want to put effort also to continue doing workshops and to bring the professionals into EASA more closely and more directly. And basically, that's more or less that. I think it was quick, but I would just like to close my presentation thanking these two magical guys that I have here. So Guillaume and Axel. So this is actually the project management team of AI. Ethics for AI, ethics for AI. But of course, I would like, of course, to thank to all that collaborated with us and the future ones that will work and collaborate with us too. Thank you so much.
Okay, great. Thank you very much, Ines. You can contact Ines. You will have the contact of her on the slide whenever you see it again. Exactly. And with that, we move into the coffee break. You can still use Slido. We will have the panel discussion. We will organize the table for the next session. And at the end of it, we will have also a Q&A session before entering the conclusions, closing remarks from Alain Leroy, our chief engineer. So let's go finding the coffee. If it's in Boeing or here, I don't know. We will find out. Thank you. Jesper, I think we can start. So let me introduce our panel moderator, Jesper Rasmussen, our EASA Director for Flight Standards, and enjoy the panel discussion. Thank you.
Thank you very much, Guillaume, and welcome back. Hopefully a bit re-energized by the coffee. We still have one session to go, so I will do my best to make it lively together with the panel here. We have heard a lot since this morning about the EU AI Act, introducing also requirements of ethics. Now, I believe this is one of the hot potatoes in what we discuss in applying AI in aviation. And furthermore, you could also say for many engineers, this is not the usual ball game. Ethics is another thing. It's more fluffy. How to deal with this? Well, basically, that's what we're gonna have a conversation about. In EASA, we don't hide that we need your help. We need help from the survey, which Ines just presented. We need help from distinguished experts, from academia, from industry. So we, in the best way, possible way, can shape the framework that you can work under in the coming years. Let me shortly introduce the panel. I'll just do it very shortly. We have Peter Hecker from the Technical University of Braunschweig. We have Thomas Krüger from DLR, Rosemarie Redon from ANITI, a research center, Fateh Kakai from Thales, Sergei Bobrovsky from Airbus, and finally Ines Berlinga from EASA. We will play it this way, that we will start with academia and then go to industry viewpoints and finally EASA. I will be fair, but still a bit tough with the panel. We have agreed to use 7 minutes each, allowing time for Q&As afterwards, and that's very important. Without further ado, I will jump into it, and I think I will start with you, Peter. Please.
Okay, thank you very much. Yeah, great. So maybe you click one slide further, then we might have a few questions there, which will help me to fill my next 7 minutes. We are discussing ethics and AI, and there are several dimensions how ethics are affected. We've seen a wonderful presentation by Ines earlier today, where many things have been approached through the questionnaire, and so I think I would like to focus on data, because data are essential for implementing AI and in aviation. And as soon as you start discussing about data, you need to discuss data protection and data privacy. So overall, I would like to touch upon 3 things. One is data protection and privacy. So how will data be used today? How are they being used today? What will change, and how will they be used in the future? I would like to talk a little bit about change making, so allowing society to agree in that, what we are trying to do. And then I've hidden a kind of hobby horse here, which is data for use in science, open science. And this will become even more difficult in the age of artificial intelligence. So let's start with the first statement, which is about data, which data are being used today. So today we have a very well-defined situation. So we have data owners at the different stakeholders. It's airlines, it's airports, it's aircraft manufacturers, whatever we have. And they are owning data, and they are sharing data according to a very clear scheme. So which data are handed from the aircraft manufacturer to the operator at the end, which data are shared within the air traffic network. So this is very precisely defined, and nobody gets data who doesn't need to have them. And we all know how those data are being processed and where they are being processed, and we can be ensured that the data are very well protected. So this is a very well-defined state today, and it may change in the future, because in the future we will include data from other sources. Looking, for example, in the air traffic management domain, we are looking into data from social networks. We are trying to analyze messages floating around from airports, from other sources, to understand what is the traffic situation, what does it mean for an individual flight, what does it mean for the airline operating a certain flight. So the quality of data will change, and we will lose control regarding the data ownership, because on one hand, industry and all those who are developing AI-based systems will on one hand need data to produce the system, to train it initially, and then over lifetime, the system will make use of the data, further learn, train, and further, condensate and work on the data. So we are losing track and trace of the data. And this means that at the end, we have no control anymore. And this is a big challenge, and this may be a challenge to acceptability by the citizen. And this brings me to the second bullet point, change making. So how can we pave the way for traceable and responsible data usage? We have learned this morning and all the day that there's a very close regulatory framework. There's a legislation on that. And I'm convinced that this is setting a very good frame, but we need to ensure that this is really followed up. And we need to ensure that society is believing us, that we are adhering to the scheme and that we are implementing it and that they can trust us in the way how data are being used. And I think a very good step forward is the questionnaire which has been developed by EASA, especially Ines, has reached out to the professional stakeholders, and I believe it's absolutely important to reach out to the society, to all those who are traveling with aircraft within the air transport system, and to see what they think about data privacy, data protection, about AI in aviation, in order to understand their concerns and to develop measures to really build trust. And now coming to my last point, as data are a very important element in the aviation community, and they are not easily shared today. It's always for research a very difficult, and for academia a very big challenge to access data and do a kind of research which is really significant and will provide the results we are looking for. There's a very long history in approaches where we approach the stakeholders from Eurocontrol via aircraft manufacturers, via airports and navigation service providers to get a consistent set of data which we can use for research and at the end achieve comparable and relevant data. And this will be even a larger, bigger challenge when we are looking into artificial intelligence, where it's a lot about training data, a lot of relevant data for testing. And so I think it will be in the future a big challenge for academia and for the research community to manage data in order to develop things, concepts, ideas, to build knowledge, which will find its way into the innovation pipeline. So I'm not sure if that was 7 minutes, but let's
you have been very disciplined, Peter. I think you only spent 5. So
okay.
Allowing just a question here before we move on. Now you focus very much about this, the data issue. If we look at it from the ethical side, it seems to me that you put a lot of emphasis on how the public acceptance or the passenger acceptance is for use of data and hence also AI. That's how I hear you. Is that correct understood?
Yeah, that is one part of the medal. Of course, that is relevant, but the aviation professionals who are subject to data handling and management, of course, need to be recognized and respected. And in the breaks, we had several discussions with ECA. So for crews in the cockpit, how their data are being managed. If we look into pilot monitoring, pilot state monitoring, there are a lot of open questions, what to do with those data. It's a trade-off, right? Where are we increasing safety and where are we collecting data which could be potentially misused? So I think it's not only the passenger, it's also every aviation professional.
Thanks a lot. Very good points. Let's continue with our next panel member, Thomas from DLR. Thomas, over to you.
Yeah, thank you very much. And thank you for the opportunity to participate here in the panel. So I would like to start with a rather general statement. So ethical requirements are necessary for the acceptance of AI systems. So very general, to be honest, but I think looking a bit more into details and looking a bit more into the day and the things we already discussed, this is quite obvious. So with regard to what Ines showed us from the survey, there is from the aviation professionals really the demand that there need to be some questions answered with regard to ethical requirements. But also with regard to the EU AI Act, aviation applications are high-risk systems. So there is a hard requirement for answering some ethical questions. And also considering the panel we had on the use cases, we had quite some applications where we have the teaming between an AI system and the human operator, being an air traffic controller or being a pilot. And then looking into these applications, there are certainly some ethical questions. You already raised some with regard to the monitoring perspective. And I think there it starts. So is it ethical being monitored in the workplace? And there is some discussion on this. And I think this discussion is not finished. So from the perspective of the engineer, it is highly desirable to have this data in order to improve systems and potentially improve safety. From the perspective of a pilot, I think this monitoring is questionable. And looking a bit deeper into ethical topics here, I think monitoring the biometric data, the physiological data, there is quite some open space for the ethics assessment and, for example, for unfair bias. If you have a system which is monitoring the gaze or the eye movement of a pilot, then the eyes need to be tracked, and there are currently systems which are not doing this with the same amount of accuracy. So you have systems which are detecting green eyes in a higher accuracy than brown or blue eyes. And using this as an input for an AI assistant, you clearly have an open door for unfair bias in your system. So this is an example where it gets a little bit difficult, I would say. So what is an important aspect is to find the right balance between ethical requirements and the complexity of the AI functions. So what do I mean with this? We have seen that with the concept paper, we have the categories of level 1 to 3 subdivided in A to B. So we have some clear boundary conditions. And right now we see that, for example, with the Altai, we have a vehicle where we can address ethical questions. So one question would be, where do we find the balance between applying the full Altai question list to, for example, a level 1A system? And maybe we can see it if you could click one further. So here we have a bit of a high-level perspective. Right down below, we have the intertwined V model in gray and the W model in light blue. And the V model is what we are doing in aviation if we develop systems. And everyone who is working in industry or has been working in industry knows that this is the reason why we have safe aviation, but this is also the reason why development is rather expensive in comparison to other industries. Now AI adds another layer of complexity with the intertwinement of the W model, and the ethics-based topics add another layer of complexity. So we see here on the top left the Altai list, and there are some high-level requirements will be derived, and these high-level requirements in the end will break down on the W, and they will break down, for example, with regard to unfair bias within the training data to the left branch of the W, and will break down to requirements with regard to data management. And so depending on the complexity of the AI function, and maybe in the end also with the criticality of the AI function, we need to find a balance and need to make sure that we don't build up too many barriers to really develop and deploy these systems, but also don't make it too easy in a sense of negate ethical requirements which are clearly there. And so one question for the future, I think, would be, can we maybe derive some kind of subsets, for example, from the Altai list or other guidelines, which are then applicable for a level 1 system? And a larger subset is applicable for level 1 and level 2 and so forth. So to make it easier for the developer in the end to address the correct ethical requirements, where we, I think, most of the people here agree that there are some ethical requirements we need to fulfill. And so there is this balance to be found, I would say.
Thank you very much. Thank you very much. Also, you were well within the 7 minutes. Thank you very much for this. As far as I understand you, you are advocating a kind of segmentation of the AI application system in terms of safety criticality, as I get it, all from non-critical. I mean, from cabin entertainment systems, which is non-critical, surely until clearly top critical systems, where we can apply different barriers. That's how I understand you're balancing. So if we have a scale from everything is forbidden to everything is allowed, we should set the boundary according to the criticality level. Is that correctly understood?
Yeah. So I think with a perspective of a systems engineer on the complex task of designing trustworthy AI, this balance between the necessity and in the end the cost of developing these products and deploying these products into the field, this is the aspect what I'm advocating for, I would say.
Thank you very much. We move on to the third panelist, and that is Romaric. Please.
Thank you. So indeed, I'm Romaric Redon. Maybe some of you remember I was speaking previously as Airbus. I was managing the AI roadmap for Airbus, but as of today, I don't speak anymore for Airbus. My colleague Sergei will take care. Because I'm now appointed to be the director of operation of an AI research center in Toulouse. I'm still seconded from Airbus there, but in order really to move on, especially to move on the topic of certifiable artificial intelligence, we have created a specific AI research institute in Toulouse, which is called ANITI, where we have something like 300 researchers working from academy, but also we have seconded engineers from various industrial companies. And our main topic is really to build performant and trustworthy artificial intelligence, because performance, we get it. Trust is a challenge for many of what we want to do. And therefore, we are really building this research center. So what I've shown there is our contribution on the Altai referential. In ANITI, we do have technical contributions and also contributions coming more from social science. So you have there, and I will give you a view on that, a mix of stuff which are more technical that maybe will go will be linked to the learning assurance, and some which are more coming from sociologists, psychologists, which are more links to the ethical topic. So first, on looking into the Altai, on the human agency and oversight, we did a quite interesting analysis, and I think we'll iterate a bit with what you did on the way humans are judging machines. It's something we did with, it's César Hidalgo, he's coming from MIT, he came to ANITI for this activity. So the topic was really how we judge machine. And in fact, we have bias. As human, we don't judge humans and machine in the same way. We tend to judge machine on their outcomes, on the outcome which is produced, whereas we judge humans on the intention. And sometimes we forgive a lot to humans. If the intention is good, but the result is maybe not the right one, we tend to forgive for humans, which we don't do for machine. So we have made an analysis on this aspect of the way we judge machine, and as a result, if there is a risk of physical harm, we judge more harshly machine. If there is a risk of discrimination, we judge more harshly humans, because we expect humans should care about discrimination, whereas for machine, somehow we expect maybe machine is not able to really understand discrimination and all of that. So we have a different view on that, and it's quite interesting to learn about that. And there is a book which has been published by César on this topic. Also, then on the topic of oversight, I've seen we've made a long way. We discussed this topic with Guillaume long ago. Initially, in the AI Act, there was a stop button. So in terms of human agency, there was really the requirement of having humans to stop the system with a stop button. Now we are more with an efficient oversight by a natural person, which is what we have. But still, I think it's very important that we also think about oversight not only by human. And here, I mean, there are tools which we have developed, for example, through the DEAL project on out of distribution. I mean, how to build an efficient monitoring system to make sure that the AI is doing what it should do and only what it should do. And we know, I mean, in aviation that fallback solutions is not always human, even if human is often a very good solution, but there are some cases where the fallback solution is also a system. And this is what we work on with developing new AI methods for monitoring. In terms of technical robustness and safety, I mean, we have developed a lot of tools really to improve the robustness, which are linked to formal methods, to the use of, for example, something which is called as one lip stitch network, to use, and this has been developed also in the DEAL project. The point I want to make here is that, and it's linked to what was said by Thomas, is that we have to balance. Because if you really want robustness, you may lose some performance. And especially if you go with this kind of one lip stitch network, they are more robust, but they are less performant. So when you do this list, it looks like you want all of the items, but you will have to make trade-off between all these items because there are some conflicting requirements. So if you want something very robust, potentially it will be less performant. Then covering some topic on transparency. Transparency, definitely we are developing new explainability methods. And especially we try to move to not only development explainability, but also operational explainability using similar methods. So we try to develop concept-based explainability, which means, I will take an example. If you are, and we have a use case, which is, by the way, a public use case about detecting the runway. We build a data set for that. So we want the pilot to be comfortable about the fact that we have detected a runway because we are capable to, for example, to know that we have the concept of what we call the piano, which is this kind of stuff that you have at the beginning of the runway. So if we have well recognized the piano, we know we are not on a motorway. So we want to be able to provide this concept-based explainability to provide more transparency and more explanation to the pilot. In terms of diversity and non-discrimination and fairness, it's quite a complex topic, I want to say, because if you want something fair, you may lose accuracy. So if you want to improve the fairness of your algorithm on not being discriminative, you will do it, but at the cost of losing the potentially some accuracy. So there are some math behind that, especially optimal transport fairness measures, which are the best trade-off between ensuring the best fairness, the best equity, and the best accuracy. So these are stuff which are quite important. And the last topic is also by psychologists. I'm not sure we will have that in autonomous in aviation, but we had it for autonomous driving. We performed and we worked with Jean-François Bonnefond. It was also a collaboration with MIT on the moral machine experiment. And this was really the big survey to analyze the challenges for autonomous driving with questions analyzing, should I rather manage the safety of the driver versus the safety of the pedestrian? On this kind of dilemma where, okay, with scenarios which you don't know what the system should do. And there are ways that psychologists build some survey to really educate, including regulatory bodies, regulatory agency, to really help to find what are the moral norms that should be applied with such dilemma. And yeah, finishing, I'm over the 7 minutes, 1 minute, just a bit. So my conclusion is just beware of these conflicting objectives ahead, because if you want all of them, it's not possible. You have to find the right trade-off between all these objectives.
Thank you, Romaric. Thanks for pointing out some dilemmas and balances and trade-offs that we have here. So we cannot go for the ultimate solution. We will lose something else on the way. I think that will come back in the discussion. Yeah. Thanks a lot. And at the same time, you are the perfect bridge builder from academia to industry, since you are yourself that bridge, you can say. That leaves to the bridge to the next speaker, Fateh from Thales.
So thank you, Jasper. I will start actually this short talk by reminding that from industry perspective, AI is a powerful mean actually to develop advanced automation in some fields where traditional techniques were not so, I would say, performant. So we can mention, but it is not an exhaustive list, developing computer vision systems to do object detection, classification, or natural language processing, and so on. Of course, this powerful automation mean comes with some concerns. And from these concerns, we can actually mention many things that have been somehow introduced in the presentation today. We can mention lack of explainability, we can mention data quality, we can mention generalization capability, we can mention data and concept drifts. From, I would say, use case point of view, sometimes we mention didactic, I would say, use case where we can imagine an AI system that is developed to, I would say, to provide assistance to the cabin crew in order to manage emergency, I would say, evacuation due to, for instance, fire or something like that. And imagine that the database that has been used to train this model has several information, and in particular what is related to the travel class, so economy, business, and first class. And due to spurious correlation during the training, so the priority of the evacuation is linked to this, I would say, traveling class. So you will provide, I would say, some situation that will impact, of course, the ethics rules. We can have also many other, I would say, examples in the aviation industry. There are also some concerns regarding the security. So we can mention deepfakes, which is, I would say, a sophisticated way to a sophisticated attack vector. And maybe an example will be better than long sentences. So I don't know if you can click on the speaker. Yeah. So imagine you are on a plane traveling, and you are, I would say, listening to your favorite music.
Pilot announcement.
Or watching.
Ladies and gentlemen, this is.
Or watching your favorite, I would say, movie, and you have a pilot announcement like this one.
This is your captain speaking. I hope you're having a comfortable flight. We have encountered a minor technical issue with the cabin's temperature regulation system. To address this, we need to redistribute the air circulation throughout the aircraft. I kindly ask all passengers to temporarily move to the back of the plane, where the temperature control is more stable. This will help us manage the situation more effectively and ensure your comfort. Please do not solicit the cabin crew during this process, as they are attending to other important matters. Thank you for your cooperation and understanding. This pilot announcement has been generated by an AI tool to illustrate the risks related to deep fakes.
Okay, so you can see the impact on the load balancing of the aircraft, and also, of course, on the airworthiness. So this is just to illustrate the fact that we will face, I would say, very sophisticated, I would say, attacks like this one, and it is really a concern for the deployment of I would say, AI systems in aviation. What is important to highlight is that today AI ethics is seen as a big umbrella where we could find a lot of things, and in particular, I would say, foundations that are already covered by existing regulations, so like I would say safety and information security. So to be able to implement in an efficient way the ethical requirements that we have in I would say Altai document, or in EASA I would say concept paper, or in future regulation, it is very important to identify what is already covered by existing regulations, standard, etc., and what is not. And when there are areas that are not fully covered by existing regulation or standards, here it is important to have I would say either a risk-based approach or a performance-based approach in order to manage the gaps. The goal will be, of course, to implement or to address this new ethical requirements by design, in order to not consider them just as an add-on. What is also very important is the proportionality. The goal is not to overkill the business. So it's very important to, through this risk-based approach or performance-based approach, to have an implementation of these ethics guidelines that is proportionate to the risk or the performance. And of course, here also trade-offs, and I think that we are quite conscious on that. It is important to maintain a balance between the innovation and these ethical requirements. Thank you.
Thank you very much, Fateh. Like we heard before, Thomas, we can also see you using the words of balancing and weighing and not and trying to avoid duplication. So where we have an inherent risk, of course, we have a lot of regulation already in aviation. So it really needs to add value to this new regulation on AI. Thank you very much. Let's proceed with Sergey from Airbus.
Yeah, thank you very much. I'm very glad to be here. And so the question of this panel is, should aviation embrace ethics? And I will try to, let's look at it from a wider perspective maybe. And I think it will incorporate many things which have been already said and have been mentioned. So first of all, I'm working as part of a cross-divisional initiative, how to implement and apply the EU AI regulation and go beyond it towards AI ethics. And I'm focusing on the ethics part, and I have colleagues focusing on EU AI Act. And we do it not only because, first of all, EASA will implement it for onboard systems and critical systems, but we develop a lot of AI for our internal processes, which are not covered, which will be directly fall under the EU AI Act and regulation. So should we embrace ethics? And I would say that actually aviation industry has always embraced ethics, but it's very uncomfortable for engineers to speak about this soft topic. So it was always spoken about as, well, we focus on the technical aspect and safety, yeah? But if you look in the philosophical literature, of course, safety and human lives and safety are ethical topics. So the systems which we have built are built in a way to protect certain values which are important to us. So ethics has always been done, but instead of speaking about, well, this kind of unweird concept, which is not so clearly can be taken in hands, let's speak about requirements, technical design assurance, failure modes, and so on. So, of course, and it can be measurable. So this is very important. So aviation has always embraced ethics in some sense, but now we are forced to, let's say, take it out of the closet and maybe look at it more directly, because AI is somewhat different, and AI has the dependence on data. So the modern AI types are data dependent. Data is being generated, can be evaluated and used for different means. The public perception is different because people are now using AI in everyday lives and understand what it can do, and new risks are being taken. So somehow we are now have to take it, be more explicit about it. It doesn't mean everything has to be turned on its head. It just means we need to understand in what sense we have already taken care of it and what are the really new risks coming in this area. Also, what I've learned in discussions with many academics is that it's kind of very hard to circumvent and not to do ethics, because many of the technical decisions in AI domain, irrespective whether in aviation or, I don't know, in banking, on many domains, if you just say, well, I'm not considering ethics, I'm considering just a technical solution. By doing technical choices in your pipelines, in your data selection, what kind of algorithm you use, you have taken ethical decisions, by the way, and you are promoting maybe certain values without being aware of it. What kind of values you're promoting and protecting or maybe violating. So you cannot kind of go completely and say, I'm focusing on technical and technology, so maybe somebody else has to take care about ethics. You have already made an ethical decision. So now the question is, okay, what is so special maybe about AI? Well, it's this black box nature, advanced capabilities on decision making, which might come up. Oversight, can we do oversight? And the data, of course. And a lot of questions have been mentioned here, and a lot of questions have been raised also during the previous panels in the questions. People ask questions about it, how we use tools. And I think everything which have been said so far is compatible also with the EASA concept paper, which already takes care of gaps and fills in gaps with the ethical topics. Well, let's look at some examples. So one example, which is not from a critical system, it's what we, and we have, I think Airbus has published it, is that we have now a pilot project, not a pilot. We have an assistant based on generative AI. So based really on, let's say, almost state-of-the-art technology, where we have standard operating instructions, which are instructions for human workers, how to assemble parts during the aircraft assembly. And these are PDF documents. And we assume that the human worker teams know how to build it by heart. But if they have questions, they need to look it up in the PDF document. Instead of a PDF, we now have an assistant. You could imagine a smartphone speaking with you, and the smartphone would provide you direct. You can ask, what should I do the next step? And the smartphone would tell you, okay, the next step in your process is to assemble following part. You can ask, okay, what is the torque value to be applied? And you would get, instead of a table, you would get a torque value to be applied. And when you provide, and it's purely an assistant tool, low level, I mean, it's kind of 1B if you would maybe take EASA on it. So the first question we get when we explain something about it are ethical questions. So most people ask responsibility, who is responsible in case of mistakes, what will happen about data. You have interactions between the users and its systems. So now you have data, how the workers are asking questions and how many, or whether they are not asking questions. And so these are the first questions we get, and we need to find an answer to it. And it's a system which is not even, let's say, as critical as some have been provided here. So one part of the answer is, of course, yeah, the humans are responsible, of course, and we need to make it explicit and to train and have a rigorous validation and testing of the technology we use and provide some assurance on it, maybe. So thinking about ethics, what we are thinking about is that it should be kind of a steering wheel in the development of AI and not a brake. So we don't want to stop AI development. Instead, we want to focus and develop better AI products. Now I'm thinking about AI, for example, in internal tools. And we want to speed up adaptation of it, that people are comfortable using it in their daily work life and that they agree. And by using it extensively, we can reap the benefits. We actually have the business value and we have the value, the purpose, enhanced safety maybe, and so on. So how to do it in practice? How to increase in some sense, implement ethics and take people's opinion into account without creating a process which somehow strangles innovation. Here we are investigating ethics by design process. So there are many proposals which have been released in academia, and we have worked jointly on a white paper with the AI for People Institute, where the idea is to take ethical considerations from the beginning into account. Of course, after taking the legal implications. So if EASA would provide us requirements on products, of course, the first things would be taken into account are the legal and the implications coming from outside. So from UEI Act, from EASA, from any sectorial regulation. But then you look maybe on top, make sure there are no overlaps, but you look also on specific requirements coming from ethics. You maybe do light assessment in the beginning against the UI Act,
And then you have maybe a longer assessment prior to deep development. And there you also take into account early on the possible values of your end users, and to make sure that you anticipate in the design process how the system will be used and how you make sure that the people are comfortable using it and are using it in any way. And we can imagine that it's kind of an extension of something like a risk-based approach, which is more common now in the engineering field, where new type of risk and failure modes have been identified, and you try to proactively address them during development process. And the mitigation actions should be, of course, according to the risk level. So you don't do something very expensive for low risk.
Thank you very much, Sergey, and thanks for reminding us and clarifying that ethics is not a new animal. It has always been around, possibly also historically with the steam machine and so on, if they ever discussed it. We highlight it now because we have this new thing called AI, and then suddenly we take it a bit apart and look at this ethical dimension, but you actually contribute to demystifying a bit. Thank you very much for pinpointing that. And I will let now the word to the final speaker, which is who is Ines from EASA.
Okay, thank you. All right. So more questions than answers, yeah? So I put some topics on the slide that I would like to share with you. It's a bit of maybe some worries or some food for thought. And the first, it has to do with the risk of de-skilling. As I could show to you, so this is a very important topic for the professionals. And in fact, this was based on a case that we designed. So we asked the people, for example, you are an ARTCO and you have an AI-based system interacting with you, helping you to do your job. But more and more, this system will gain autonomy, and basically you are not doing anything but supervising it. Imagine this type of situation. And well, imagine that you'll have a cyber attack situation and the system is not working anymore, and you have to jump and solve the emergency. How would you feel like? And the people would say, no, sorry, I don't think I would be ready to perform. I would be actually, in fact, already de-skilled because I stopped performing my job. It's like us, right? Taking selfies with these things. Like 15 years ago, we would use a camera, right? And if I put the camera on your hands, do you still know how to use it? Maybe, but it will take time, at least for you to say, oh, yeah, I have to, push this button and check the light and the distance and so on and so forth. So this is just a small, joke. But the thing is that the people will not feel prepared to jump into an emergency situation after having this time not performing. So, and we also asked, okay, so what are actually the mitigations for this? And the first thing that occurs to us, it's like training. But people say to us, no, I don't think training will be sufficient, to be enough to have my behavior totally aligned with the needs of the situation in order to perform correctly and successfully. So the risk of de-skilling is there, and we have to tackle it, and to tackle it well. So the second thing that I was bringing to the table today, it's these new competencies, and especially this emotional intelligence. And people say, oh, but this is so far away from technology and so on and so forth. But we also worked on a case where a pilot would have an AI-based system interacting and kind of monitoring the communication, for the purpose of identification miscommunication. And imagine that you are not an English native speaker pilot. Imagine that the pitch of your voice is low, and so on and so forth. And then you have the AI-based system say alert, then 10 minutes after alert or whatever. How does it feel like? Yeah. Well, you feel like insecure, like, am I doing right or wrong? Why is this bothering me? Because it's bothering, It's getting into your emotions. This is bothering me. And at the end of the day, you are tired,
And even you are thinking, well, am I performing wrong? Am I a good or bad professional? So all of these things are linked to emotional intelligence, and it has impact on safety. Yeah, because at the end, if we are not performing well, or if you are putting in cause our own competencies delivering our job, this has impact on safety. So food for thought, we will have to go through this also. And last but not least, it has to do with this topic of responsibility and accountability. For example, imagine on a situation, we also discussed this case, on a maintenance situation where the expert has some sort of a device that could check the sound structure of the aircraft, yeah? And then you have kind of a lightning scheme like red, yellow, green, and just do the evaluation of the structure. At the end, you have just to sign off and say, yeah, it's red, it's green, it's good to go. The structure is sound and safe. And we asked, well, are you ready to sign off? Yeah. Will you take the responsibility? Are you accountable for that? So, and this is important here to be discussed also, because people would say, well, maybe I would accept to sign off the fact that the check was done, but I will not be responsible and I will not be accountable concerning the result of the quality of the check. You know what I mean? So lots of these situations will come up into the aviation world, and we should also tackle. So just food for thought. Some situations will come up. I just gave you some examples that sometimes, of course, they are not so technical, but I think they are pretty human, and we are all human here. Yeah. So food for thought, and that's it. And I think it was like quick, no?
That was very quick, Ines. Thank you very much. And now things are reappearing in different settings with new wordings, but as also some of the panelists have demonstrated, things are coming up again, and they're perhaps not that new. De-skilling reminds me of the ongoing work in ICAO under the heading automation dependency, which is actually the same discussion just for pilots following the Boeing Max accidents. What can a pilot do when there's more and more automation, AI or not, in the cockpit, and how much should he or she do? So things are coming up, and perhaps they are more inherent to aviation safety more in general, and thus not only to AI as a special new technology. All right, thank you very much for the input. Now there's definitely food for thought, also food for questioning. Please use the Slido as much as you please. I will start out taking the liberty of being chair to ask one or two questions to the panel, and everybody can kick in as they want. Now, what do we have to regulate as EASA? And perhaps extending it a bit more, how much should we as regulatory authority take the pen and write down things in hard law, soft law? And how much should we bounce back to industry in the form of industry standards and so on? Fateh, you are co-chairing one of the working groups in EUROK. How much can industry embrace, also in the soft field of ethics, making charters of companies agreeing on a way of working, or how much should EASA do for the entire industry? I think this is an open question. So this is just my question to the panel, and whoever can raise their hand and take the word. Thomas.
So maybe I go first. It's an interesting question, and I would tend to say that the lead for ethical questions which need some answering should lie with an agency which has some task to fulfill this this monitoring, because in the end, in industry, there might be some tendency that earning the money with the profits is also something which is very important. And sometimes it might be the case that ethical questions are not on the same priority. And without implying anything, I think it's a good practice that these things should be addressed by some neutral body. And this could be an agency.
Thank you very much. And now this was also a small provocation, perhaps, to the industry representatives. Let's hear what you say to that.
So maybe I can jump in. So regarding your question, do we need new regulation or more regulation? And I would say who can support this work? So first, what you have seen this morning regarding the presentation of the EU AI Act is that some decisions have already been I would say, taken to I would say, not authorize the usage of AI in some fields. And I think that from this perspective, from this point of view, there is already, I would say, safeguards in the AI Act to deal with this ethical aspect regarding social scoring and all what has been presented this morning. So we have a first level that is already in the EU AI Act. Secondly, what is interesting when we, I would say, ask the question about regulation, new standard, is first to ask the question, is it really new? Or is this problem really a new problem? Or is it, I would say, are we looking to the same problem from different perspectives? So if I take an example regarding the unfair bias, actually, we have seen through the examples that we have discussed that we can have bias in the data, and if it is not managed properly, this bias can lead to a bad model and unintended behavior. But we could have the same if we have a specification. So forget machine learning and AI. If we have a bad specification for a system which I would say introduce some biases, we will have the same. The system will be developed according to the specification, and these biases will be present in the system. So actually, it's questioning how we validate the source of truth, which can be the specification in one hand or the data in other hand, and it questions the capacity to be able to detect these biases in the source of truth. That's true that from specification point of view, we are used to validate the requirements and detect some requirements that are not, I would say, acceptable. For data, it raises more challenges regarding the verification mean, but is it a matter of mean or is it a matter of regulation and new objectives? That's the question, actually.
Thank you very much. Let me just elaborate a bit more. Some are saying that in Europe we have regulation, and in the US, perhaps China, they have innovation. Well, it's perhaps meant as a joke, perhaps not. I hear what you're saying, Fateh, is that yes, some regulation is needed, but be very prudent. Don't go too far. Discipline the pen. Let it not draft too many pages or too deep. That's the message here. Sergey, will you also contribute?
Yeah, I would fully agree to that. I mean, we always hear, it's a very common comment, that's like, okay, we can regulate very much, but what about innovation? And the question would be, what is the goal of innovation which is completely uninhibited? So do we really want to live in the world where it happens? I'm not sure. I'm not the one to give the answer. Everybody can give it. Every person can answer it, but maybe we should ask the question, how can we speed up and create the right systems which we want to have? Concerning the regulation, I think looking at aviation as a system concerning not only machines, tools, but also humans internally, and giving the mandate of EASA to about safety. One can say, okay, what is the domain of safety and how much now with AI? What has exactly the question? What new has come on top of what is already there? And if really something new can be identified which would impact the safety because we have not taken it into account, then maybe a regulation is needed. But still, of course, we need to make it sure that we make it as prudent as possible and be able to innovate, of course, also here. Yeah.
Can I? Sorry. Just a note, because I think regulation can support innovation. Yeah. Because if it's well regulated, all of the people will have the trust enough, will be trust enough to put effort, money, and work on it. So I think regulating brings enhancing will really support and reinforce trust. And I see the investors investing a lot on innovation because they feel safe and they feel trust to put the money on it. That's how I see it.
Thank you, Ines. Peter?
Well, if I may add another dimension, I think it's not only about regulation, it's also about education, right? And this is important to raise the awareness, to teach young engineers and people who are joining the aviation system what the background is. And I think there we have to still to do something. We are very well used to educate in the usual engineering domains, but there are still some things need to be done.
Yeah, exactly. If I may add, I think this is very important that maybe, which I have not mentioned, is that the cultural change in the development field, the developers, AI developers, engineers need also to have some little cultural change to embrace this topic and actively. And I think taking it up in education, and I know there are programs on technology ethics, AI ethics in many universities and TUs and so on, I think it would be really helpful.
Thank you very much. Now, as you can see, the Slido questions are starting to pop up. Let me just give me a second to review. Well, let's take the first one. How can it be verified that the AI is trained without any discrimination form? Who wants to have a word on that?
So there are different methods which could be used to detect bias, which are not expected. I mean, bias are the essence of machine learning. So you learn from correlation, which you find in the data, and usually the discrimination is not coming from the algorithm itself, but is coming from the fact that in your data set, you represent the world as it is, whereas the world as it is might embrace some discrimination. So you expect to have something which is not discriminative, but if you rely on existing data, you will project the world as it is with the discrimination that goes with it. So the approach is that you have methods to really identify bias in your data set so that you are aware of this bias and potentially you can correct this bias. I was mentioning optimal transport, which is one of these methods, which will help you to correct your data set. So to make sure, for example, that you will have the same answers for male or female, but it could be also other kind of discrimination that you want to avoid. So you will have to define the different variable where you want to make sure that you will have similar answers. And then you can use such methods to really recalibrate your model somehow to make it, to ensure that you have optimal fairness with your algorithm. So that's at least a technical answer, but everything is not linked to technology also on this topic.
Thank you very much. Any other, Fatih and Thomas?
Yeah, maybe to complement what Romaric said, I think a good approach also is to not consider the data as the unique source of truth, and to, let's say, reconciliate the data with the initial functional intent. So in the initial functional intent, we expect that discrimination or any other, I would say, negative bias will not be part of the intended function. And by, I would say, defining a link between this initial intent and the data you collect or the data you generate, you can first ensure that your training data will be, I would say, will have less biases. And also regarding the verification, if you verify your end product or your model against this initial functional intent, you will have also some means in order to detect, I would say, some undesired biases that have been introduced during the development. So data is not the unique source of truth. The source of truth is what is intended initially by, I would say, the developer, the designer, and also I would say, the customer or the stakeholders that are at the very beginning of the process.
Thanks, Thomas.
Yeah, so I would like to maybe come a bit to the process perspective on this. So with the example I mentioned for eye tracking and eye tracking with regard to detect if an operator is tired, we worked on this in our project Loki, where we are developing a AI assistant for an air traffic controller. And there we encountered this situation that we came up with, well, okay, different eye colors are being detected in a different accuracy. And this was really surprising to us because, well, we expected this is state-of-the-art technology and we just use it and use it as training data. And now, having the awareness you also mentioned before for this implications on these ethical topics, then I think in the process level, it is something which can be covered in an operational design domain for an AI system. So you could really state that the different eye colors should be detected in a similar accuracy. And then in the end, it can be verified with the different scenarios you could lay out for testing it. And so having the awareness and combining it with a decent process is another perspective to look at it, I would say.
Thank you very much. Looking at the two next questions on the slide, they address in various ways in which perspective the ethics should be seen. First, and let's separate them, but I think they are somehow connected. Can you give an example of an ethical problem in aerospace that is not first an engineering problem and wouldn't be solved by solving the engineering first? I think you have touched it already, but any additional comments to this?
Yeah, so as a matter of fact, the very example I was mentioning was at least a surprise to us. So with the expectation that basic task like the eye tracking, which would be so relevant for any AI assistant in the end, it was surprising to see how at the starting point you have these implications. And obviously you could state, well, okay, if the eye tracking system would be just better, then you wouldn't have these implications. But yeah, also with the use cases we discussed before, I think many engineers tend to take these systems you can buy for granted and use it as a baseline for further developments. And so it is, at least for us, an example where it was really surprising what consequences there are in the long run for developing the system.
Thank you. Peter?
Yeah, taking up that question, I think there are two elements. One is you need to differentiate what are concerns regarding the automation itself and what is really AI add to that. And I think sometimes these two elements are really mixed. And we can also, with a simple automation system, enter into discrimination and ethics issues. And secondly, the question is which function, for example, could not be solved by engineering? So the first of these questions, considering, for example, the measuring of vital parameters on board the aircraft cockpit, so monitoring the crew. This can, of course, increase safety, but on the other hand, the data can be misused. And then you might consider to have a bulletproof way of processing the data and not releasing them to any other authorities, whatever. But I think this is not really a technical issue. It could not be overcome by only technical means.
Thanks a lot. I think let's take on board the following question, which is closely related. As this concerns AI systems, does this mean systems without AI don't have to consider ethics? A bit provocative. What is asked here is how specific is this to AI, or should it be handled elsewhere? You can also ask in the regulatory framework or in the way we deal with the technology and specifications. Any additional comments from the panel?
Well, first of all, many of the laws we have are based on ethical principles first. So I think many of problems which we have with any system are already, of course, have been taken into account by laws we have because they protect us on the regulatory level. So AI, why AI now? Because AI brings something to the table which might have not been regulated before in any way before the EU AI Act. So there are possible scenarios. And because we have seen examples of system, I think there is one example of systems which have not been regulated and which now are there and we cannot take them back. And it's usually connected to social networks which we have and the impact of social networks which have changed many industries, all of advertisement and publisher and so on. You cannot take them away, but the impact which they have and the risks which have been risen with them are such that this society and also, I'm not sure, the companies have not anticipated them. So there is an example of this already where regulation was not fast enough. So, and then we speak about ethics. But of course, we have to consider it also for other systems, but the regulation was fast and it's covered, I would say.
Thanks a lot. We can move to the next one, actually to EASA. Are we moving towards autonomous ground ops? Where does this fit under the regulatory framework? Guillaume, you step in, please.
Yeah, maybe I will step in the panel. Sorry about that. No, I would take this question a bit more like a generic topic that, as we mentioned, we are really dealing with AI at large. Any domain impacted will benefit of it. How will we move towards ground ops and, let's say, within aerodromes framework and regulatory framework is really based on the rulemaking task. We will see exactly the level of proportionality, the level also of safety assessment we need, in fact, to inject to understand is it a safety-related application or not, etc. So I think it doesn't escape the big picture that we drew this morning, and same for ethics. So I didn't see a specific ethics point in this one. That's why I'm kind of jumping in to you.
Yes, right. But now it had 7 likes, so somebody was. So we took it in as an exception. All right. I think also we should leave room for questions from the floor. We have at least a microphone here. Please raise your hand if you have a question. That's where you want to elaborate a bit more than you could do on the Slido. We have one here. Please. From the FAE. Oh, yeah, you have the mic.
Yeah. I have a question not from the FAA point of view, but from a personal point of view as an academic professor in my previous life. Just imagine I was teaching a class. This is human learning now, not machine learning. I was teaching a class and I decided to write an exam to test my students. After giving out the exam, I discovered that people with blue eyes pass it with higher rate than people with black eyes. Do I have to do something to make sure that both groups have equal performance by revising my exam? Or do I set the minimum performance, like 60%, would constitute sufficient performance?
All right. So now beware what the answer may be here. I'm very eager to hear that.
Can I ask just one question? Will be 60% of performance enough?
That's normally the standard that we have in the US university.
Yeah, okay, but if we apply this to aviation, yeah, what is the level of safety that we want to embrace and to
No,
assure?
I was asking in the context of human learning.
Yeah, and more, and could there be an unknown discrimination that's your theme here? So, Mike.
No, for me, just a general comment. It's a good testimony of expectations that might be different from humans to AI. I mean, as soon as you start to have an AI system, you will probably raise new requirements in terms of fairness, which you may not raise if a human is doing the job. And it raises a lot of questions, because it means ourselves, we have bias towards what we accept from, and that's a bit the story about the way you judge a machine. I mean, a professor, we might not ask, and this happens at the moment because professors are starting to use Gen AI also in assessing some of the results. And then the level of scrutiny in what they will get from the AI system is higher than probably what they were doing as human beings. So I have not a direct answer, unfortunately, but it shows that, yeah, we would expect different things. And especially, I mean, Ines' comment was very interesting, linked to critical systems. Is also linked to critical system. Human performance is often not enough, so we have also to go beyond. I mean, and to make sure we regulate for the right level for safety. But yeah, this is what I can say.
If I may,
Yes,
what does it mean? You could either lower the standards for ethics at machine learning level, or you could increase the standards of ethics for the human being. So those two ways I would see, and so to decide.
Can I be more specific? Yeah. Let's consider students in medical school. They have to pass some sort of licensing board. Would we consider lowering the requirements so that everybody can pass? Blue-eyed people can pass with the same rate? Or do you feel comfortable with establishing minimum performance for medical doctors so that they can treat you?
Yeah, I think the question is very much situational dependent, and we know that ethical values or principles can be in conflict. One being safety for medical profession, and the other being fairness. So there we would ask the question, what is the right measure of fairness, and what do we mean by fairness in this situation? And maybe in this situation we would decide explicitly stating that. So the ethical part would be to state explicitly that we actually in this situation care very much about safety and the future doctors. And we have to admit and embrace then maybe unfairness on some particular properties, maybe not in some others. So it's very much case dependent. And that is true that there is always a trade-off. So even going back to AI and even in the AI development, there are examples, and we know examples of big companies where focus on some particular aspect of fairness might have lowered the actual factfulness, which is not desired for the system. So I think the trade-offs have to be clearly stated, and there are trade-offs there, and it has to be made explicit which decision has been taken and what is the system doing.
Thank you. Let me move on to a slide of question with 7 likes. Actually, Thomas, it's for you.
Thierry, so she can raise it if you want. She's in the audience.
Sorry?
Thierry is in the audience.
Okay, please.
Okay, so I think both of the questions are related. So the one voted up to 7 is related to the first one about the data privacy and data protection. So at this point, I was wondering if the existing processes related to data management, for example, the anonymization for some use cases, do you think that this can be enough to cover some ethics statements? And which relates to the second one, which is more general for the ethics. In fact, do you think that on the W-shaped learning process, so this can be a question for the EASA also, do you think that there is already most of the ethics requirements are covered? So if people will follow the statements on this process, can have, let's say, a more ethical AI, or there is even more statements to be defined, or some most important things are missing?
Yeah, so maybe I focus my answer on the second part of the question. I would certainly hope and to a certain degree expect that the existing W gives already quite some answers, because the complexity is quite high as it is. And I would say that with regard to the ethical requirements, the challenge is to translate them into technical requirements. And these technical requirements need to be, traced or worked through the W. So starting with a operational design domain, for example, with regard to eye tracking, that the correct colors are being trained, and then in the end verified with correct scenarios to prove this. And so the challenge is not to make it more complex, hopefully, but really to find good solutions for translating the ethical requirements and maybe also sometimes dilemmas into technical topics and requirements.
Thank you. Omar? On my side, I will take more the challenge is that anonymization is not always enough. I mean, it has been proven and in many studies due to the beauty in bracket of machine learning. I mean, sometimes you can recover information even having anonymized the data. So anonymize the data is for sure the first good step. After there is research on privacy preserving machine learning technologies, such as one of them which is quite common is differential privacy. But the challenge, once again, I mean, if you use that differential privacy, you will lose a bit of accuracy. So once again, that's a bit of this interesting conflict where, okay, you're improving the aspect of the privacy because you will be stronger, and it will be even more difficult to come back to disclose any privacy information because in fact you lose accuracy. So that's the kind of interesting trade-off. So
maybe this is a challenging question, but do you think at the same case when we will have a use case which is safety critical, but also there is some ethics statements that should be respected? In your opinion, which of these two criteria should be considered most important than the other? I think the performance or the ethics, in fact.
I think we spoke about this a bit. It's a bit of a trade-off of what should be your priority. Of course, you have to create as much as a balance as possible. But I mean, when you are talking about safety and people's lives, then I think you have a clear answer there, no? So, but tough decisions for sure.
I think we have been going around some of the dilemmas which several panel members have highlighted, where we need to find a way forward. Perhaps we need to segment, as I believe it was you, Thomas, mentioning, into different degrees, various degrees of safety criticality, because as you say, Ines, when we come to safety, I mean, there's not much we want to trade off here, really. But in many other aspects of what we're doing and how we're engineering it, we may have to take some conscious, some informed decisions on what to do whether we have one objective, we want to prioritize more than the other objective. So how to regulate us through this, it's not very clear to me. But again, back to my preferred question before, is that something that industry also can take on board some of these questions, and presenting a way forward in the form of industry standard or charter or white paper or whatever form it can take. So to advise the whole industry, but also the authorities on a professional and decent way to go forward.
Maybe to comment on that, it would go back to what you mentioned before with regard to the different levels and does it match to other industries? And I think there also lies part of the answer or part of the comment, because aviation does not stand alone with regard to these dilemmas and these problems. And I think it really makes sense to also look out to other safety critical domains like medical applications, rail or automotive, and really to try to find some common ground between these safety critical industries.
Thank you. Yeah, and by the way, as soon as you touch automotive, we are multiplying with factor 10 in terms of size. So that's well, in literal sense, a vehicle that you can jump into and follow. It's difficult when you are a sector, automotive or aviation or maritime or whatever, because we're organized in silos. So we need to grasp some common ground, and that's what ideally the AI EU Act is trying to grasp. What is covering everything. Now, what remains for us to discuss here is what do we need to add for a safety critical industry like ours? And can we find inspiration? That's how I hear you, Thomas, from similar sectors, nuclear, automotive, or whatever.
I mean, I can only agree with that. I can say that inside NET, we do work with railway, with automotive, with nuclear, and we find a lot of stuff in common when we are building the trustworthy AI methods, because the trustworthy AI methods, we share really the same objective. And we had, by the way, we defined, for example, a use case which is on detecting a runway. But we have people from automotive working on this use case as well as railway, because they're learning from this use case in terms of explainability method, in terms of robustness method, in terms of out of distribution, conformity, conform prediction. So, I mean, all these kind of low level, we really can work together across industry sectors. And also, I want to say, with the work EASA is doing, others are also looking a lot at what we produce to answer objectives from EASA. When I say others, from automotive, from railway, because also EASA has invested quite a lot into the topic, maybe more than some of their agencies. So they are really learning, but also contributing to what we do. And I think it's quite a good approach.
Thank you very much. Time for the last question. Well, in fact, a bunch of questions because they're going your way, Ines. So if you can take care of some of them, I will not spend time reading them.
Sure, let's go for it. So, is keeping human autonomy a competency? Well, in the sense that a human should be autonomous, should have the ability to be autonomous when interacting with AI-based system, not doing over-reliance to the system. Because you can imagine interacting with AI-based system systematically, yeah? And then you
maybe we'll have the risk to over-rely on it. So it's important that you still retain the competence to be autonomous, to judge, to evaluate, and to be able to decide. In this sense, being autonomous, it's a competence, yes. Is the skilling a problem? Society replaced skills of rural agriculture by industrial means. Yeah, isn't okay. So I think it is, especially when we have a high risk situation or an emergency situation. Just think about COVID. Yeah, maybe at that time you thought, I have a garden at home. Maybe I will try to do some carrots, tomatoes, and potatoes. I'm just kidding, right? But do you understand the logic? If you have a high risk situation, very high level of criticality, and it's an emergency situation, the risk of de-skilling there could be a problem, a high problem. So yes, I think the risk of de-skilling is important to be tackled. What more?
And the last one.
Do you think that possible option for avoiding de-skilling is to revisit the process related to the training, simulation, or urgencies? Yes, sure, of course. I'm not saying that training should not be in place. I'm super fan of training and competency development, as you can imagine. But I think that might be not sufficient, just this. Of course, practical training, simulators for sure, yes. But I would say that putting the people on the situation, doing really the actual job once in a while, or once per day, or 2 times per day, just to be sure that the people still perform, I think it will be a must.
Thank you very much, Ines. I think we're coming to the end of the Q&A session, taking a view on my watch. So we have spent some time together trying to come around this for at least for perhaps an engineering mindset, a bit fluffy thing, and can be a bit difficult to grasp. However, we have heard many interesting perspectives on how to attack or how to address ethics, putting it in a larger perspective, which many of you have done, also highlighting the balances and trade-offs we have in this area. And thank you very much also to the floor for raising a lot of very relevant questions, which we heard some interesting response to from the panel side. So thank you very much, first and foremost, to the panel. Thank you to all of us. Thank you. Bye.
Maybe before leaving our panelists, we have some presents actually for all the panelists. We didn't share them before, but Giovanni will do for his panel, and Ines for the one that was managed by Jesper. Thank you very much. And Kirsty, if you can come forward, indeed, thank you for bringing that. You did well. We have also some nice present for you, Ines, especially, and for you, René, our let's say representative of the 20% that were in the survey. But thank you so much for all the great presentations. Thank you.
You know, to work on this agency in the AI program with Guillaume, we have to have actually 2 criteria. Yeah, being a psychologist and having been born on the 40th of January, right, René? Yeah. Okay, dinner then.
Wait. Before the dinner, we have first the wrap up, and then we will put the slide for the dinner location. So thanks again to all speakers, panelists, interaction of the public, people watching online and staying awake with us, also from far away in the world. So very, very appreciated. And I give the floor to Alain Leroy, our chief engineer, EASA chief engineer, for the closing wrap up, I would say, on perspectives. Let me.
Good. Well, thank you very much. I think you will all agree with me that was a very intense day, full of very useful pseudo-philosophical discussions. I really have to say I enjoyed the last few hours because it was a mix of technique and philosophical societal discussion. So we are really in the heart of today's society transformation. So back to this morning session, Guillaume and the audience. I think something which is striking to me, looking at the previous years, we were talking about what has to be done, the roadmap, what is under construction, what will come, and so forth. I think we've gone through a major step, major achievements, thanks to all of you, because it is really what I feel, and if you disagree, let me know. It's a year of consolidation. I would say a lot of material has been published. The concept paper issued 2. The roadmap is now very secured. I was also impressed by the use cases in aviation. We have a lot of practical cases. Maybe I would say from a management perspective too many, because it keeps people very busy in the agency, but at least we learn from it. And those use cases are really the foundation to confirm what we think, or what we should not think, maybe, depending on the discussion. Because I liked one of the last panelist statement, ethics should not be a brake, but a steering wheel for AI. So AI ethics is really something we have to bear in mind, and those use cases, as we saw, are touching every day on it. So really, really a big thanks to all of you for all what has been done. But I'd like to come back on this consolidation. There was also a newcomer in the room, or it was a bit there last year, but the AI Act. And thanks to the Commission presentation this morning, you saw how we work as part of the full EU system. We are not left alone. Guillaume's team, the agency, we are ensuring on a daily basis that we are compatible, or I would even say consistent, compatible is not enough, that we are consistent with the AI Act. And I encourage you to review or to reconsider the slide you have, where on top you have the AI Act, and then the various pillars with our regulatory development, the part AI you have in mind, and most important, the standardization bodies, EuroCAE, etc. Because it shows how we have to be organized in Europe. And this is really a challenge, how to ensure consistency with the EU society and expectation, which are expressed in the AI Act, without jeopardizing aviation safety. So a big thank to all of you. That's the area of consolidation. And of course, if we consolidate, we are an agency, regulations, rulemaking. So as you saw, the rulemaking 742 is on the way towards where it should. And I would like to come back to this evening discussion. Again, the steering wheel, not the brake. So we have to make sure, Guillaume, I will say Guillaume, all of us, that that in our further development with industry, with our bilateral partners, we have to make sure that we keep the ethic assessment permanently in mind, because this will allow us to have the right objectives and the right proportionality. I also, sorry to quote most of what was said, I had no time to prepare a long speech, so I'm improvising. So I liked one statement, it is always a matter of trade-off. If we want to do it all, it will not fly. So we have to have this kind of proportionality, the trade-offs, how to satisfy the overall safety expectations without being not consistent with the AI Act and the society expectation. Alors, a very important word. Now, we have a special guest, our FAA colleague. So thank you very much for visiting the agency today. And it was very nice to have a first introduction on your thought, how you see the work from an FAA perspective on AI, on automation, and how you want to make best use of existing standards and regulations today. So it's a point where, in my humble opinion, I'm not an expert, I'm a poor pilot and a manager, so I'm not an expert in AI. I'm learning from Guillaume every day. But for us, it is a point where, how could I say, it is very similar to what we did at the very beginning with the use cases. We had IPCs, Innovation Partnership with Industry, to develop the famous learning assurance process. And I think you are following the same path. And I would like also to quote a very important event, which happened last month. We are in July. The FAA EASA annual conference. Our two executives highlighted very, very clearly the need to have a single approach to safety. Safety is universal. So normally we should really do our best to harmonize, to work together, because we have to promote this common mindset. And I think it is on the way. So you are welcome to be with us today. You are welcome to share your thoughts. And of course, we will share ours with you. Well, there might be sometimes some small discrepancies. It's normal. We have to fix them. And at the end of the day, industry will be the safeguard and will ensure that we have done it properly. So that's in a nutshell what I had taken from the day. Did I forget something, Guillaume? Except that I don't want to go back through your panel, Jesper, because this was fascinating. The link between the technique, the society, the ethical considerations, and how to make sure that, back to where is Ines, but here, your best preferred topic. As a pilot, de-skilling is for me, I am an instructor, and de-skilling is really something which is on top of my own list. So I can understand what you mean, what we mean by that, and the performance-based, the competence-based aspect, again, in the automation development is very important to us. So I don't want to keep you busy for too long because it has been a long day and you have now a nice evening waiting for you. I think it's not raining any longer, so you may have a chance, no umbrella. So thank you all. It was really very instructive, very, very enlightening. And I like really this kind of cooperative event. Thank you to the panelists. Thank you, Guillaume and the team. And thanks to all of the audience and online for supporting us today. And I wish you a nice evening. Thank you very much.
Thank you very much to all of you. The last slide of the day to remind where we gather at 7 o'clock at the Gaffel am Dome, which is a brewery on the other side of the main station. You go through the main station, straight ahead, and you will fall under, let's say, pass under a kind of a passage, and there you will enter a brewery called Gaffel am Dome. You just ask. Normally, we will be probably in the cellar like last time, and a private area where we can really continue the discussion. So thanks again for coming and for being with us. And yes, let's continue the discussion. Safe travel to everyone traveling back, unfortunately today, but still tomorrow we have a program, MLIP Day at the EASA AI Days, the final dissemination event, I would say, from the perspective of EASA and the consortium. So stay numerous in the room, and see you very soon at the Gaffel am Dome. Thank you.